Good morning, Fatima.
Hey, good morning, Amber.
I don't know if you want to go ahead and share here. I'll share my screen. If you want to go ahead and share your screen or not with the opening slide, or I just changed my name to Zeek Project Training will start at 8 a.m. PT. So that's what kind of shows if you're not sharing your screen or have your camera on. So that way when people see the live stream on YouTube, they know kind of what's happening. So I don't know if you want to do that as well, or let me see.
Sure, I can share my screen just for the holder for next 30 minutes.
Well, if you share your screen and you try to go somewhere like you're doing something else in the background, it's going to stop sharing.
Okay.
So you might want to, you want me to change your name to the same thing I put mine to? Just hold on. That
okay.
way.
Let me change my name.
Here, I can do it right quick for you. Hold on. I can do it.
Oh, perfect. Thanks.
There we go. That way, if you don't want to share your screen, because we're live right now, so we're out to the whole world, so which is fine. But if you don't want to share your screen, then you can just stop your video and it'll say Zeek Project Training will start at 8 a.m. And you can go from there.
Sounds good. So let's well, I'm working on something, so how about we yeah,
I was just going to say just stop your video and it'll just say Zeek Project Training will. Here, let me stop mine.
Gotcha.
Well, I changed your name, but does it say that your name has changed?
Yeah, I can see it says now Zeek Project Training will start at.
Okay, cool.
So it's good to go.
Cool. All right. And there's that. Okay. Well, I've got to do one more thing. So I'm going to step away for 3 minutes and then I'll be right back. And then once things start, I will probably make you host just in case something happens to my internet or whatever, there's a backup. You know what I mean? There's a,
yeah.
So does that make sense?
Yeah.
Cool. All right. Well, I'm going to mute myself and we will reconvene in probably about 30 minutes or so. And then I'll introduce you and Keith and y'all can go from there.
All righty. Sounds good.
Cool. Oh, do you want me to share any slides or anything in the channel? In the Slack channel?
I think we are good, but if you want a copy of the slides, I can share it with you over.
Just send it to me after the training.
Okay, sounds good.
Cool. All right, cool. I will see you in a few minutes then.
All righty. Thanks, Amber.
Bye. Good morning and welcome to ZeekWeek. We'll be starting the Zeek project training in about a minute. So welcome. If you have any questions, please ask in the Slack channel, which is hashtag ZW21-Zeek-project-training. If you are watching this video, you should either be in the channel already or you got a calendar invite. So let me know, ping me on Slack. I'm AK Grainer, and we will get started in just a few. Fatima, are you and Keith there?
Hey, Amber, I'm here. I'm just getting the Zoom link to Keith.
Oh, I thought I added him.
Just give me a few. Sorry about that.
It's all right.
Yeah, I just sent him the link, so he should be joining.
All right. Once he joins, I will introduce the two of you, and then I will turn it over to you all. And you can change your name back now if you'd like.
Sure.
All right. All right. Welcome, everyone, to Zeek Week 2021. Unfortunately, or fortunately, we're having to be virtual this year as last year. And hopefully next year we'll all be able to gather together. But today we have Fatima and Keith, which many of you probably are already familiar with if you've been in the Zeek project anytime at all. Both Fatima and Keith are members of the Zeek LT. They're longtime contributing members of the Zeek project, and each of them like I believe Keith still works at Indiana University. Fatima used to work at Delaware, University of Delaware, and now Fatima, you're at ESNet now, right? Or yeah, you're at ESNet now. So you'll see these folks in and around the community if you spend any time at all, you know, in our Slack channels, on our mailing lists, or any other event that we have. And today we're fortunate enough to have them doing the Intro to Zeek training. Both of them are no strangers to this training. If you attended last year, or even the year before, you probably are familiar with Keith's training. And if you've attended any of the virtual training events that Fatima does, you're probably familiar with her teaching style as well. And so with that, I will turn the two of them over to you all, and have a great training. And if you need anything, you can ping me on Slack at AK Grainer, and we'll get you taken care of. The floor is yours, guys.
Thank you very much, Amber. Welcome, everyone. Please note that there is a Slack channel specific to this training, and that is the best place to ask questions. We'll try to answer them. We've got several great folks that have offered to join and assist with answering questions as well. So it will not just be Fatima and I. Let me share my screen here quickly, and we will get moving forward. Fatima, can you give me a thumbs up if that looks good?
That looks awesome.
Perfect. Okay, so let's get going. As Amber noted, I am Keith Lehigh. I am currently the Interim Chief Information Security Officer at Indiana University, and I also manage the security engineering team there. I've been running Zeek on a large EDU network here at IU for over 10 years, and I've been a Zeek LT member for a number of years. Fatima, would you like to introduce yourself?
Sure. Hi, everyone. I'm Fatima Banathwala. I have been using Zeek for past 6 years now, and I was a security engineer back at University of Delaware, and I recently moved to California a year and a half ago, last year in Feb, and I am now currently a security engineer at ESNet. I have completed 1.5 years, and when I came, the COVID hit and the pandemic hit. So all of a sudden, after I came to California, there was like all lockdown. So people were like, "You brought it with you," and I was like, "No, I didn't bring it with me." And I want to be on site and work on site, but it is what it is now, the new norm. And also, I'm the member of a Zeek LT team, and I currently lead Zeek's training subgroup as well. So if people are not familiar with it, we always we have bi-weekly meeting on every Friday, 8 a.m. Pacific time for Zeek training subgroup. And feel free to join in. And we have a mailing list as well for training subgroup. So if I will share the information on the training Slack channel as well. So welcome, everyone.
Excellent. Thank you. Okay, so the goals for today, by the end of this, you should be able to run Zeek on the command line. You should understand how to configure Zeek. We'll be going over some basic functions. You'll be familiar with the file system layout, so you can figure out where scripts live, be able to look at them. We'll talk a little bit about how to process Zeek logs using traditional Unix command line tools. We'll get into why that's useful and important when we get to that section. We'll talk about performing some basic customization of Zeek. We'll interact with some common frameworks that you're most likely to see as a novice. And then finally, if we have time, we'll talk a little bit about the cluster configuration and what that looks like. We've left that to the end because we're really trying to focus on what you can do running Zeek at the command line. Oh. All right, a couple quick housekeeping notes. There is a link in the slides there for a Docker how-to. We are using Docker this year. It's a lot easier to get this running on a variety of operating systems. Couple quick notes there. If you haven't already done so, you'll want to grab that Docker image. The container image is just Docker pull security Zeek training 2021. And then the last note is inside of that container, there is a directory with training resources. This includes some scripts that we are going to be working with, as well as a number of packet captures that we'll be running for exercises and as part of the demos. And then last but not least, we're focused on the 4.03 version release, and you can find the official documentation for that at docs.zeek.org/en/v4.03. I think maybe if you go to docs.zeek.org, it may land you on that automatically. If not, there's a nice little drop-down menu to get you to the right version. So diving right in, who uses Zeek? There's a number of different people in the information security world and outside of it that make use of Zeek. One of the first is people who are doing malware research. Zeek is exceptionally handy for getting a PCAP that has some malware in it or has some network activity related to malware. One of the best things you can do is just run Zeek with no options, and you immediately get information about connections that are made, common protocols that are going to show up. You can immediately see what's going on there. There's also the ability to extract files out of Zeek. So if some piece of malware was passed over the wire in a plain text protocol, Zeek may be able to pull that file out for you. Then you could run it in a sandbox. You could inspect that malware with other tools. So exceptionally handy for that. Probably the original use of Zeek has been working with network defenders, primarily blue teams. Zeek will be found in all kinds of sectors. It's got a long and storied history in the EDU sector. Over the last half decade to a decade, we've started to see a lot more usage outside of EDU. It's commonly used in .gov space and certainly in the commercial world. So learning Zeek skills is a really great thing to bolster your resume. You'll find that it's used in a lot of places. Those network defenders use Zeek for pretty much all of the security operations functions. You can use it for doing forensics. Fatima and I both have worked many different incidents that have been solved primarily from the data that we've been able to pull out of Zeek. So incident happens, all of us pivot to our Zeek logs first to figure out what happened. How did the incident, how did the system get compromised? What did the attackers do once they had access to the resource? Additionally, Zeek is great for just traditional monitoring. You can write scripts or use packages or scripts that exist already to raise notices and be able to do detection. And then you can do generalized monitoring of your network, using that for understanding where your resources are, what people are doing interacting with it. Additionally, Zeek is great for doing network research. It doesn't just have to be focused on solving information security problems. You can use Zeek to investigate behaviors of networks in general. And then last but not least, there are a bunch of different commercial entities who are now building Zeek into their products. Probably the most well-known is Corelight, but there are a number of other private companies that see value in building Zeek into their product and then selling that to their customers. So what is Zeek? At this point, we like to refer to this as the Zeek platform. Zeek has been around for now over 25 years. The first lines of code were actually written in 1995 by Vern Paxson. Beyond, once, after that sort of took off, had a little bit of a slow uptake. Initially, for many years, Zeek was pretty much used primarily in academia. When I first started attending, when it was called BroCon, pretty much the entire attendee audience were all people from higher ed institutions or research institutions. Probably about the late aughts is when we started to see more commercial related, private sector folks showing up. And over the last 5 years, there has really been a shift. A lot of the attendees at ZeekWeek now are people in the private sector or people in the government space. There's still plenty of folks in the EDU world that use it, but you can see Zeek has really started to expand outward and spread around the world. In addition to being software, Zeek is also a domain-specific network monitoring language. So it gets a little bit confusing at times because sometimes we're talking about the language, sometimes we're referring to the actual product itself. Although it's a domain-specific language, it's fairly easy to pick up. There are a lot of tutorials out there. Some of you may be attending Ashish's training this afternoon. That will be a wonderful introduction to the scripting language. I think if you've got a little bit of programming knowledge in almost any programming language, you'll be able to start to figure out how to write Zeek scripts. we're really not going to focus on writing scripts at all here. We have a few scripts that you'll interact with as part of the exercises, but those will be simply having you edit existing scripts to be able to create, cause different behavior in Zeek. Again, big plug for Ashis's training. There are lots of other resources out there about getting interested in the language as well, and I encourage you to dive into that. It'll really extend what you can do with Zeek. One key concept to keep in mind with Zeek is that it strives to be, by default, a policy-neutral tool. So Zeek is going to just kind of give you the ground truth of what's happening on your network. The developers of Zeek strive to give a lot of high confidence to any log data that is logged. A common place where this might throw people off is Zeek may not log a file name if it doesn't trust the source of the file name. So if it's just a file name that's thrown in an HTTP header, there's not as much confidence to that, and so that may not get logged. Again, the idea is, we want this product to have high confidence and high certainty in whatever it logs. The policy neutral thing starts to trip you up a little bit if you've got, say, a bunch of history with Snort or Suricata. Those are tools that generally are focused more around primarily identifying malicious activity or policy violating activity on your network. Suricata certainly has the ability to do some of the bulk general logging that Zeek does these days, but again, those tools are usually really more focused on helping you find bad things on your network. Zeek has a much more broad and neutral approach and just tries to show you what's going on your network. It's then up to you to interpret the data or use some of the existing packages and scripts to identify malicious activity. Part of what that policy neutral approach really helps with is you may not know what you need to log until after an incident has happened. So you may find, boy, I really wish that we had, in Suricata, you see an event fire and then you may not know what happened after it. Whereas again, with Zeek, you can use that Suricata alert as a starting point, and then Zeek helps you understand what happened before, during, and after that alert fired. And I will note, I kind of can't see questions that pop up in Slack, so I'll rely a little bit on Fatima to highlight if someone's asking a question about what I'm saying here. I encourage all of you to ask questions. Let me know if I'm speaking a little too quickly or if I brushed over something that you want a little more info about. So let's talk a little bit here about the Zeek architecture. We kind of sometimes refer to this as the triple cheeseburger logo or graphic. So at the very bottom of this graphic, you've got a network that you should be getting packets from. It may be a packet capture that you or someone else has grabbed. You may be getting packets from a passive optical tap or a mirror port off of a router. You got to have some way to start feeding packets to Zeek. Very quick sidebar. You can run Zeek without actually feeding it any packets, and you could do all kinds of things because, again, it's a fairly powerful language, but I think 99% of the time when people are running Zeek, they're feeding packets to it from either an offline or an active source. Those packets are fed up into the event engine, and this is kind of where the protocol decoding happens. The event engine is an important concept in Zeek. Zeek is an event-driven system. So as it decodes packets and processes them, it will raise events about things that it observes. It may be things as simple as, I just saw the start of a new connection. There's a new connection event in Zeek that fires every time it sees a new connection, the first packet in a connection. It may raise an event that is connection established. So with TCP, once it sees that three-way handshake, it will raise an event to tell you, hey, I just saw this connection successfully completed the initial setup. Then there are protocol-specific instances, events that happen. Things like seeing an SSH session happen, seeing an FTP session happen, activities that happen within HTTP, TLS certificate negotiation. All of these things are events that fire off. Those events then can be managed and interacted with in Zeek scripts. And Zeek scripts are kind of what you can think of as where the analysis logic all happens within Zeek. Additionally, the scripts and sort of the output, logs and notifications all together function as what you might think of as the user interface of Zeek. This is where you as users are going to start interacting with it. We'll poke around at some scripts later, give you a little bit of a rough overview of what common areas of scripts are, and Fatima will be doing a walkthrough of the file system, so you'll be able to see where scripts live, and you'll get some time to poke around and look at scripts and get a little sense of what's going on there. So again, out of these scripts, you're generally going to get logs, and then you have the ability to raise notices, and we'll get into that in a little bit. But this is kind of a very quick overview of what the Zeek architecture looks like. You can dive in a lot more. There's a lot more detail to it, but we're kind of trying to stay at the 10,000 foot level for this audience. So I mentioned those analyzers. Zeek has a wealth of analyzers that come out of the box. You already have pretty much all of these analyzers are available to you in the installation that we did. The exception is Spicy at the bottom of the slide. I'll get to that in a moment. Among protocol analyzers, there's ones that that many of you probably interact with and are familiar with. Things like HTTP, SSL, DNS. There's a number of authentication-oriented analyzers. There's a good Kerberos and Radius analyzer. There is good coverage of some of the common Microsoft protocols. SMB is frequently in the news, it seems, and RDP. These are both protocol analyzers that are available by default, and they're enabled generally by default. Now, note that if someone is using SMBv3 and has encryption enabled, you're not going to see anything much out of that. Likewise, RDP, as people shift towards encrypted RDP, the amount of data that is available is greatly reduced. This is kind of the trade-off between privacy. The ubiquitous use of TLS has been a boon for the privacy of our users, but as network defenders, it certainly makes our life a little bit more challenging. I will note that Zeek currently does not have any ability to decrypt TLS sessions. If you have your users' consent, that's something that you should probably do outside of Zeek and then feed the decrypted traffic in to be able to regain visibility there. And then there are a couple other ones here that are kind of interesting, right? There's a fair amount of tunneling that malicious actors may do. So there is support for SOCs as well as IP and IP type tunnels. Zeek still does have an IRC analyzer. When I first started getting into Zeek 10 plus years ago, IRC was an exceptionally popular command and control tool for attackers. And so you could simply start looking through your IRC log on a large network like ours, and you would start to find systems that had been compromised and were sitting in an IRC channel somewhere, reporting back and waiting to accept commands. Don't see that nearly as much today, but every once in a great while, we still do run across people who are kind of rocking it old style and using IRC. And then last but not least, FTP is still a widely used protocol, though starting to get deprecated a little bit. That is also another useful and interesting protocol analyzer. I've really only glossed over these. There are a lot of other protocol analyzers, and there is the ability to augment the existing protocol analyzers with Zeek packages, which Fatima will be talking about the ZKG tool a little bit later. On top of protocol analyzers, Zeek also has file analyzers. Probably the one that people interact with the most is actually, or one that people commonly like to use, is the extract file analyzer that allows you to extract files out. There's also the ability to hash files. So every file that Zeek sees flying over the network gets hashes generated for it, which is a tremendously useful tool for network defenders. There's also an X509 analyzer, which will watch the exchange of certificates and give you an exceptionally rich amount of data about the certificates that are passed back and forth as part of the negotiation. I will note that TLS certificates that fly across your network are files. So Zeek hashes those and will give you hashes for those certificates. So if you identify a malicious certificate, you could start watching for that hash and then be able to identify other uses of that in your environment. There's also a portable executable analyzer available that will give you some basic details about Windows executables that you might see on your network. The last thing I want to talk about here in the analyzer section is a really new exciting project that has been spearheaded by Robin Sommer called Spicy. This is a C++ parser generator that allows you to easily create robust parsers for network protocols, file formats, and a lot more. There is now a Zeek package available that allows you to install some additional parsers as well, or some additional analyzers, as well as replacing some of the by default provided analyzers. Keep in mind, Spicy is still really being developed and worked on. So if you've got an environment where you could run those Spicy analyzers against live traffic in a sort of in a test or development environment, that would be a great way to run this and provide some feedback to the developers about what you're seeing with those analyzers. And then if you've got an interest in developing parsers or analyzers, jumping into the Spicy channel in Slack is a great place to start seeing the discussions that are going on there. Again, there's a lot of really great active development that's going on at the moment with Spicy. And I think that this will be yet another pretty revolutionary thing that will come out of Zeek. So one of the other great things about Zeek is the dynamic protocol detection. Essentially what happens is when Zeek sees a new connection, it will try to identify what protocol is there and attach an analyzer. The first thing that Zeek does is it uses a variable that's called known ports. So if it sees traffic on port 80, it will look up in known ports and it will see, port 80 is associated with HTTP traffic. I should try to attach the HTTP analyzer to this stream and see if I can decode it. If it's HTTP traffic, the analyzer should successfully attach and start to parse out and provide you with output. If it fails to attach, or if it sees activity on a port for which it doesn't have an entry in known ports, Zeek will start to try a combination of signatures as well as attaching analyzers until it successfully parses the traffic, or until it exhausts all of the analyzers and signatures that it has. This is pretty performant, so you shouldn't be concerned too much. We run Zeek against a network that has tens of gigs of traffic, and this doesn't really create any performance problems that we've ever been able to detect. So it's exceptionally fast. It's great for being able to find things like someone is running SSH over port 443. That might be interesting, or it might just be someone who's trying to get around a firewall at a hotel that they're connecting from. Zeek has an OpenVPN. I believe there's a Spicy analyzer now for OpenVPN. We will commonly on our network sometimes see people who are running OpenVPN over port 443. Again, just because that's happening doesn't necessarily mean it is malicious. It might be someone trying to sidestep filtering somewhere along their path. Successful protocol parsing will be reflected in the con.log proto field. We will have plenty of opportunities to look at that log. And then there will also be the files.log analyzer. So Zeek will tell you where it saw a file. So if it logged a file that was over an HTTP stream, there will be a field that will actually show you that. As I note there, non-standard port doesn't mean it's bad, but it is certainly interesting. There is a log called knownservices.log that can tell you about services that are listening on your network. Part of this is derived from this dynamic protocol detection. As a network defender, you might want to start watching that known services log and see if new web servers are popping up somewhere that you don't expect them. Or if you see services popping up on new ports on an existing system, again, that may be an interesting item for you to investigate and understand the changes in your network. Okay, I think the next step is to hand off to Fatima.
Cool. Thanks, Keith. I can share my screen real quick. Does everyone see that okay? Perfect.
Yep,
so thanks, Keith. And now, since you guys have some little background of, well, not some, but good background of what Zeek is and what it is capable of doing, then let's dive into some of the techniques of running Zeek. So before we go ahead, again, some of the things that I would like to touch base on again, that we will be using for our exercises a Docker image that is in the Hub Docker repo for security, and it's Zeek Training 2021. If you haven't already, please pull down that image and run it using this Zeek, using this Docker run command, so that you guys can have a shell in that image. That image is loaded with Zeek 4.0.3 and ZKG, and those are the primary two tools we will be using for our exercises. So make sure you have ZKG and Zeek running on your image. And other thing I wanted to mention is if you have Zeek local on your system and you are not using the image provided in the repo, then make sure that you pull down the training resources folder that is on this GitHub link here, because that resource that training resource folder has all the PCAPs and files that we will be using later on in our exercises. So just want to make sure that you guys are all set with the resources needed for successfully completing the exercises. And other than that, if you can verify whether Zeek is installed correctly, you can run this command /zeek/bin/zeek-h, and then it should show the help page and all the options that are available to the Zeek command line tool. And if you want to just type Zeek for the next time, whenever you are doing the exercises, hopefully the path is exported. But if you don't find it, please run this command so that you can directly run Zeek and don't have to deal with typing the whole /zeek/bin/zeek again every time you run Zeek. So those are the few, again, housekeeping tips so that we are all on the same page. So running Zeek, there are multiple ways to run Zeek, and some of the ways Keith already mentioned, that majority of time you want to run Zeek when you have packets, right? Because one of the strengths of Zeek is it kind of like does this parsing and analysis of network captured traffic. So there are multiple ways, and the two popular ones are running Zeek in command line, which is like running in offline mode. So if you have a packet capture from your network and you are doing some investigation analysis of that packet capture, you can totally run Zeek on the command line, and it provides different kind of flags and options that you can use to run Zeek in the command line mode. The other mode that we will hopefully be discussing later on is running Zeek with the Zeek control management tool. And if you have live networks and if you want to run Zeek on the live network, then you use Zeek control interactive management shell to run Zeek to capture the traffic from your live network and produce log files for you. So both of the online and offline modes are important, and based on your requirement, you can run Zeek accordingly. So just wanted to mention that Zeek provides you multiple ways to run it. So in this slide, we will be exclusively talking about how you can run Zeek in the offline mode, where you have either scripts that you want to test, you have some PCAPs that you want to analyze, or you are just doing some kind of forensics on your network, and Zeek is a great tool to do network forensics. So these are some of the ways that you can run Zeek. So the first one says that it's very basic. Run Zeek with -r flag and give the PCAP. So you can provide the PCAP full path. And if you're running Zeek in the directory where the PCAP is residing, you don't have to provide the full path. So what the -r flag does is, it's self-explanatory, that it reads the PCAP and produces the log files. And we will be discussing later on how Zeek is shipped with different kind of scripts. So if you're running Zeek with just -r and giving the PCAP, that means you're running Zeek in the bare minimum mode. That means the only default scripts that Zeek comes with, that is enabled, will be loaded when you are running Zeek like that. The second option is, if you have, whenever we have packet captures, we run into the issues that we have bad checksum in it, and Zeek by default drops the packets that are having bad checksum. And a lot of time we get questions on our mailing list saying, hey, I have this packet capture, all the other tools are saying this capture has these things, but when I'm running this capture with Zeek, I'm not seeing any kind of logs generated. Well, that is because Zeek doesn't, if the PCAP contains bad checksum in the packets, Zeek will just drop that packets and would not run on those packets. So the dash, and this is capital C. So the capital C is used to tell Zeek that avoid checking the checksums and do not do the checksum check on my PCAP, and just parse all the packets that are in the capture. So if you're running if you're running a PCAP capture and you're not seeing any logs, but you're for sure know that it has the packets, then try giving it a -c and see if that works. So this is again the second command. It is reading the capture file from the standard input, assuming that you are running Zeek in the current directory where the capture resides. You are giving a capital C option, making sure that Zeek sees all the packets and it doesn't drop the packets with the bad checksum. And you are not giving anything else. That means you are running Zeek in the bare minimum mode. That means Zeek is only going to load the scripts, the parsing scripts that it comes with by default, and it is not going to load any kind of special script or any kind of policy script. So another great way of running Zeek and command line is, if you have a particular script for which you have written a detection, like if you have a PCAP and you are doing some forensic analysis or whatnot, and you have written your own detection for that PCAP, and you want to test it out, then you can totally give that as a command in the command line and tell Zeek that, hey, read this PCAP and then run it against this additional script as well. And then it will read the PCAP, and then whatever the script you have provided, it's going to load it on the runtime. So that's another way of running the PCAP with an additional script that you have. The fourth one is Zeek, and this one has the local at the end. So it's just saying Zeek that read the PCAP and then load all the local policies that are defined in the local.zeek. So when we are going to do the file system layout, I'm going to show you that where exactly these scripts reside, right? The scripts that by default is enabled in Zeek, the scripts that Zeek ships with, but by default it's disabled because they might be performance impactful and whatnot. And you can enable those policy scripts in your local.zeek file, and that resides in the site directory. And we are going to walk through those kind of those directories. But for now, if you want to have some additional scripts that should be loaded when you're running a PCAP, and those scripts are residing in your local.zeek file, then you can just run Zeek with the reading the PCAP and then giving it local at the end, telling it that apart from having all the files loaded by default that Zeek basically loads while on the runtime, load additional scripts that are provided in the local.zeek as well. The fifth one, it says the same thing, but it is just showing you a way where you can actually redefine some of the variables that on the command line that Zeek gives you capability of redefining. So here it is just saying that the site:/local_nets variable, you can just define it with the whatever the local subnet is for your network. So if you don't have, and there is a configuration file to define your local subnets and telling Zeek that, hey, these are my local subnets. But if you do not have it defined in the configuration file, you can absolutely define it on the runtime when you are running Zeek on the command line by using the redef and the -e executable flag, where you can just tell Zeek that, hey, my local subnet is this. So you can absolutely define those variables that are redefinable in Zeek on the command line. So the fifth one is just showing you another way of redefining some of the variables on the command line during the runtime. The sixth one is showing you that there is a PCAP that you want to read, but there is a policy script that is available in Zeek. You haven't written that script, but by default, that policy script doesn't get loaded when you run Zeek. Like, for example, in the first and second, those scripts are not loaded. Zeek will only load the bare minimum, right? But if you want to exclusively load a policy script, then you can totally give it on the command line, saying that, hey, there is a policy script that resides in protocol/modbus/ directory that Zeek comes with, and I want to load that script when I'm doing my my PCAP analysis with Zeek. So these are some of the tools. These are some of the techniques where you can run Zeek with different modes, like not different modes, but with different flags, where you want to like either run Zeek with bare minimum mode, either you want to run Zeek with just local scripts loaded, and if you want to just exclusively load a script that Zeek comes with, you can totally do so. So these are some of the ways where you can play around with running Zeek in CLI. And we also have an exercise for that. So what I'm going to do is I'm assuming that people already have Zeek Docker image up and running, and they can do the Zeek, they can run Zeek command on their terminal. So this is the Docker container that I'm running, and we have provided that to you guys. So hopefully you guys are all set. And if you just do Zeek/h, it should show you that Zeek is installed correctly. So, and if you guys have any problem running Zeek or any kind of exercises, please drop a question on the Slack channel, and we would be more than happy to help you guys out. So it's a very basic exercise. It's just going to go over the different command line options that we discussed, and running it through the captures that we have for you in the training resource folder. So the first one is running Zeek with the just bare minimum Zeek with the capture.pcap that is in the /Zeek/training resources folder. So just to give you a basic outline of what the image has, it has a Zeek. So this is a symlink in the / directory that is directly linking to the user local Zeek folder where the actual Zeek installation is there. So we will be using everything in /Zeek because it's easier to type, and you don't have to type the whole path every time you run the PCAPs. So if you go into the /Zeek folder, it has all the folders that Zeek comes with. And then it has another folder called training resources. This is the folder that has all the PCAPs and scripts that we will be using. So if you look into the training resources, it has all the PCAPs. So what I'm going to do is I'm going to show you how to run Zeek in command line with different options. So the first example is running Zeek with the checksum on, the checksum disabled by -c command, and then just reading a normal PCAP from this folder. So you can either go in, depending on where exactly you want to run Zeek, because if you run Zeek, and we will cover that later, but if you run Zeek in command line, it is just going to dump all the logs in the current folder. So if you are inside the /Zeek/training resources, then you don't have to provide the complete path. But if you are in the, let's do that. If you are in the home folder of the root, then it doesn't have anything. So you have to provide the path every time you run Zeek and read the PCAP. So just going to go over and just use tab complete for the for providing the path. So you don't have to type the whole command. So I'm running this first command here where Zeek is reading the PCAP from the Zeek training resources folder. So just let's run the capture of PCAP. Okay, so it has run without any warnings, and it has created some log files for us. And these are the log files that are dumped into the current folder. And depending on what packets I have in the capture.pcap, Zeek is just parsing them with all the base scripts enabled, and it is just collecting the logs into the different log types. So it has seen, just by looking at the log files, I can tell that this PCAP has some DNS packets in it, some web traffic, some NTP logs, or some NTP packets, and then some kind of mail traffic and SSH traffic going on. So just by looking at the overall log file names, I can easily tell that, oh, this PCAP has this kind of traffic, which is pretty neat. So
Fatima?
Yeah.
You might want to increase the font size on your terminal there to make it a little easier.
Is it better now?
Yeah, I think that's a little bigger.
Perfect. So I am just running, well, thank you for, I should have asked.
No
So I just ran the command for running Zeek on command line mode and just feeding it a PCAP. And then you notice there are no warnings, but when you run the same command and just provide a local name in front of the PCAP and then run it again, it gives a warning. It says that Zeek says that there are no local local nets defined. It's because that's because some of the scripts in the local.zeek will require you to have the local nets defined, and usually that warning tells you that Zeek is agnostic of your local network. So if you define your networks either on the command line or in the network.cfg file, which we are going to talk about later, then it will have better detection and analysis of your PCAP. So that's what we are going to do next. So we ran Zeek with the capture and then providing it with the local. This local is just telling Zeek to load everything that is in local.zeek in the site folder. Now, what we are going to do is we are going to define the local nets on the command line and see if there's still a warning. So
if you might want to pause for 15 seconds to let people run. That way they can run these as you're walking through them, unless we're going to let them do this afterward.
Okay, so I'll wait for people to catch up, and I'll just show this screen then. So I have just run these two commands to run Zeek command line on capture PCAP. So let us know if you guys have any trouble running those commands. Just to mention, I have pasted the commands on the Slack chat. If you are getting any kind of, I wanted to mention that copy paste of the commands might not exactly work depending on how the copy paste works for the apostrophes and semicolons. So if you are getting any kind of error, then just make sure that you change them as you go typing on your terminal, because the copy paste exactly the commands from the slides might not work. And yes, the Zeek, when you're running it on command line utility, it should stop running after it is done with parsing the PCAP and producing the log. So it should come out. It should, yeah. So, so as I mentioned, that copy paste might not exactly work because of the formatting in the slides, right? So you might have to, if you're getting error running the third command, you might have to change it. Like if I just paste it like that and run it, it will just say that, well, it didn't quite copy paste it correctly. So you might have to change some of the like semicolon and the quotes. So let's try that. Okay, so I'm just going to type it. Zeek-C read. Okay, so this time it ran, but it didn't produce any kind of a warning. So I'm just going to copy paste this command in chat so that you guys have hopefully right formatting to run on your Docker images. Okay, so I ran this command, and see the difference when we ran this command with just local without having this local nets defined. It was giving us the warning saying that there are no site local nets defined. But since that variable is redefinable, I added that with the -e flag in the Zeek command line, and it didn't produce any error. That means it is just on the runtime, you can actually define the local variables, and then Zeek is just going to read it fine. Okay, assuming that people were able to run this command, I'm just going to go ahead and run this command next. So, the last command in this exercise is telling Zeek to read a PCAP, that is modbus.pcap, and since it has that protocol's traffic, I exclusively want to enable the track memcap.zeek policy that is by default disabled in Zeek. So instead of editing the local.site and reloading the local, I'm just going to provide it on the command line and tell Zeek that, hey, add this script while reading this PCAP. So this is the command I'm going to run next. And I'll paste the command in the Slack once I run it so that you guys can copy paste it. Well, before doing that, I want to make sure I don't have additional residual log files. Okay, so this is the command I just ran, and I'm just going to paste it in the Slack channel. All right, so this PCAP doesn't have a whole lot in it, so it might have just created the modbus and dpt log file. So you can take a look on what the PCAP has just by going over the modbus.log file. So all right, that actually ends the exercise of running Zeek in CLI mode. And there is a question in Slack channel that says that where the protocols Modbus is. So usually when Zeek is installed using source code or in the local installation, which is for which the prefix is /ops/Zeek, Zeek has a way of looking at the policies that are by default shipped with Zeek and the base policies, and it starts looking at your prefix and then /policy folder and then /base folder. So even if you're not giving it a full path, Zeek knows that it has to look into the prefix directory to find the protocol /modbus. So this should work even if you have a Zeek installed locally in your machine and you're not running Zeek in Docker, if that makes sense. Alrighty, hopefully people were able to run the commands in this slide, and then I'm going to go ahead and jump into the running Zeek online. All right, so the next thing that I want to talk about is running Zeek online, try.zeek.org. So this is a very cool website that is written by Justin, and what it does is the use. So if you do not have Zeek installed locally on your system and you really want to run Zeek on a PCAP, or you just want to see how Zeek works, and if you have a script that you want to test out with Zeek, but you do not have Zeek locally running, then what you can do is you can directly go to the try.zeek.org website, and it has this really pretty interface, and you can select the version that you want to run on your PCAP version of Zeek, and you can choose a file. So for example, if I have a PCAP and I want to run Zeek, I can choose a file and it can upload it from my computer. But if you do not want to run Zeek on your PCAP and you are just exploring Zeek and you do not really want to go through the trouble of installing it and bringing it up on your local desktop, then you can totally use this interface to run Zeek remote. So all you have to do is it comes with some exercise PCAPs, and these are the PCAPs that are available on the server. So you can just run Zeek on one of the PCAPs and then see what kind of log it produces. So this is a very easy tool to learn Zeek for beginners, and it's still running. And the other cool feature of try.zeek.org is it has some examples. So if you are really new to Zeek scripting, but you really want to try out some of the detection, or you want to learn some more in Zeek scripting, it provides different examples. So if you want to learn more about how the loops work, then there is this very basic example of showing you that how you can define a for loop in a Zeek event. So this kind of comes very handy when you are just starting to learn about Zeek and you are a beginner and you are just trying to learn more about how you can work with Zeek scripting. So it has like different examples, and then you can build your own complex custom script for detections. But this really gives you a basic way of and a walkthrough of different kind of things that you can do with Zeek scripting. So there is like log filtering, where you can tell Zeek that this is the where you can tell Zeek if you want to do some kind of log filtering and whatnot, and all the cool stuff. So I was just going to run it again, and it would produce the log files. And it just gives you a quick view of the basic log files that Zeek creates, depending on the PCAP that you are using to run Zeek on. And then you can go over different kind of logs. And if you're running a custom script, and that script has some logic of creating a new log file, and if you run that Zeek on a PCAP, you can actually see the new log file also created in this output. So you can totally test out your script. This is a great tool, and I use it for testing purposes. So anytime I'm writing a script and I do not want to test it on my local installation and whatnot, I just paste the script here, and then I can quickly run it and see what kind of error I'm getting, and if it's running and if it's working correctly or not. So this is a great tool for the beginners to learn. Another important thing, can you zoom in on my web browser? So I can zoom in on my web browser. So Another thing I wanted to, so to try it out, you just have to type try.zeek.org and it will take you to that web page. And then, yeah, and then it has a hello world basic script loaded. And if you just use a PCAP and run it, it will produce the log files based on the traffic it sees in the PCAP. The other cool thing I wanted to show you was look at the URL. So, well, the URL is not getting bigger. So the URL is this. It means it has saved whatever script I have run with a number. And if I want, for example, if I want to share this script, right? Like if I'm writing my own custom script and I'm getting like an error or something and I don't know how to figure it out, what I can do is I can just copy paste the URL because it has saved my script, and then I can share it with my colleagues and my peers and ask them to, try it and see if they can figure out what the error is. So another great way of sharing the scripts if you are having trouble in writing a script or whatnot. So this is another cool thing I wanted to show you. So any case, this is a great resource, and sorry about that. This is a great resource. It has some basic, depending on what kind of example you are trying out, it has some explanation of that as well. And it has references to the Zeek documentation as well. So you can go to the Zeek documentation, it will directly take you to the declaration and statements. So it is a great resource to try out and test out Zeek. And if you are new to it, you will really enjoy learning Zeek scripting using that resource. So just wanted to show you how try.zeek.work and what all the features are there available. And then you can share your custom script in the try.zeek.org website as well. So that is, let us know if you have any questions on the chat, and I would be more than happy to answer. So the next thing is only with script. Another important thing I want to focus was, as Keith mentioned in the earlier slides, that you can run Zeek with the scripts only, and you can run Zeek with the PCAPs only. So the misconception is that, oh, if I'm running Zeek, I need to have a packet capture because then what else Zeek is going to do, right? But if you have a script and you are just totally testing the script and see if you have any semantic errors or if you have any logic errors or whatnot, you can just totally run your Zeek with bare minimum Zeek, and it will show you if the script looks good and or if it has any kind of error. And if you just want to print out hello world without giving it any traffic, then it will absolutely do so. So this is another way to test the logic of your scripts by just running Zeek. So you don't have to worry about, I don't have a network packet capture, so how am I going to test my script, right? Unless your script totally depends on any kind of specific network capture. So just wanted to show you guys this, that you don't have to have a PCAP, and Zeek can totally run on script and produce the output. So I think we have hello world.zeek script that I think I completely stole from hello world here. And I put it in there so that you guys can run it locally and see what it produces. So I can just quickly show you guys how it's run. So what are we going to do right now is we are going to run hello world script that we have in the training resources with just Zeek. So just type Zeek, go to the training resource folder, and then there should be a hello world script. So it just prints out hello world and goodbye, and it doesn't create any kind of log files because it hasn't gotten any PCAP. So no logs, just doing a testing of a hello world script. So this is how you can run Zeek with just scripts, and then it can produce the outputs. And if it has any errors, it will dump it in the std out as well. For example, if I miss semicolon, and then run Zeek again. So I just removed code from my print statement, and I ran it again with Zeek, and it is just showing me that, hey, there is an error in the script, line 3, and then there is an unrecognized character. So you can totally, troubleshoot your script just by running Zeek through the script. So that's another way I wanted to show how you can run Zeek with. And I can share this command over Slack. So there's a question. So if I have an example of hello world and I run it, it just dumps the output, right? And this is the default stats.log file, and I haven't produced any pcap. I haven't given any pcap. And since you have run a script on the try.zeek, it will be saved on Zeek with this number. So every script you run on try.zeek, it will have a number and have /save. So if there is an error in the script and I don't know how to deal with it, and I just run it, and it will produce error. It says error unrecognized character, and I have no clue what the error is. I can totally share the script with this URL. That's the URL that Zeek saved it, right, on try.zeek.org. So I can share this URL with my colleagues, and that when they type it in their browser, they will be taken to my script. And then they can say that, oh, this is the error, and maybe fixing it like that would help. And see the number change. And then if they reshare it with me, like this URL, I can go on that URL again, and it will give me the new script that is fixed. So this is how you can back and forth share, if that answers the question. All right, so moving along. Well, that's a good question. I have no idea how long that URL is valid. And I'm not sure how long it saves, but if there are people on the Slack channel that have more knowledge about try.zeek, then they can absolutely answer that question. But that's a good question. I'll make a note, and then I can share it if I get an answer for that. All right, so running Zeek only with scripts is done, and then dump events. The one last thing before handing off to Keith, I wanted to show you is the dump events script. That's a pretty neat script. So what it does, so dump events is the script, as the name suggests, that Zeek has a lot of parsing done on the PCAPs, and every time it parses a PCAP or a packet, it kind of like triggers the events that are corresponding to that PCAP. So for example, if I have a lot of HTTP data, then there are a lot of events that are written that will get triggered, that gets triggered that are corresponding to the HTTP traffic. So to know what kind of events get triggered when Zeek is parsing your PCAPs or your network traffic, you can run dump events on your PCAP and see what kind of events and what is the sequence of events that are triggered in Zeek when it is analyzing the PCAP. So the dump event is pretty cool when you are doing scripting and when you want to see the records as well, because it prints it out. So let's run this command. So we are going to run the dump events. That's a script that is in the miscellaneous, that is available in the policy miscellaneous with Zeek. And it's not enabled by default, but you can absolutely run that script on the PCAP to see if there are any, what are the sequence of events that gets triggered in my PCAP when Zeek is trying to analyze it. Okay, so and if you guys can follow along, that's a pretty cool script to know about in Zeek. So what I'm going to do is I'm going to just run this command here on the, well, first of all, I will just remove all the logs. Okay, I don't have any. So I'm going to run Zeek on the packet capture, and I'm going to pass the dump event script and see what are the events that gets triggered while Zeek is parsing my my PCAP, and what are the sequence of the events. So capture, and then I see. Just making sure I have a copy. It's a pretty long PCAP, so I'm just going to cut it there. I'm just going to dump the command in the chat so that you guys can run it. So this is the command I ran it, and as you can see, these are the event names, And these are the event names that are used in Zeek scripts as well. So further along down the line, when Keith is going over the Zeek scripting, in the scripts, you will see a lot of events defined, that event when the connection state is removed, event when there is a new connection. So what does that mean is whenever Zeek parses the traffic, and whenever it sees a new connection, a new connection event is triggered for TCP, right? And then it will have the connection event dump as well, that whatever it has parsed for that corresponding connection, it is just going to dump it on the screen. So it helps you basically to show, to see what events are there that are triggered in your PCAP. And if you're writing a custom script, you can totally use these events to do your custom logic that, hey, if there is a new connection and every time Zeek has a connection state removed for that connection, do this logic. Like if it's a scanner, dump it out in the notice.log file and whatnot. So it just gives you a pretty cool way of showing you that which analyzer it is and what kind of event it is triggering in your PCAP. This is a record. This is a connection record. So anything that has like the brackets like that, it's basically a record that is defined in that event. So for this, for example, get file handle. So it has the enum type, and then it has a connection record that is going to dump. So these are all the fields available in the connection that you can work with if you're writing your custom logic. And the analyzer that got triggered for the connection was the analyzer HTTP. So that's, and this is this is the connection record when the connection state remove was triggered on this timestamp for that connection. So it has a lot of fields that you can work with. And looks like it was an HTTP connection, so it has a lot of HTTP fields in it, and then SSH and syslog and whatnot. So yeah, so that's a great script to have just to dump the events and the sequence of events that get triggered when Zeek is running against that PCAP. So it's a lot of information in here. All right, so that is another thing I wanted to show you before I hand it over to Keith. So let us know, this is the command I ran with the miscellaneous dump events script on the PCAP. And now if there are no other questions, I will going to hand it over to Keith.
We'll go ahead and we've been going for about an hour and 10 minutes here, so we'll go ahead and take a quick 10-minute break. I will share my screen and keep that command up, the dump events command. If over the break, if you want to run that or the other exercises we did, several of us will be around to answer questions, and we will be back in about 10 minutes. Not about, exactly 10 minutes. Been using Zoom for a year and a half now. It's still, there we go. Okay. Perfect. If folks have questions, pipe up in the Slack channel and we'll try to help, and we'll be back in 9 minutes.
Hey, Keith, you might want to mute.
Okay. Let's pick back up here. I apologize if there's a little bit of background noise. I can't control when people show up to cut the lawn, so hopefully the AirPods are filtering that out. Please do pipe up in the channel if that's still a little bit noisy and distracting. All right, let's get back to this. Welcome back, everyone. Finished up on the dump events here, and so let's dive into a little bit about what Zeek does. So kind of the heart of Zeek is logs. It generates a tremendous amount of logs by default, and there are a lot of logs that you can add by installing scripts, writing your own custom scripts. This is a quick LS of a cluster that's running. So first of all, awesome, thank you. So all logs by default are written in ASCII file format in a tab separated format. That makes them really, really easy and useful to parse with common command line tools. It is possible for you to have Zeek write logs out in JSON format if you'd like to consume those with some sort of other tool. But everything we'll be doing here today is all based around the tab separated format. So you'll notice on this screen that there are some logs that are actually kind of highlighted with little boxes. Those are ones that we wanted to draw a little bit of attention to. So you can see that there's a DHCP log, FTP, DNS, SMTP. These are all of the logs that are basic protocol logs that you're going to get. In addition, you'll see that there are some that are surrounded with a red box. Those are ones that are kind of interesting logs. Those include things like, you'll see the known services log that I mentioned earlier. Zeek also generates a known certs and known hosts log. One note, those three logs by default will only log things for your local networks. So that is things that are defined in site : local nets that we've demonstrated a little bit so far here. There's also a notice log. We'll really get into that a little bit later. And one that's kind of interesting to dive into on occasion is the weird log. This is where Zeek will log things that are just unusual. Maybe you missed a little bit of traffic in your PCAP, you missed the beginning of a connection. And so Zeek will see that it joined a connection right in the middle, and it will raise a weird for that. Fatima's done a couple of great talks over the years that you can go back and see where she's dug into the weird log and looked into what's there. And if I remember correctly, I think some of that actually led to some improvements that she provided to the DNS log. So that weird log can get a little large at times, but again, it's a really useful and interesting one. Another one I wanted to point out here is the software.log. Now this is a log that's getting a little less useful as everything moves over to TLS. But back when I started working with Zeek, everything was in plain text and you could start catching all kinds of software that's on your network, software versions like Java or Flash. It was tremendously useful for finding the vulnerable versions of Flash in your environment. So again, software.log comes back to that idea of being policy neutral in the Zeek world, just trying to show you what's on your network, and then it's up to you to decide whether that's interesting, malicious, or just a Tuesday in your world. There are a few other logs here that are not enabled by default that I wanted to highlight. You'll note on the left side here, there's con_s0, con bulk, con long. These are logs that are showing up because of additional scripts that have been written. Con_s0 is one that people who frequently have, or people who have large environments that generate a lot of log data will actually log connections that only have a single packet. Most of the time, that's going to be related to scanning. That con_s0 log can be giant in size. And so what some folks will do is write that out to a separate log and then not send it forward into their SIEM environment. You can really blow up your Splunk or Elastic usage if you send something like S0 in there. The S0 is an indicator of con state. If you poke around in the docs, you'll see, or as you look through the con log today, you'll see that Zeek logs an entry about what it saw for the state of a connection. And S0 just means that there is a single packet that was seen, and it's generally, again, that's probably going to be scanning activity in your environment. And I think Dot made a comment about, right. Okay. So might need to reload YouTube for those that are, well, those that aren't seeing it can't hear that. So again, this is kind of a quick view of some of the logs that you'll see normally in your in a production environment. And these are cluster outputs, but you should see a lot of these logs throughout the day as we run against various protocols. And then again, if you look across here, you'll see some of the ones that we've also mentioned, things like tunnel.log. So I am going to try to pop out to a shell here real quick and show you some of the actual logs themselves. As luck would have it, we actually have an exercise where we'll show you how to generate con.logs separately, and that'll be part of that. And so you'll be able to take that away for something that you can run in your own environment. So let's stop share here. Pop back over. Okay. Is the font large enough on that?
Seems to be.
Great.
Yep, looks good.
Perfect. Okay, so what we want to look at here real quick. So one thing that I like to do, when you run Zeek on the command line against a packet capture, it will output all of the logs into the current directory. One little habit I built over the years is I tried to create a little subdirectory to work in. So you'll see that I'm in the Zeek root, but I've created a separate subdirectory under there called ZeekWeek. That way, if I do rm star accidentally, I don't delete everything in a production directory. So we can see here that these are logs from the capture.pcap. And the first thing we're going to look at is show you the log header and footer. So less-s is a super handy command to turn off line wrapping. So if we look at con.log with that, we'll look at it without it enabled. And you'll see that there's line wrapping, which as long as the Zeek lines can be, that gets a little bit hard to parse for a human. If you throw -s on there, you get line wrapping turned off. Let me rerun this because that was from me playing around this morning. And another habit I try to get into is doing rm star-log when I run multiple times. That way, if the con log, for instance, exists, Zeek will overwrite it. But if you're running with different PCAPs, you can sometimes end up with logs getting a little mixed up. So I try to have a habit of running with rm star.log to start with a clean environment. So if we run capture pcap, little Mac will work away here, and now we can see that we've got a bunch of logs. And let's take a look at the header and footer. So when you're writing logs in tab separated format, Zeek automatically gives you a number of header fields that tell you some things about the log. You get useful things like separator values by default, what the empty and unset fields are. You can see here that by default, Zeek is using tab separation. It is possible. You could set the separator field to whatever you want, but again, by default, it's tab. Any sets that are listed in here are going to be separated with commas. Let me see. We will be playing with some options a little bit later where you will see sets logged, and you'll see that those are separated with a comma. A couple other things I wanted to highlight here is Zeek tells you what the path of the file, the log that you're writing is. It also tells you the open time of the log. And then the last two really handy field lines here to look at are, there is a line that tells you the name of each of these fields. We'll be able to use those names when we play around with the Zeek cut command later. And then the next and final line in this header section is telling you what type of value to expect in here. Maybe a string or a port or an address. That can be useful when you're trying to write tools to consume these scripts, or consume these logs rather, outside of the tools that come with Zeek. And then the last thing is a little footer. When the log closes, Zeek will give you a little timestamp to show you when the log was closed. So this can be really handy for knowing if the log gets renamed or something. You can go in here quickly and figure out when the log was started and when it closed. So the next thing I wanted to look at is we're going to look at a couple common logs and just show you some of the useful fields that are available in Zeek. The first one we'll look at is con. One of the first things that I want to draw your attention to is the second field here is a UID. This is a unique UID for this particular connection. And everywhere that that connection gets logged in a log, that UID will be available. So this is a really tremendously useful tool for being able to pivot around inside of logs. In fact, if we play around with grep quickly, we can see for that first entry, well, that's not working the way it's supposed to. Too short, probably nothing. Okay. So we can see that first one that I grabbed. If you look a little further over, you'll note that there's an S0, which this is what I mentioned earlier. This was a single packet flow, so it's logical that there would be nothing in there for HTTPS. But if we look for one where we know we identified a service, then if we search for this, now this will work better. And you can see by searching for that UID, we find that there's an entry in conlog and there's also an entry in DNS log. This gets really useful when you're talking about something like an SSL connection, where you may end up with an entry in SSL.log, TLS.log. You could have entries in files. There's a whole bunch of different places that logs can that a particular connection can get logged. So going back to looking at some more fields that are of particular interest here. Keep in mind the time value is Unix epoch time. The Zeek cut tool will allow you to convert that to human readable time. A couple other ones that I want to draw your attention to is there is the service field. I'll try to highlight the header here. That service field is what Zeek logs when it is able to successfully attach an analyzer to the connection and parse it out. So you can see here that we have got some NTP connections that are going on. We've got HTTP. You can see all of the services that Zeek was actually able to successfully parse out of this packet capture. Couple more ones that are of interest will be the con state, and that is the one which let's go ahead and introduce you to. We'll dive a lot more into Zeek cut a little bit later, but we'll preview some stuff that we're going to do later. So here we can see that Zeek was able to see a number of different connection states. OTH is generally going to be maybe a TCP connection that Zeek joined in the middle. The RSTO is where a reset was sent back. S0 is a single packet flow. Again, probably going to be scanners in your environment. The last one I want to draw your attention to is the SF, which tells you that Zeek saw a fully established connection that was torn down with fins. So standard normal TCP connection. If you look around in the documentation, there is documentation that shows you what all of the possible connection states are and what they mean. I still have to poke at that every once in a while for some rare ones that you may not see very often. So back to the conlog here, and just checking to make sure no questions. Another thing that I want to draw your attention to is the history field. So Zeek will actually give you an output of the history of a connection, which is all of the states that it saw for a given connection. So if we look, so at the top here, we have some single capital S. That means Zeek just saw a SYN packet and nothing else. Capital D, lowercase d tells you that Zeek saw UDP data in one direction and UDP data in the other direction. The capitalization tells you whether the state was from the originator of the connection or the responder of the connection. And this is a really great time to dive into responder versus originator. Zeek has a concept of the originator, which is whichever system, whichever IP address started the connection. Most of the time, that is going to be your client, and the responder is going to be your server. But there are some unusual protocols where things may get flipped around. Active FTP is an example. Not used very much anymore, but you may still see instances. And that's why we still stick with that originator versus responder concept. Is using client and server may actually give you a misguided notion of what the connection actually really meant or what really happened. And that comes back around to that idea of trying to have high certainty about what Zeek is telling you and giving you good ground truth about what's going on your network. The last thing I want to do is pop down here to some of these full connections. So you can see here that there's an S and a lowercase h. That means the handshake came back. And then the A's are ACKs were seen in both directions, data seen in both directions, and finally, FIN packets seen in both directions. So this is an example of a history field that tells you that this was a fully established TCP connection that was torn down by normal means. At the bottom there, you can see some of these are have entries where there was a FIN packet in one direction and a reset in the other. Most likely that's perfectly normal behavior, but if you're a network researcher, that may be something that's of interest to you. Again, the history field is really useful for understanding what actually happened in a connection. There's a bunch of other fields that aren't represented in these PCAPs that you can, again, look through the Zeek documentation on the con script, and it will tell you a lot of details about what's going on in there. So let's pop back to the con log one last time. The last thing I want to highlight, we don't have any connections. I believe we don't have any connections that have tunnel parents in here, but let's double check. And we do not. Again, that hyphen tells you, right, that is an unset field. So none of the connections in here were over a tunnel. However, if, for instance, someone was passing traffic over a plain text tunnel of some sort, say an IP to IP tunnel, Zeek would log the encapsulated traffic as separate connections and then annotate it in that tunnel parents field to tell you, hey, this specific con log I saw was actually encapsulated in a higher level tunnel of some sort. And then that tunnel should also generate a separate con log. So this gives you a sense of completeness of what's going on in your environment. And really excellent point on from Sebastian there is you can do column alignment with the column tool itself, which helps a little bit with lining up those, especially those fields, those field names are the ones that are going to be really useful to you. So let's actually go ahead and do that. And pretty slim install here on the Docker image, so that may actually not be available, but you'll generally find it elsewhere. So that is what I wanted to cover. Again, there's a lot of other fields in the con log, but just wanted to highlight a couple of key ones there. So let's go to the files log. Oh, geez. So as I noted, lots of things that move over your network are really just files being transferred over various protocols. HTTP is usually just passing around web pages. TLS connections involve a whole bunch of certificates that could be passed back and forth. So the first thing I want to highlight here is there is, in addition to that con UID that I mentioned, there's a files UID. This again is the same thing. This is a unique UID for this particular file. And you shouldn't see collisions. You basically shouldn't see collisions. The size of the of possible outputs is large enough that you would have to run for an exceptionally long time before you should see a collision. Again, this file entry is going to be useful for searching through other logs. And we'll look around here. We don't have an SSL connection in this one, but we can still point out a few other things. You'll see that there is that con UID that I mentioned earlier. So if we searched for this con UID, I swear I type for a living. We can see that we found entries in con.log. There's the entry that shows the entire connection. There's a whole bunch of entries in files.log, probably somebody pulling down a web page. And then last but not least, there's HTTP connections that also happened in there. Okay, so a couple other things to point out here. We had mentioned the analyzers field. So there is an analyzers field, or rather, there is a source field that tells you what analyzer was attached to be able to parse out these files. And in pretty much all cases except the bottom, these were all HTTP connections. But you can see there was also, there's some mail traffic, unencrypted mail traffic in this PCAP. And we've got a couple of entries from the SMTP analyzer as well. And then the last thing I'm looking for here. Okay. Okay. And there we go. So if you run with the local.zeek loaded, you'll now see that we by default get MD5 and SHA-1 hashes for all of the files that Zeek saw. And it looks like the same file was passed a whole bunch of times there. You can also enable SHA-256 hashes if that's your jam. But MD5 and SHA-1 are still, I think, reasonably well used. And again, this is really useful for, you see a malicious file on your network, or maybe you get it from a PCAP that you looked at. You could then take that hash, pivot to your production logs, and look around to see if you've seen that file passed somewhere else in your environment. There's a really handy way that Fatima will get into using the Intel framework to actually load these indicators of compromise or indicators of suspicion and be able to get alerts so that you don't have to constantly grep through your logs. And then last but not least, we wanted to quickly look at the SSL log. I can paste the, sure. I will try to paste some logs in a moment, or some commands in a moment. Well. Okay, and I wanted to look at the SSL log, so it helps if I run against a PCAP that has, now we have an SSL log. And again, this comes back to, right, we've got the that con UID that we can pivot around off of. We can see that there's some traffic that looks to be going to 12.723, and then you get some details about the SSL connection that was negotiated. So we can see that this is TLS version 1.2 traffic. You get information about the ciphers that are used. You get the file UIDs. So we could take one of these file UIDs, and if we grep for that, we have an entry in notice.log, we've got an SSL entry, and we've got the files entry. And you can see that we've got a bunch of hashes there that we can take advantage of. And in that files log, you'll see Zeek tells you that the file type is application X509 user cert. Let's go back to that files log. So there's Keograd, that's a good question. I would be curious why you're only seeing one particular type of hash. Somebody else in here might be able to dig in or know the answer off the top of their head. So the last thing, or something I skipped over in the files log, is there is a MIME type field that is defined. These MIME types are actually generated. So Zeek does not use the popular libmagic library to be able to do MIME type identification. There's actually separate scripts that handle all of the MIME type identification that are managed by the Zeek developers. That's a really good place for folks to be able to do some really easy giving back to the community, is identifying new MIME types that you're able to share back, and then they can be added into this to expand what files Zeek can identify. So that's a really quick overview. There are a lot more logs, and there are a lot more fields that are available. When we get into looking at a script in a little bit, you'll be able to see how Zeek figures out what fields actually get populated. And that's a great place if you're looking at a field in a log and you're not sure what in the world that means or where it came from. There may sometimes be really helpful comments in the script that can help guide you. So I'm going to pop back out to the slides here, and we're going to keep plowing ahead. All righty. Any questions? All righty. So in addition to logging, Zeek also does alerting. The image you see there is a submarine dive klaxon. A friend of mine once bought one of those off of eBay. He ran it in our office, and everyone ran screaming. So if you'd like to get someone's attention, submarine dive klaxons are a really great way to do it. In the Zeek world, if you want to get someone's attention, one of the most common ways is to log an entry to notice.log. There are some notice entries that are logged by default as part of scripts. You can also write your own scripts that do things with notices. You may have some sort of pattern in an HTTP connection that if you see that's of interest to you, raising that into the notice log is a really good way to sort of raise that up a level so that people can see that it's something that needs to be looked at. In addition, there is an action email. So you can, in theory, email notices. The email support in Zeek is a little simple at this point, so it can be a little bit noisy at times, and you don't have a lot of ability to easily send notices to different people depending upon the notice type. But that's some stuff that you could probably script up pretty easily. So then real quick, here's a couple notice examples. You can see that there's an Intel notice. So the left part of this double semicolons tells you what script, or generally what script this came from, and then the right side is the specific notice. Here we can see some interesting ones. The Intel notice, Fatima will be talking about that when she goes through the Intel framework. There is a Heartbleed script that was written by Johanna very shortly after the Heartbleed vulnerability was announced. There's some scanning. There is a kind of older scanning script that exists in the default scripts from Zeek. I would note you probably want to be a little bit careful running that in a very large production environment. I think it still has some performance costs and it can be exceptionally noisy. But Zeek would tell you that there was an address scan where a single port was scanned across a multitude of IP addresses, and then the port scan tells you that multiple ports on a single host were scanned. Other useful ones are, certificate expired. That may be interesting for compliance purposes in your environment. And then there's a couple cool things in the SSH script. The SSH script will raise a notice if it sees an interesting host name. So for instance, if Zeek sees that someone SSH'd into your environment from a host called mail.example.com, that's kind of interesting. Generally speaking, people should not be SSHing out of hosts that have mail in their domain name. That you would assume is a mail server. And seeing someone SSH out of a mail server into your environment is maybe interesting. It may also be that someone is at a cafe somewhere that happens to be using a box called mail.whatever as its NAT gateway, which I have seen in production. In addition, there's a watched country login. So Zeek has the ability for you to say, if anyone SSHs in from some country that we normally should have no business with, then I want you to raise a notice to me that there's successful SSH activity coming from somewhere that is of interest to me. That's where it's useful to kind of know your network, know where people are SSHing in from. I'll say in a higher ed environment the size of ours, this is a little bit less useful to us because we see people legitimately SSHing in from all over the place. And then the last part is Zeek has a password guessing heuristic that crudely tries to looks at some features of an SSH connection and tries to get a sense of whether someone is potentially trying to do brute forcing. And then last but not least, Zeek can do custom logic. This is the obligatory XKCD that everyone is required to have in their slides. Custom logic is more what you would learn in Ashish's training later. Again, we're going to really dive into writing your own scripts, but gaining that capability really allows you to unleash the power of Zeek for whatever your specific needs are, though there are a wealth of scripts out there that you can take advantage of. And with that, I am going to hand the reins back to Fatima.
Thanks, Keith. I will quickly share my screen. All right, so now we are going to discuss about the file system layout of Zeek. So we have been talking about scripts and logs and where exactly the configurations are to tweak in order to have Zeek perform cool things, but we haven't really talked about where exactly you can find those, like where exactly you can find configuration files, what is the default path that Zeek looks for loading the custom scripts, policy scripts, and base scripts, right? So this is not an exhaustive tour, but it will give you some of the important directories that you always would want some way or other to look at. And we will be ignoring the include and lib because that's the two directory that really, as a user, you do not really have any interest in going into and performing anything. It just are, they are not very, like, as a user, you would not be touching them that often, or maybe not at all. I haven't looked into the include and lib for a very long period of time now. So when you install Zeek, there are two installation default paths, right? So first, if you're compiling it with source, you can give it your own prefix where you want the installation to happen, right? Usually it's user local Zeek and then some version where people like their source code to be compiled and installed. But if you are installing Zeek from the binary packages that are pre-built, by default, the Zeek is installed in opt/Zeek directory, right? So these are the two basic prefixes that Zeek usually uses, and Zeek has these prefixes. So anytime you're loading some scripts, it knows your default path where Zeek is installed, and it will start looking and finding the files and scripts under those prefix installation paths. So we will be talking about the bin directory, etc directory, logs, share, and spool. Those are the important directories you should really know about, because if you are either customizing Zeek or if you are just configuring it for basic deployment in like a either standalone mode or cluster mode, you should have to have knowledge of where exactly you can find the configuration files. So moving along, the first directory that I'm going to talk about is /bin. So whichever your prefix is, either it's opt/Zeek or user local Zeek, you will find the bin directory in the installation path of Zeek. As the name suggests, it is the directory where all the binaries get installed after you install Zeek on your system. So there are a lot of binaries, but there are 3 important binaries that you should always have knowledge about. So Zeek cut, it has Zeek as well. I didn't put it because we have been using Zeek for Zeek command in CLI for all the exercises. So you by default know about that binary that is in the /Zeek/share directory that we are using in exercises. So apart from Zeek binary that we are using in the exercises in CLI mode, there is Zeek cut that you guys got a taste of when Keith was showing you some of the cool things that you can do with the log files, right? So Zeek cut, usually what it is it extracts the column information from your Zeek logs, and all you need to do is you need to provide the column name, and it will cut the ASCII log files, and it will just print out that column. It doesn't work on JSON logs, so it's just for the flat ASCII file that are tab separated, and it can easily convert the Unix epoch time to the human readable time form. So it's a pretty neat tool to have in your pocket to play around with if you are especially doing log analysis and log processing with Zeek. The other is Zeek wrapper. It's kind of like it was there to avoid the deprecation warnings when you are using Bro, but still it's backported, so it's still supported, but you should not be using the scripts and files that has the old Bro related variables and Bro related nomenclature. So that was just a wrapper to just let people still run the older version of Zeek, which still supports Bro in the file names and directories. And then lastly, the third one is Zeek control. So when I was discussing how you can run Zeek in different modes, I briefly touched upon running Zeek in the cluster mode, right? So Zeek control is like a very Unix style interactive shell to manage the cluster configuration and cluster commands. So if you are running Zeek in cluster mode, that is like live tapping your network, then you can use Zeek control to deploy your any changes you have done to the script. You can restart the cluster, you can install different scripts and whatnot. So Zeek control primarily is used for controlling the cluster framework, and it's kind of like just a cluster framework management tool that Zeek provides. Okay. So the second important directory that you should know about when you have installed Zeek is the etc directory. So that is important because even if you are running Zeek on command line or in cluster mode or in online mode, any mode, you need to know where exactly you can tweak some of the basic configuration of Zeek, right? So the etc directory has 3 important files in it, network.cfg. It defines your local networks. So remember when we were doing the exercises where we were redefining that local nets variable, and we were providing Zeek on the command line during the runtime that, hey, these are my subnets that are local to my network. If you want to configure your Zeek when it automatically knows by default that which subnets are your local subnets, you can actually define those subnets in network.cfg, and then every time you run Zeek, Zeek by default knows about your local networks. And Zeek analysis is again, Zeek analysis is network agnostic, so it will perform better. And if you have any policy scripts that exclusively look for scanners and whatnot, it will have efficient performance. It will have a better analysis of your network traffic if it knows about your local networks. So that's important. If you don't define it, every time you run Zeek will produce a warning on your standard output saying, hey, it's a good practice to define local nets, and that's where you define it. So you go into the etc/ directory, and then in network.cfg file, it has by default some of the syntax of how you can define your local network. So you just follow that, and then whatever networks are local to your in-house network, you just define it there. The second one is node.config. So even if you're running Zeek in standalone mode, Zeek has different components attached to it. Like, for example, Zeek has logger, Zeek has proxy, and all those components are defined that which node is performing what function, you can define that in node.cfg. So even in our Docker installation, if you go into our /zeek/ folder, you will find all these directories, and you can go into the etc directory and you can take a look into the node.conf file. So all it does is it just defines the functionality based on what your node is supposed to do. So if you have multi-node cluster, you can define in node.config that these three systems, these physical systems are my workers, and this one system is my manager, and then this system is my proxy, and then the other system is my logger. So basically you define your cluster architecture in node.conf file. And even if you are sniffing traffic from your local interface and you don't have any cluster, you just have one machine, you can define this standalone mode of running Zeek when sniffing from the interface in node.conf. So all you do, there is a standalone stanza where you provide the interface where you want Zeek to sniff the traffic from, and then a basic setting. So even if you're doing standalone Zeek packet capture, then you can actually define that in node.conf. So you have to tweak those files if you are running Zeek in the live mode where you are analyzing the traffic from your interfaces. Lastly, Zeek control.conf, CFG. So we talked about the Zeek control binary, right? So all the configuration related to the Zeek control management tool goes into that Zeek control CFG file. Again, it's a flat file, it's an ASCII, you can read it. And the three important things that are defined in Zeek control.cfg are first, where exactly is your log file, like your spool directory, where exactly Zeek should log the logs that it is generating by parsing the live traffic from your network, the log rotation interval, how often you should by default rotate logs, like depending on your log retention appetite. If you have a lot of disk, then you can have log retention for a longer period of time. But if you just do not care about it, and if you just have a very tiny amount of storage, then you can absolutely define if you want to just store logs for 1 day or 2 days. So that goes into the Zeek control.cfg when you are running Zeek in live mode. And then the third important is like email address, like what is the reference of your administrator where Zeek can send the emails to if there is anything happening in the notice framework, and if it has to send out an email. So those are the three important config files that you should be familiar with when you're running Zeek in live network capture mode, and they're all residing in the etc folder. Another thing, so we have been running Zeek in command line, or as we can say, in offline mode. So every time you run Zeek in offline mode, wherever Zeek is running on your system, if it's running in /root directory or if it's running in /user directory, it is just going to dump all the logs in your current directory. It doesn't have any clue in what log path you want to drop your logs in. So in the CLI mode, the default log path is wherever you are in the current directory and wherever you're running Zeek in. So in CLI mode, default log path is current directory. But when you run Zeek in the online mode where you are sniffing the traffic, Zeek will be running in the daemon / mode, right? It will not have any local log path. So what it will do is it will pick up the spool directory that you have defined in Zeek control.cfg file, and it will drop all the logs in that log path. So usually there is a logs folder that is in your default Zeek installation path, and it has a symlink that says current, and that symlink links to the spool directory or whatever directory you have given in Zeek control conf file to drop your current logs for the hour. So that's the log directory where Zeek will drop all the logs if it's running in online mode, where it is sniffing the traffic from your interface. And by default, Zeek has the log rotation interval of per hour. So every time, every hour, at the top of every hour, it will rotate all the log files that are in the current directory, and it will zip them and archive them into the year, month, date format, and it will drop that log file into per hour basis into that folder that is that has the year, month, and date naming format. So that's where the logs are archived, and that's where the logs are rotated every hour by default by Zeek. So another important directory to consider is the logs directory. Share. So we have been discussing a lot about when you are running Zeek in command line, if you don't provide any local or anything like that, and if you just run it in the bare mode, it is going to load by default all the scripts that are the base scripts, right? So now where exactly these base scripts reside, right? So there is another directory in the file system layout called share. And if you look into the share, it will have a Zeek folder. And inside that, you have 3 important subfolders. One is base, second is policy, and third is site. So as the name suggests, the base folder has all the base scripts that Zeek is shipped with, and they are loaded by default. They're enabled by default. And any change, it's not recommended for you to do any kind of changes in those scripts, because every time you would upgrade Zeek, those scripts will get overwritten. And that's why we have site directory, where exactly your site specific changes go. So if you have custom scripts, or if you want to extend a base script and whatnot, you can actually have your customized script sit in the site directory and then explicitly loaded in local.zeek. That again resides in site directory, so that your local changes do not get overwritten when you are doing a Zeek upgrade or Zeek install of the latest version. And the policy directory. So the policy directory has all the scripts that are written by Zeek developers by default that can find interesting stuff in your network. For example, as Keith was mentioning, that there is a built-in script for the address scanning that Zeek ships with, but by default it is disabled. So that script resides in the policy directory, because it's an additional script that Zeek developer wants to ship out Zeek with, but they are just agnostic of whether you should be enabling it, because if you enable it, there will be a performance impact. So there are a lot of scripts that are really cool, that have really cool analysis of your traffic, like there is SQL injection script, there is a SSH password guessing script. Some of them are by default enabled in the local.zeek, but some of them that are like performance intensive, and then they should be like tuned based on the user's environment. They should be they are disabled by default, but they are still there in policy. So if you want them, you can enable them by going in your site directory and then loading them in local.zeek explicitly. We will be doing the explicit loading and unloading of scripts in later on in exercises, so that you know where exactly you can load the scripts that are not enabled by default. But those are the 3 important directories that you should consider when you are thinking about scripts, and what scripts by default Zeek ships with, and what scripts are by default enabled in Zeek. Spool, that is the least favorite of mine, and that it's not like highly important, but it is in itself it's in itself an important directory, but you have very less things to do in it. Like, you don't touch a lot of files in the spool directory. One of the important thing I want to mention was I have been mentioning that there is the current directory in the logs, and it is a symlink, right? So the symlink actually symlink kind of links it back to the spool directory, and then there is this logger directory which actually holds your current logs for the hour. So that's one of the important things that should be that you should know about spool directory. But other than that, if you are running Zeek in cluster mode, there are a lot of files that are by default generated that are like state files for your for the state of your different workers and the different cluster components that you should not be touching. So you will see a lot of, depending on how many workers you are running in your cluster, depending on what is your cluster configuration, you will get like all these state files that are by default generated and dumped out in the spool directory. Another important file here is the Zeek control config.sh. So whatever configuration variables you have set in your Zeek control conf file that resides in your etc directory will actually be generated and dumped into that file as well. So if you want to check that what are my variable values, whenever Zeek is running, you can go into that file and you can check that what are the cluster configurations that you have enabled in your Zeek cluster. Okay, so that was the quick walkthrough of the Zeek file system. Hopefully now you know where exactly the Zeek scripts reside, where are the logs residing in Zeek, and what are the configuration files, what are the important configuration files that you should note about, and where exactly they are residing. So before that, let me give you a quick walkthrough on the terminal to show you the different directories that I was talking about. So I'm not actually paying too much attention on the questions. So let me know if there is any burning question right now based on the file system that we have discussed that I can answer. As I mentioned before, that this /Zeek is a symlink to the user local directory where exactly Zeek is installed. So this is our installation path of Zeek, right? So this is the prefix that was used to install Zeek on the Docker image. So all the folders that I have discussed right now And let me know if the font is okay and if you guys can see it. So all the folders that I have discussed right now in the file system layout will be residing in this prefix on your Docker image. And if you are not running this Docker image, if you have a local Zeek install, then depending on if you have installed it with binary, there should be a /opt folder where the Zeek by default would have get installed. And if you have compiled it with source, you should have given a prefix. And if not, then I think by default, it will just create the installation in the user local directory. So we have discussed the bin folder, etc folder, logs folder, share, and spool. So these are the 5 folders that we have discussed. This is a custom folder that we have created. So it is not usually available in the default prefix. It's just like we have created this custom folder in the default prefix so that you can quickly go through the prefix and locate the files that we are using in the exercises. So if you just take a quick look in bin, it has all these binaries, and we only talked about some of the ones that are important, right? So Zeek is the one that we have been constantly using in our exercises. We will be talking about ZeekAG later on. There's a Zeek control binary, and then there is the Zeek cut that we have talked about. So if you look into the etc folder, it has the 3 important configuration files that I was talking about that you need to look into if you are running Zeek in the live network capture mode. So if you take a quick look in the networks, it will show you that this is the by default 3 networks that are like private IP space that Zeek usually have in network.crg. But for example, if you are an enterprise and you have your own local network, you can absolutely add more lines that are tab separated per line, like the subnet and the comment should be tab separated. That's another thing that Zeek is pretty conscious about, that it should be tab separated. So this is the log file that you list your local networks in insider notation. And it also supports IPv6. So, and then if you look into the node file, it is the Zeek control node configuration. So this is the standalone version. So if you are running Zeek on one system and you don't have like multiple clusters set up, then you can just say my local host is my standalone host, and then you can give the interface where you want Zeek to sniff traffic from and produce logs. This is the example of the different nodes that you can run in a cluster mode. And logger, you can provide a host for logger, and you should define a type. And then for manager, define type manager, and then host, whichever host is, if you have physical boxes, you can have the DNS name for the boxes. Otherwise, you can just have one single system running all different 5 types of components. And then the workers, the interfaces are only defined in workers because those are the ones who are doing all the heavy lifting from the network. So that was node.conf. And lastly, there is Zeek control, right? And as I mentioned before, it has meeting options, it has logging options, it has logging interval, which is like by default 3600 seconds, which is 1 hour. And then it has important options like your site policy script, which is local.zeek usually by default, and then the logging directory and spool directory. So this is the spool directory that I mentioned before. And this is the log directories. You can absolutely change them according to whichever disks you have assigned for the Zeek logs, and then whatever SSDs you have and wherever you have on your system that Zeek should be using for the current logs. Zeek should be using it for the current logs, and then the configuration file. This is by default already set up, and you should not change it, but just in case if you have changed the location, you should define a new location. But this is by default populated based on your prefix. So you should not be changing that. So those were the 3 important files in the etc that you should take a note of. You should know about them. And then there is logs. Logs doesn't have anything yet because we are not running Zeek in cluster version. So yeah, log doesn't have anything in it yet right now. And then share is the important one that I talked about, and it is in Zeek that you will have all the scripts. So the base will have all the Zeek scripts related to the base policies. This policy have the scripts that are, some of them are enabled, some of them are disabled by default, and you can totally enable them in your site directory. And site is an important directory. Site has all your local additions. So local.zeek is the one. So if you have a script, you can totally dump it into the site, depending on how you want to, do your layout of file system for custom scripts. But usually what people do, if they have a local script, they dump it in the site folder, and all they do is they go into the local.zeek and then they just load it in the Zeek. So we will have exercises where you will be loading some custom scripts, but this is where the scripts are loaded. So by default, if you see this tuning scripts and capture loss, these are the policy scripts that are enabled by default in Zeek. But there are some policy scripts that are by default disabled in local Zeek, which is like one of the scan scripts. It is by default disabled, and if you just uncomment this line, it will get enabled in your network. Same with the trace route detection. This is another policy script that is by default disabled. And there are a lot of cool scripts that actually detect some kind of some type of software in different protocols, and they are by default enabled. So there's a lot of things that you can do with the local.zeek and enable and disable according to your network and what you want to detect. But coming back here, so how you can find the scripts? It's pretty simple. If you just find all the scripts in Zeek land ends with .zeek, and if you just find the if you just run the find command in the share Zeek folder, it will find all the scripts with the name ending in .zeek suffix. So I can try that out here. So where am I? Go back. ls. Okay, so I am in the share Zeek, and this is my prefix. So since there is a symlink for the prefix, you just have to type /Zeek, and then you can change your directory into the share Zeek folder where exactly the folders are for the base and policy script, and then find all the files that has a suffix ending in, well, the copy paste doesn't really work that well. So I'm just going to type it. I'm going to paste the command in the chat so that you guys can find it. So these are all the scripts that are in currently that are in the Zeek deployment that you have installed on your system. So okay, I'm just going to remove the less from the. So see this, these scripts are in the policy folder. Some of them are enabled, and if you like really want to have packet fragment enabled, then you can actually take this path and load it in your local.zeek file. Same with track all assets. So Zeek definitely comes with really cool scripts that are by default shipped with Zeek that are not enabled. But if you really want them to be enabled in your network, you can absolutely enable them. So there are some in the software folder for software framework, and then there are some files. So hash all files. This is the script that is responsible for adding the hashes that Keith was showing before in the files.log file, that there were, and you can actually take a look into that. That's another great way to learn more about scripting. You can go through the scripts that are there, and then you can see what exactly people have written for detection. So Zeek has file analyzers. And one is, and there is SHA-256 as well. So somebody was asking a question before that how you can enable SHA-256. So you just add another line, or you should customize this script actually, because this is under policy and it will get overwritten. So you just make a copy of the script and drop it down in your local site folder, and then add it and load it in your local.zeek. So these are the two file analyzers that Zeek attaches every new file in the connection to. One is MD5 and SHA-1, and that's why. And this script is by default enabled. So this script is by default enabled, and Yeah, you can add another file analyzer SHA-256 to have SHA-256 hash on your in your log file. So that is an exercise, and hopefully you guys were able to follow the exercise. And then after that, we are almost on the break side. So you guys can play around with the command and then look into the scripts, different scripts, and yeah, play around with them, explore the script land of Zeek, and then hopefully after that, Keith is going to go deeper into looking into some scripts and dissecting them. And I can have it on present so that you guys can have it there. I have pasted the command as well in the Slack, so yeah, you should be good to go.
Awesome. We'll take a quick 10-minute break here. I will note we've been talking a lot for the first section of this. The rest of the time here, we've got a bunch of exercises. So we'll have little 10-minute exercises to allow you to customize Zeek, play around with some frameworks, and really give you a chance to do some hands-on stuff. But I would really encourage folks as much as possible to run the same commands as we're showing things and be able to look around. And we'll take a 10-minute break. And if you have any questions, please mention them in the Slack channel. Thanks. Okay, welcome back everyone from the break. Hope everyone is refueled and ready to dive in here. Go ahead and share my screen and we will get back to it. So picking up where Fatima left off, talking about the file system tour there, the next thing that we're going to do is we're actually going to pop out and look at a script and give you a little bit of an overview of what you can look for in scripts. Okay, so if you remember in the file system tour, Fatima talked about under Share Zeek base, there are protocols. And then if we do a quick double tab here, we can see these are all of the protocols that Zeek has by default. We're actually going to look at the HTTP script. HTTP is a little less prevalent these days in our environment, but there's still some really good tools and some things that we can convey. So when we look at a script, first of all, you'll notice in this directory, there are a handful of scripts in here. That dpd.sig, that's actually the signature that Zeek tries to use to identify HTTP traffic. You'll also notice that there's a _load script. That's a script that Zeek can look for in a directory and know, oh, I need to load all of the things that are in this script. You'll notice the @load argument, and then the @load, and then the argument of main entities, etc. You'll notice that there's a little bit different argument to load a signatures file. But what we really want to dive into here is the main.zeek. For most of the time for directories that are loading scripts, there's going to be a main.zeek. That's a great first place to start looking around to understand what a script is doing. So if we look at the HTTP one, again, the first thing you'll note, there's great comments, especially for the scripts that are shipped by the Zeek project itself. There are great comments throughout. So even if you know little or nothing about Zeek, you can still look through, read the comments, and start to get a sense of what a particular script is doing or what some action is happening. So you'll note at the top here that there are a couple more load statements that are happening. Sometimes people will have redundant load statements, and Zeek handles deduplicating perfectly fine. So even if you think that a script might be loaded by some other base script, if you are writing your own custom script, it's not bad form to load to make sure that the things you need that are outside of your script directory are actually loaded. The next thing we want to look at here is the module, a keyword, which tells you that this is the HTTP module. So that defines the namespace for this particular script. You can do some grep-foo to figure out what the available namespaces are, or if you're trying to write your own script, make sure that you don't conflict with existing scripts. So as a beginning user, one of the first places or one of the best places to find out what a script is doing is to look at this export section. These are variables that are exported out and available throughout Zeek. I'm purposefully paging down here real quick, and I would note, I'll actually take a moment here. Note the script I'm running. Please do take a look at this yourself locally as we poke through. There's export and then an open brace, and then I'm intentionally paging down to show you down at the bottom here, there's a close brace. So this whole section is arguments and variables that are available outside of Zeek. There's some common things like the enumerator to show the log. There are some log policies that allow you to hook into actions as logging happens. But what I kind of wanted to really hit on here, so the order of the load statements is not relevant. Whatever order works for you, Zeek is going to run through all of the load statements it has, deduplicate them, and then load all of them. For the most part, that shouldn't be relevant, though I suppose, yeah, I need to poke around. Maybe an edge case where something gets loaded a little bit later, but generally speaking, no. Order of load statements is not particularly important. Good question. So one of the first things you'll note here is that there is an option defined here. We're not going to dive too much into it, but Zeek is in the process, or rather there is a new framework that was recently written by Johanna Amann that is the config framework. This allows you to start changing Zeek variables as Zeek is running. Before the config framework existed, if you wanted to, for instance, change the default capture password from that option, if you wanted to change that variable from true to false, you would have to edit your local.zeek, save it, then restart your cluster. If you're just running against a packet capture on the command line, that's perfectly fine, not really interrupting. But if you have a cluster that's been running for days on end, that restart can lead to loss of state. Or you may miss traffic in the short bit of time it takes to restart Zeek completely. So the config framework is a really cool new thing that's added. As I noted, we're not going to really dive too much into the config framework, but we will interact a little bit with it. But when you see something that starts with that option command, that is telling you that this is an option or a variable that you can change. And again, you'll note there's a really good comment here, tells you that this logs passwords used in basic auth. The next thing to start looking at is the record that Fatima had mentioned. So this defines all of the fields that show up in the HTTP log by default. And again, great comments to tell you what this means if you don't know anything about a particular protocol. There's the common stuff that is, the ID, you've got your timestamp, you've got, method, the URI that was observed, a referrer. There's a lot of useful information about what is getting logged into a log, or what is available in a log. So then we've got a little bit of some structures that are used for maintaining state. Again, here's another option keyword. This is telling you that by default, Zeek looks for, this is a set of strings that Zeek is going to look for when it is trying to find proxy, to indicate proxied requests. This is variable, redefinable, so you can, if you came across a proxy header, some sort of string that in your environment indicates proxied connections or requests, you could add it to this set and then be able to start getting new behavior in your environment. Again, here we've got, HTTP methods that are defined. All the common ones, we're mostly familiar with: get, post, delete, connect, some of the distributed authoring HTTP methods. Then the last couple things I wanted to note in here is there are a couple of hooks that are available to you. So there is, this is an actual event that gets raised that allows you to get access to the HTTP record when it's sent on to the logging framework. So if you were wanting to do something complex, maybe you wanted to look at the logs as they're written to the HTTP log and not have a particular thing get logged because it's really noisy in your network, hooking this particular event is the way that you would be able to do that. And then there's the HTTP finalization hook. And again, that's another event that you could hook if you were wanting to do some custom work. A couple other things I want to point out real quick in here. I just wanted to raise the point about the const, the ports that are defined here. So these are the hints that are used for looking for likely server ports. And you can see that this is reused immediately as a redefinable variable. Then once we get beyond that, we start to get into the real meat of what the script is doing. There's that Zeek init event that Fatima demonstrated when she showed you running Zeek without a PCAP. Zeek init is the first event that always fires when Zeek runs. If you run dump events against a bunch of scripts, you'll see Zeek init always runs first, and then Zeek done always runs last. What we're doing here is we're just setting up the log stream primarily, so that we've defined, what the log is. We are creating a stream. We're getting the columns for this log from the info record. We've got an event that we're defining here, a path, and then there's some stuff related to log policy. And then in addition, you're registering the analyzer. So this is kind of some sort of housekeeping stuff that Zeek's is doing in this script to get things set up to start receiving traffic. And then after that, you've got a bunch of functions that are defined that are going to be used. And then finally, the events themselves. So if you ran a script, if you ran dump events, you would see this HTTP request event fire. And then you would see the data structures that are defined here. There's the connection record, which is what C: is. We've got available the method, the original URI, the unescaped URI, and the version. And then a priority that is defined that allows you to raise or lower hooking your own events. And then the rest of this is just, Zeek code telling you what Zeek is doing when it looks through the HTTP request. There are some good comments throughout here. And again, if you've got a little bit of familiarity with programming, there's a decent chance that you'll be able to read through a script and kind of generally understand what it's doing. I don't think any of the things are too esoteric as far as, Zeek's logic or how it works. Most of this is just around understanding what some of the variables and options are that are available. Okay. Any questions about if you have any questions about the guts of the script, please feel free to ask in the Slack channel, and there are folks that can help. I am going to bounce out of here. Again, kind of to finish up here, the key thing that you want to take away from here is remembering this export section and being able to look at that and see what things are logged and what options are available for you to change the behavior of Zeek. And we'll actually be playing with the HTTP options in a short bit. So let's bounce out back to the fantastic slide deck. Right, so that was an anatomy of a Zeek script. So we're going to talk a little bit about customizing Zeek, and then we'll have a little exercise where you'll be able to play around a little bit. I'm not sure that I'm following the question there with where is the HTTP request called from. Maybe one of the helpers can ask a couple more leading questions and fill in the blank there. I want to kind of move quick because we're starting to get a little far into time here. So customizing Zeek. As Fatima noted, Zeek shares Zeek site local. That's local.zeek is the full path to the to where you would do customizations of your scripts. You can copy that local Zeek script, local.zeek, which we will do in a moment. But this is where you can do local customizations. So you could just copy or edit in place the local.zeek and add your own customizations. There was a question earlier about somebody who wanted to be able to watch for SSHs to particular IP ranges that they're interested in. As I noted, one way to do that would be to define a set. So you could define a set of IP addresses that are of interest in that local.zeek file. And then you can write some notice policy to be able to change the behavior when a notice is raised. You can do things like do comparisons. Is this IP, is the destination, or is the resp.h in my set? And if the notice that is raised is the SSH, say, password guessing, then you maybe want to have some sort of different behavior, which you can do. You could also write a simple little separate script. Maybe you've got a script that's a little bit more complex and you don't want to pollute your local.zeek. You could write that as a local script and then just do an at load to load your script, which I think Fatima had mentioned a couple times. And then again, here is where you can enable or disable scripts. And then change variables is one of the more frequent things that people do with local.zeek. So as the example here, we will have we'll have an exercise in a moment. Using good old Nano, we open up our local.zeek. We're working off of the Zeek that is the local.zeek that is shipped. One thing to keep in mind is that this is the place to make changes to your scripts. You really don't want to go out to, say, the HTTP main script that the main.zeek we were just looking at. You wouldn't want to go in there and change that variable because it could be overwritten by future installations, whereas local.zeek should not be changed in future updates. So that's a stable place to make your changes. In the example here, we're using the @load command to load the header names so that Zeek will start listing all of the header names that it sees going back and forth between the client and the server. Sometimes those header names can be kind of interesting. We'll note here that you can see what the file search path order is. So if you run Zeek-H, it'll show you the Zeek path value. By default, it looks in the current directory first, and then it looks in a couple other locations looking for that, for where it can load things. As we noted, there's an export section, there's redefinable variables. Like I said, main.zeek, best place to start looking. There's some hints here, right? There's that default capture password. Couple examples, if you're wanting to, say, redefine a value, then you just use the redef argument. And then you'll note here that's that SSH password guesses limit. Whatever the default is, we've decided 15 is better for our environment, so we want to change that. In addition, there is a variable in that SSH script that is an ignore guessers set. And we want to say, if you see SSH, you want to be able to define your orig and your responder, your originator and responder. And so we're saying if Zeek sees attempts from 192.168.1.2 going to 1.20, we don't want notices about that. Maybe you've got a script that, maybe you've got some activity in your environment where there's a lot of high volume automated SSHing that's happening between two hosts. That could potentially create some noise from the SSH script. So we've got the ability to define that table, not a set, a table, define that table, and then Zeek will stop raising notices for those pairs of IP addresses. And note that there's CIDR notation there, so you could have one IP address going to a set of, or a range of IP addresses. And then the last entry here as an example is defining Boolean values. Again, we've got that redef. We define the scope of HTTP, and then we say we want to log the server header names, and we're redefining that to true. So we'll have a quick little 10-minute exercise here. We're a little tight on time, so let's change that to a 5-minute. This one is pretty quick, but go ahead and copy that Zeek share Zeek site local.zeek to your local working directory. Like I said earlier, it's a good idea to make some temporary directory that you can work in, and then go ahead and work through the changes here and see how the log output changes. You might want to run that HTTP auth PCAP first, take a quick glance at the logs, and then change these values and then rerun, and you'll see some new fields that'll show up. And if you've got questions, please ask them in the Slack channel and we will try to help you. So we'll start with about 5 minutes here and try to move through this one pretty quick. Okay. So I am going to stop my share here. We're going to pop out to terminal real quick and walk through this exercise. So let's go back into our working directory. Let's get rid of our old logs, and I'm going to run this, and then I am going to grep fields out of the HTTP log, and we can see all of the fields that are here. And now if we copy over that local.zeek, real quick here, you'll note that I aliased VI to nano because as somebody in the Slack was noting, VI isn't installed by default, and I kept running VI, and I didn't want to confuse people with a different editor for people who aren't used to that. So little bit of mess from when I was testing things out. So let's remove our. This will actually work perfectly fine. So I had those values already set in my local.zeek when I ran it, but if I run that script again, or that pcap, and then I run that same grep, you'll note that there are that the fields are no longer available that were there. Well, they shouldn't be there. Well, that's weird why they're there, but we can look at the actual HTTP log. So we added those header names. So if we look at, and I'm going to find that command because so I don't remember who offered this up, but -x20 is a pretty slick way to line up those columns for you. So if we look across here, we were wanting to enable HTTP header names, and we wanted to start logging the username and, or rather the password that may be passed if someone is using. That doesn't actually line up the way that we had hoped, but we'll see in the fields name, there's the username and password. And now when we look, we can see that someone was using the password of ETH students. And then if we go a little further over, well, there are not many header names in this one. So I know there are in this one. Oh, right. Helps if you have the thing enabled. All right, using the same one here. Now we look, we see still no header fields. Well, that's odd. Try the capture one. Oh, thanks, Fatima. Jeez, promise I do this for a living. Key point there, missing the local argument. So if I don't run with the local argument, it doesn't load local.zeek, and it doesn't do any of the things that I wanted it to do. So let's go back to our local pcap. Boy, oh boy, that's embarrassing. All right, so now we have our, right, ETH students is our username. Now we actually have a password that was passed. We could track down the user that did that if it's in our environment and gently suggest that maybe they don't want to use basic auth. And then here's your client header names and your server header names. And there are lots and lots of them that are available. Yep. I totally missed the local there. This is why you should store your commands. But again, you can see that by changing those two variables, we ended up adding a bunch of header names, and we end up getting the capture passwords. Maybe in your environment, you might want to see if those passwords are being reused. If a person passes a password in basic auth in plain text, maybe you want to test that against your users, and be able to see if they're reusing passwords for their central authentication. And then again, maybe your IR response is to force a scramble or force a change on that password. And yeah, as Veronica notes, Zeek cut password. I'll show that real quick. Right, we can do Zeek cut. We can just get the password field, and then we can look at the HTTP log, and that shows us super quickly. And again, if you pass the username as well, now we get those pairs. So let me pop back out here to the slides, and we'll keep moving along here. The redef, so I'll just right. So as Fatima noted, that's the that's the command that you would want to run with local.zeek. And then if you want to enable those default capture passwords, that is the redef that you would add to that local.zeek. And then the command line is the command that that Fatima pasted into there. All right. Life with AirPods. Battery life on those ain't so great. Yep. Same as on the slides. Okay. Oh, well, let me hand the reins back to Fatima, unless we've got some additional questions on that exercise.
Okay, so let's talk about ZKG now. Next, my slides visible okay to everyone? Cool. I'm not seeing any yeah, cool. All right, so let's now talk about ZKG. So back in the days when we were not like when Zeek was bro, the basic use case that I give of explaining ZKG is like back in the day when when I was starting with Zeek, I never really wrote like my personal scripts. I always started with using somebody else's custom scripts to detect the anomalies and whatnot in the traffic. And the way I used to do it was people have a lot of cool scripts, custom scripts written in Zeek on their, well, back in the days in Bro, and they would just publish them on their GitHub accounts, right? So they are, the way I used to do it was I used to download the script, I used to move it over to my isolated system where we are running Zeek, and then I used to manually load it in the right like site directory and then load it in the local.zeek. So there were like a lot of steps involved, right? And then there was not a central repository for looking for to look for all those kind of cool scripts that people have contributed over the years. So then considering all those things into the mind, the Zeek developers came up with the concept called Zeek Package Manager. that kind of like provided an easy way to share and distribute the scripts from the community out there, and then an easy way to install and load it in your Zeek installation. So just like the operating systems, like just like Yum has their own Yum is their own package manager, package repo manager system, and then package manager tool, and then Ubuntu has their apt-get. Similarly, Zeek also, ZKG has a similar concept that if you use ZKG, you will be able to load the policies and scripts that other people have contributed over the years, and they have converted those scripts into the Zeek package, and then you would be easily able to load them in your installation. So just skipping through all those manual steps in the process of going out there, trying to find out a script, and then downloading it on your local system, moving it over to your Zeek production, and then loading it manually. So all those steps were skipped over. So that was one of the benefits of having Zeek Package Manager, that it's a central repository where people have converted their Zeek scripts and Zeek plugins and whatnot into Zeek packages, and then they have published it out there for the community to use easily. Right, so you use Zeek Package Manager to install and load new scripts and custom scripts and plugins to your Zeek installation. So that was a little bit of background of the how Zeek Package Manager came about into the picture. So the command is pretty straightforward. It's ZKG. So before 4.0, there has to be like ZKG was not included in the by default installation of Zeek. But if you are running Zeek 4.0 and later, ZKG was included as the by default built-in installation with Zeek. And you just need to install the independent dependency of ZKG to make it work. So that was all the things required to run ZKG in 4.0. So the Docker image that we have provided, it has ZKG installed because we are running 4.0.3. All I had to do was just one line of pip install of the dependencies that it depends on, and we were good to go. So as I mentioned earlier, that you can actually add new scripts and analyzers that are converted into Zeek packages and available out there in the Zeek package repo. And then you can just, by using ZKG, you can, in one command line, you can just download it and install it in your Zeek installation. And we will be going over some exercises where we would be using different scripts out there that are kind of like Zeek packages now, and we will be installing them and running them in our local Zeek installation on our Docker image. So analyzer examples, and some of the people mentioned in the chat that if they want to write a protocol analyzer, where should they put the code in? And then there were responses that said that, well, you can actually create a plugin, and then you can have those plugins installed additionally on your Zeek installation. So you can actually add the analyzers and custom analyzers to your Zeek using ZKG, and some of the examples are Quick and PerfSonar. And then for scripts, if you have written scripts in the past and you have not converted them into the packages, there is a pretty easy way to convert them as packages and make it available centrally in the central packages repository that Zeek maintains. That ZKG, that is the source for ZKG. So ZKG looks for all the packages that are available out there in the central repo. And you can also check it out. The link that I have provided on the slide, https://packages.zeek.org. That is the website where you can find all the packages right now. There are, I think, over 100 packages right now that are available in the Zeek central repo that are Zeek packages. And then you can go through them, and then you can install whichever interests you in your Zeek installation. So that was a little bit of background of what ZKG is and how and why you should use ZKG. Okay, so now let's use Zeek. So I'm going to show some of the commands that you can run on your Docker image, and we will be installing some of the packages that are available out there. And then we have some exercises where we would be explicitly looking for packages that can perform some of the tasks that we would like it to perform. So I'm just going to pop into the shell really quick, and I can show you how to run those commands. Okay. So if you guys have ZKG installed, this command should show all the options available with ZKG. So if you just type in zkg.h, zkg/h, you will see all the different kind of options that are available out there and different kind of commands that you can use with ZKG. So the basic ones are, if you want to list all the packages out there right now in the Zeek packages repo, then you can just do a ZKG list. Well, first of all, ZKG refresh. And then do a ZKG list to show you all the packages available out there right now. There are 180 packages right now that are available out there that can be easily installed using ZKG. So we are going to install some of them. Let me just do this so that it's easily readable. So there are different folks who have contributed packages, and then there are scan scripts, and then the PDF analyzer, zip analyzer, and whatnot. So what I'm going to do is I'm trying to install a CVE that is written, a Zeek script that is written by Johanna that detects the CVE 2020-0601. So what I'm going to do is I'm going to install it in our current Zeek installation. It asks you if you want to install it, and then you say yes. So look at here. So it says it's installed and it is loaded. So where exactly it is installed and where exactly it's loaded. So if you go into so if you go into your site folder, which is our local folder where we can have customizations in our Zeek installation, you would see a new folder with the name CVE 2020-0601. That's the package we just installed. So if you and then there is another one that's called packages. So if you go to the packages, it has automatically added that that package in my packages folder. So if you go and check it out, the Zeek packages, it is loaded by default, and it says that you do not make any modifications because it is managed by ZKG. So every time you install a package using ZKG, it is dropped into the site folder, and then inside slide it is dropped into the /packages folder, and it is by default enabled in the or by default loaded in the packages.zeek. So you don't have to do anything to load it manually. But there is one thing that you need to do before you actually load it in the Zeek, and that is you need to load the packages into the site local.zeek so that it can add all the packages that are by default enabled in the packages folder. So that's what we are going to do right now. I'm just going to edit the local.zeek, and I'm just going to, so here it says here uncomment this to source a ZKG's package state. So I'm just going to uncomment this line, and that line is going to tell Zeek that now load everything that is inside the packages folder. And right now it just has one package because that's what we have installed right now. So it is by default going to load this file, and then this file by default loads packages.zeek. So we have successfully loaded the CVE 2020-0601 package just by running literally two commands, by loading it in by loading the packages inside local.zeek, and then by just doing the Zeek install. So that was a pretty easy and quick way of doing the installation of packages. And I showed you this, that if you can check if it's installed in the site folder, and then you just have to load the packages in your site local Zeek. Now, how to so this is all about you have to want to unload it, you want to install it and load it, right? But there is another command in ZKG that makes it easy to unload a package. So right now we only have one package installed. So if is this right? No, I think it's list installed. So if I do zkg list installed, it's just going to show me the packages that I have currently installed on my system. So when I did previously when I did zkg list all, it listed all the packages that are available out there in the Zeek source repo. But when I do a zkg list on install, it is just going to show me the current packages that I have installed and enabled on my system, which is this package we just installed on our system. And if I want to install it, okay. So another thing, ZKG info, if you want to see if the package is actually enabled by default, you can do a ZKG info on the package, and then it will show you the installed status. And it says the current hash of the package is this is the version. Is it loaded? Yes, it is loaded because we saw the packages.zeek file, right? And in here, it was loaded by default. And then if is it pinned? False. So there is another command in ZKG that helps you pin and unpin a package. So for instance, how it is used. So you are doing a ZKG upgrade, but you do not want the packages that are installed with Zeek to get upgraded. Then you can pin them and say that I don't want this package. Or you are doing a package upgrade using ZKG, and you can pin the package and say that I do not want that package to be updated. And I just want it to remain like whatever the current version of the package is. So that's what the pin command is used. And the another useful command I wanted to show you was unload. So if you do an unload on this package, it is going to unload it from your current installation. And it will ask if you want to unload it, and then it says unloaded. Okay, so now if I check the info again, it has loaded is false. So previously it was loaded as true. And now since I have unloaded it, it is false. That means now this package is not loaded anymore, which was loaded before. So you can easily load and unload a package without even editing the local .zeek file. So that's super easy and pretty handy. What if you want to purge everything that is installed on your system? So what you can use is you can also use another interesting command, which is called zkg purge, and it is going to purge all. It is going to remove and delete all the packages that you have currently installed in your Zeek installation. So now you don't have any packages installed. So now see it is that whole directory of the packages is gone. That was before that was previously added. So when we did a packages list, it had all the not this one here. When you did the ls on the site, when the package was installed, it showed the package that was installed. But now when you have purged the package, and if you do an ls again, it doesn't have that package anymore. And even in the packages, it doesn't have that package loaded anymore. So this is the easy way to purge and completely remove the package out of your installation. And now if you do a zkg list again, it should not show anything because no packages are installed right now. And then these are other useful commands: remove, pin, unpin, upgrade, and refresh. So zkg upgrade command is used to upgrade the packages. But if there are certain packages that you want to pin that you do not want them to be updated, then you can pin the package and everything else will get updated except that package that is pinned. So that was a quick primer of how zkg work. I can, these are pretty small and straightforward commands. So if you guys want, I can paste the commands, but it's just like literally couple of characters long command. So yeah, let us know if you need the commands to be pasted, and I would be happy to do so. Now we are on the ZKG exercise. So we have two ZKG exercises, and I will just go through them quickly. So the first one is there is a package called JA3, and what it does, it fingerprints the TLS clients that are connecting to your TLS servers, and it then dumps out that TLS fingerprint of the client in your SSL.log file. So we are going to install that package, and then we are going to run Zeek. We are going to enable that package, and then we are going to run SSL. We are going to run SSL pcap and see if we have new fields in the SSL.log file.
Apologies, I'm distracting Fatima with some Slack messages real quick. So we can do this one as a quick 5-minute exercise. It's a pretty fast exercise, and then we're getting pretty tight on time. So I think we're going to need to adjust a little bit of the material we cover. So while we give everybody 5 minutes to do the install and run against the PCAP that's listed there, we'll adjust on the fly here and try to make sure we get as much as we can out of this. So we'll give 5 minutes, and Fatima, if you want to leave your screen up so that people can see the commands, then we should be good to go.
Sure. So these are the commands that I'm also running. So you need to install JA3, and then it should be enabled by default. If you have done this, if you have added load packages, every time you will install a new package, it is by default enabled. So all you need to do is you need to install a JA3 package and then run the SSL PCAP against the local, and it should produce the hashes in the SSL.log file. So I'm just going to leave it like that. And then you guys can run through these 3 commands and see if you can see the hashes produced in your environment. Okay, so I hope you guys were able to install JA3 and run it against the ssl.pcap and were able to see the two additional fields. I am just going to quickly show you as I ran the same package. So I installed ZKG package JA3. It got installed and then it was loaded as well. And then I ran the Zeek with the ssl.pcap with the local. And then I'm just listing that right now it is installed. And if I run it on the pcap, I will notice that in ssl.log file, now there are two new fields called JA3 and JA3S. And those were the fields that got added by this package. So if I can just do Zeek cut on JA3 and JA3S, looks like there was a single connection from a client that had the either single connection that had this TLS client fingerprint hash, or there were multiple clients exhibiting the same TLS fingerprint. So this is pretty handy and useful if you have a database of known bad TLS clients, and then if you are just doing a fingerprinting on that, and then you are just comparing the hash with that client, it is going to kind of like tell you that which clients are connecting to your networks. That is pretty sleek. So I hope you guys were able to also see those two fields, additional fields that got added to your ssl.log, and then these were the fields that were the result of JA3 package. So there is another quick exercise I have on ZKG, and that is another very important one that we keep kind of like getting a lot of use from. So the another one is the file extraction. So there is a package written for extracting the file, and then what it does is it's by default has some of the it has some plugins to extract particular kind of files like PDFs or Excel files and whatnot. But what I'm going to do is I'm going to install the file extraction package, and then add all types of file extraction, because we would want to see that what all files are transpiring on our network. And then I'm going to read the pcap extract.pcap with local, and then there will be a new folder that gets generated when you install this package and then run it against a pcap that has some kind of file transactions happening. Extract files is the folder that gets generated additionally in the logs folder, and then you should be able to see all the files that Zeek was able to extract out of that pcap. So I'm going to leave it like that, and then I'm going to run it for really show you how that works, and you guys can follow along if you can. ZKG install file extraction. Okay, it looks like it's installed. So ZKG. So we have two packages now, JA3 and file extraction. What I'm going to do is I'm going to add the all kind of file extraction that I want in my pcap. So I'm just going to add a plugin that comes with this package. File extraction config. So inside packages, the file extraction package should get loaded, and it has a config.zeek. And it has the different plugins that you can enable and disable. So by default, it only extracts the common exploit types. But for this exercise, I'm just going to add a plugin that it comes with that is going to extract all the files for us. So I'm just going to add this line. In that config file for that package, so that it now can extract all the files, and then I'm going to write it out and then close. So this is the command I used. You can edit that config and then add extract all. And then all we need to do now is the package is loaded. All we need to do is now read the pcap and then see if Zeek is able to extract the files. Okay, so now apart from all the log files, there is additional folder that gets generated, which is called extract files. So if you go into that folder, you will see all the files that were in that extract pcap, and Zeek was able to extract them. Some of them are PNGs, JPEGs, GIFs, and then some of them are just text. And it will also tell you that in which protocol it saw that file transaction, and then and the hash of that file, so that it doesn't get overwritten by other files. So, and then the type of the file. So that was pretty cool. So these were the files that Zeek saw in the transaction. It was able to extract them. So if you had any executable that Zeek might have seen in the traffic, it would have absolutely extracted that executable as well. So that was the exercise for file extraction. And then how you can use the file, how you can use file extraction ZeekAG package to load it. So it was just like 2 lines of commands, and you were able to extract the files out of the traffic. So now, so those are the 2 exercises. I have published the commands, the 2 commands that I used, and then hopefully you would be able to get through it. And I'm just going to hand it over to Keith to talk about logging framework.
Thank you, Fatima. So we are running really tight on time, and I really, really want to finish exactly at the top of the hour so that especially people who are going on to Ashish's training afterwards get a nice little 30-minute break here. So we're going to skip around a little bit. We may not even be able to get through all of the frameworks. We will be sharing the slides. The slides have good detail about how to be able to do the logging, the log processing. The exercise has the answers to the exercise in the notes section. So you'll be able to kind of pick up a few things when you've got a moment. And then if you've got questions, I think this chat room will stay open for at least the duration maybe of the talk of the conference. And you could maybe ask questions in there, and we can kind of try to help out a little bit when we have a moment. So right, we were going to talk a little bit about, again, this is just common, Unix tools. Some of you that are Linux users, this will be old hat to you. For some of the other folks, give a look at the slides and give those a whirl. So we're going to talk about the logging framework, the notice framework, and the Intel framework. We'll start with the logging framework. So this is the framework that creates all of the logs that you generate. And this is where if you wanted to go in and make some changes, you would go in here and be able to, commonly, I think what people do is apply filters. As we discussed earlier, the filter of filtering out those con S0, those single packet flows that are likely associated with scanning. So a couple of real quick concepts here. I apologize, I'm going to try to whip through this really fast. Zeek, in the logging framework, you have streams. Streams define the fields and the types. This is essentially defines what the log will contain. Then there are filters applied. Each stream has a default filter. That default filter just logs everything that comes through in the stream. Where you can start playing around is maybe you want to change the name of a file. So you want to change the path. You may want to change what gets written into there. Again, that is changing a filter. And you do that in the old way, you do that with predicates. And I'll actually show you something in a moment, and we'll be able to do a little sidebar. Again, there are writers that are part of the logging framework. As we noted earlier, there is an ASCII, by default, Zeek logs in ASCII format. There is a Kafka writer, so you can actually have Zeek write the files over the network to a Kafka host or Kafka cluster, and then be able to feed that off into something else. And then also within the logging framework is where you would change from ASCII, default ASCII tab separated output to use JSON output. And at the very bottom of this slide, you can see this is a redef. and we're just saying we want to use JSON equals true. And as somebody noted in the Slack channel, that opens up the whole world of JQ. If you're really familiar with that command line tool, then you'd be able to start using all of the things that are part of JQ, or do other handy things if you like JSON output. So I'm going to kind of run through this. We won't have much of an exercise, but I'll walk through it. I will. So again, we're using the common capture.pcap, and we have this logging script, script that is in the training resource directory called logging.zeek. So let me pop out to that shell and be able to show you folks that stuff. Okay, so, all right. So the first thing we'll want to do here is we will just use the, we're working off of that capture pcap. Let's make this a little different. Apologies, we're kind of adjusting on the fly here. So if we look at this logging script, we can see that we have an event zeek.init. Key thing to relay, I will do this in the Slack channel right now. In that logging.zeek, there is a typo. You will, if you're looking at that script right now on your local image, you will see that that IP address that's defined is 192.168.1.0. You'll want to change that, and I will note this in here. So you'll note that mine has 125.0. We changed up a pcap at the last minute and missed a little thing in here. So again, my apologies on that. So the first thing that we have here is we've got this Zeek init. We're defining a local filter. So we're wanting to change that up. And then we've got a little bit of logic here that basically says if the orig.h is not in that net block, or it is an IPv6 address, then return, which basically says we want to print that log. So if we run Zeek against that capture log, and then we want to load that logging script, and this is what I wanted to highlight here. So a little sidebar. Zeek has two main branches with each major release. Someone asked earlier about what's the difference between 3.0 and 3.1. I'm going to focus on 4.0 versus 4.1.x. So 4.0 is considered the long-term support version. We release a version once a year that is a major bump. So the next major bump that will be coming will be 5.0. As there are bug fixes, security fixes, or major impactful bugs that need to be fixed, we would increment that version number to 5.0.1, etc. The only changes that happen in that LTS branch are, again, things that are significantly impactful, security issues, or if there was some major performance issue that was found, that would be fixed. There's the 4.1.x branch. That is a feature release. You can expect a couple, at most, I think the policy had set, at most we don't expect more than, say, 3 major feature releases over the course of a year. 4.1.x is where the Zeek developers start introducing new features that are a little bit bleeding edge, gives people a chance to run them without having to run off of the master branch of Git. But you know, if you're looking for something that's long-term stable, you want to stick on that 4.0 branch. We're teaching off of the 4.0 branch because we want to focus on the long term. But as you can see here, there's a warning that's being raised that in 4.1, there's going to be some new policy hooks. They're going to change they're actually changing the way that logging is handled and making log filtering probably a little bit easier for people to interact with. When we do this training, hopefully in person next year at ZeekWeek, we will have to update because we'll probably be on to a new long-term version by then. So for the moment, don't be panicked about the warning that you're seeing there. So as I noted earlier, we had made a little change with this script that said, don't log anything that's in that 192 range or if it's IPv6. So if we look at con.log, we can now see all that's being logged is 127.0.0.1 because that's the only traffic in this PCAP that isn't in the 192.168 range. So the next thing we want to look at is, and you can kind of play along at home. So if we comment out that return, the next one, what we're saying here is we want to return, i.e. don't log, if the con state is S0. Remember earlier when we talked about S0 is those single packet flows. So now if we've made that change, yep, and then we write it out. Just to give a quick demo, so if I just run on the capture PCAP and I wait for the little Mac to work and I grep for S0 in con.log, we can see there's a whole bunch of single packet flows that are in here. Well, if we now pass the argument to load our logging.zeek, where we've said don't log it if the con state is S0, and we run this. Now, when we do that grep command, we can see we get no results returned back. So we can see that our filter actually worked. Now we've filtered out those con S0 entries. So the next thing we're going to do here is if we actually comment out this whole section here, oh boy, that looks messy, doesn't it? And this is something that someone specifically asked about in the Slack channel. And you've got this logging.zeek file is in your is in the image that you've got. So you can make use of this elsewhere. So if we write that out, and now if we run Zeek, and trying to get past the little. Now we can see there is a new log that has been written here that is called con-scan. And if we look in here, we see this is where all of our con S0 have ended up. And if we grep for con S0 in the con log, crude grepping picked up S0 somewhere in, it's in the UID, but there's nothing in here that has the con state of S0. So we can see with using this logging filter, we were able to filter out some logs. Maybe we don't care about log traffic that comes from a particular net block, or in this case, we are now dumping con S0 out into a separate log file. So now we can slurp up con.log with, Logstash or whatever tool we're using, shove it into our seam, and we're not burning millions of dollars to companies that offer log storage. And so I will hand off to Fatima. We'll see if we can get through the notice framework very quickly. And again, we're going to have a real hard stop here at the top of the hour so everyone gets a chance to take a breather before next training. It's all yours.
Thanks, Keith. Okay, so let me share the screen real quick. Alrighty, notice frameworks. So So we have been mentioning about the interesting analysis that Zeek has in the policy scripts, right? So where exactly Zeek logs those interesting events wherever it finds that in your traffic. So for example, if you have policies that can detect the SSH password guessing, or if it can detect the SQL injection attack. So all those events that are triggered by those policies will be logged into the notice.log. So basically, Zeek provides a notice function that can be called in any kind of script and any kind of analyzer to register the interesting events that you are seeing in your traffic. So if you want to have a custom detection as well, you can call that notice function and then pass along the information corresponding to that connection so that it gets logged into the notice.log file whenever it sees that particular interesting traffic or event in the the event corresponding to the traffic in your network. So Zeek has this way of providing a way to the users to raise notices whenever they find anything interesting in their traffic. Another important thing is notice framework has built-in suppression. So the notice function that is used, and I will show you the notice function that is raised at anytime there is some interesting traffic going on in the scripts. And you can also see that in the policy scripts, some of the policy scripts that Zeek comes with. So there is a built-in notice suppression. There is a field called identifier. So anytime you are calling the notice function, and if you provide a field called identifier, and if you provide if you provide the information that is repetitive in your traffic. So for example, I want to suppress all the notices from a given source IP, source port, destination port tuple, then I can use the source IP, source port, destination port in the identifier field, and then I can tell Zeek that, hey, if you see that for a tuple, then all the notices, consider that as a duplicate. If you see all those four values in the same log, and you suppress the triggering basically for all those same four fields in the network. So anyways, and after that, there is another way of adding more actions and adding more functionality to Zeek, functionality to a notice framework by calling out hooks. So there is a particular hook called notice policy that you can call to either add an action or suppress it, or by default change what is logged in that corresponding notice function when it is called when that interesting event happens. So a lot of high-level theory there, but we can quickly deep dive into raising a notice by ourselves. So as we have been mentioning that there are some scripts that are that Zeek comes with, and one of the script that I wanted to mention is the miscellaneous scan. It's by default disabled in the local.zeek, but just out of curiosity, if we have that script enabled, then what it will trigger, what notices it will trigger in the traffic if it sees the traffic that is corresponding to the heuristics that Zeek uses to detect a scan. So I was just going to show you quickly that how the notices are triggered, because so far in all the exercises we haven't seen a notice.log file. So let's quickly do this exercise. All right, so notice framework there. So all we need to do right now is edit the local.zeek and enable that script, that policy script for scanning, so that it can raise the notices anytime it sees the scanning traffic in your network. So site and then local.zeek, and there it is. So I'm just going to uncomment this line and then do a write out to the file. And now our local.zeek should be all set to detect scanning. And we do have a PCAP that has some scanning traffic. So let's run Zeek through that PCAP and see if it is able to raise the notice. Zeek, training resources, and then the map PCAP, and then local. Alrighty, I'm just going to put this commands real quick in this Slack channel so that you guys can follow along. Okay, so we will see that we can see that now there is a notice.log file generated. So let's take a look into the notice.log file. Okay, so there is just one notice that got triggered, and it says the scan, port scan, and it detected a port scan from this IP. Okay. This IP, and then there is a message. So this is the note that is that what notice framework has logged, and then the message is something elaborated string that can tell more information about what Zeek actually has seen in the network. So this is the notice that got triggered with the message saying that this IP kind of like scanned at least 15 unique ports of this host in the traffic. So this was a pretty quick and dirty way of showing you guys how the notices are triggered. And you can actually, there is a script that shows in, I'm not going to go through it in here in the session, but there is definitely a script called notice.zeek, and that you can play around with. So when I was telling that there is a function that is called, so there is an event called connection established. So what this script is doing is every time there is a connection established event that gets triggered, like for example, Zeek is seeing a new connection and there was like a proper three-way handshake and the connection was established, then all it is doing is it is just calling the notice function, and it is forwarding this information to the notice function, which has a note called Zeek, and then giving it some connection info, and then just a basic message that I saw the connection. So this is all you need to raise a notice every time you see a connection step. So this is just an example. So if you have any custom logic and you want to raise notices based on your detection, then all you need to do is like just 2 lines of the code and then just extend the enum type so that you can have your new type of notice, custom type of notice that you want to see in your notice.log file. And this is the hook that I was talking about, the notice policy. It enables you to add more actions. So by default, whenever you raise a notice, it is just going to log in notice.log file. No other actions will be taken. But notice framework provides you multiple actions that you can take, like you can send an email, you can send a pager alert and whatnot. So you can use that hook to send you the notice via email or the pager alert. So that was notice framework. I don't think so we have time to cover the Intel framework, but I would highly encourage you guys to go through the Intel framework and do the exercise. In just a nutshell, Intel framework provides you a way to load the IOCs. But for example, if you have a list of bad IPs, or if you have the list of bad URLs or emails or domain names that are most common, you can actually load them into Zeek and tell Zeek to watch for those IOCs in the network, and anytime there is a match or a hit in the network for that corresponding IOC, Zeek is going to generate a log file called intel.log, where it can actually log that, hey, I have seen this bad IP in this connection, and you might want to take some action about it. So these are the different areas where Zeek looks for to trigger a match. So for example, for address, which is like the IP address, it looks for in the connection in origin and connection response. If you have hashes that you are going to load in Zeek, it is just going to look the hashes for a match in the files framework. And then the DNS FQDN name, it will look into the DNS in request and in response. So these are the places where it basically looks. And then anytime there is, so if you have Intel database that you have loaded in Zeek, any change to the database will reload it, but it will not by default remove the old entries that are removed from the database. So for that, there is a boolean meta.remove that is available in this policy script that is currently set to false, but you can set it to true so that every time there is a change or removal of that Intel, the database gets reload, and then the new Intel refreshed version of the database is available to workers. Do notice if you have this enabled, then in addition to log it in intel.log file, Zeek is going to log that Intel match in the notice.log file as well. And then there is an exercise. There are like 3 steps that are involved in enabling the Intel framework, and this is the exercise basically that you do. It's pretty straightforward. But if you guys try it out, and if you guys have any problem, then let us know and we would be more than happy to help. So that was just like a brief intro to the Intel framework, and I know it's not like a whole lot of information, but I just want to make sure that we are right on time.
Alrighty, we are at the top of the hour. Thank you very, very much, Fatima, and thank you for everybody for being patient as we kind of whipped through the end here and adjusted on the fly. We will make the slides available, and we encourage you to go through the slides, and we both really encourage you to give us feedback. Were there areas where we were a little thin or went a little long? Give us feedback, we can make changes, and that will help to improve the training going forward. Thank you again, everyone, for attending. We hope that you learned stuff from this, and I will hand it over to Amber.
Fatima and Keith, thank you so much for another impressive training. I'm sure the community is really glad that you're doing this. And for those that may know of people on the wait list, we're going to have another class in November, so watch for that. I don't know that Keith and Fatima will be teaching that, but their materials are so good that we're going to try some train the trainer things. I will be making the slides available later today because I'm downloading them and re-uploading them to an area where we can share them publicly without being password protected. We'll also make this video available a couple weeks after ZeekWeek ends, mostly because the post-production takes a little bit longer than I like to admit, but like we'll get it there. So if you've got questions, we're gonna leave this channel up. I don't know that Keith and Fatima, I don't know if they can stick around. Can you guys stick around in case people do have questions and you want to answer them live? I think Ashish is going to be joining in about 15 or 20 minutes, but we're going to leave this open throughout the lunch break. So if you want to continue the conversation, Slack is there. This will be open. Just let us know. But thanks again, everybody, for joining us on this morning session. And then Ashish will be doing hands-on Zeek training. He'll be joining in about 15-20 minutes, but he'll start at the bottom of the hour. So with that, anything else from you guys?
I'll certainly hang around for a little bit, and if people have questions, I'm happy to try to answer them until I think I'll stop when Ashish pops in here so he can start getting ready and take control. Thanks again, everybody.
Yeah, me too. I will be available on Slack, and then I will be able to answer the questions regarding any kind of trouble or questions people have with Intel framework or Notice framework if they are trying it out. And yeah, I'll be hanging in there for some time to help out with Ashish's training as well. Thanks everyone for attending.
Hey, Fatima, can you return host back to me, please?
Sure.
Thanks.
I'm not very good at this, Amber. You have to guide me how to do that.
I got it. I've got it. No worries.
Oh, thank you.
Yeah. It all comes together.
I was trying to see the option how to do it.
I am just changing my name on here so people know we'll start again at hands-on. You know what we didn't do? We didn't do the drawing for y'all's session, but I'll do a random generator and send out a notice to somebody in the channel.
Cool.
All right. For those that are still on the channel, if you're in the Slack channel and you're still watching, I'll post it. Fatima, if you could post this in the channel as well. Curious to know, one, how long you've been a Zeek user. Like, are you, less than a year of using? Have you been using Zeek for like 2 to 4 years, 4+? Like, can you drop a little note into the Slack channel as to just how long you've been using Zeek? And if you thought of things that the training didn't cover for the introduction, please let us know that as well. You can drop it in the Slack channel. You can message me. You can email me. You can respond through your Eventbrite link, those type of things. There's so many different ways you can give feedback. There's also a survey at the top of the in the topic for the Slack channel. So please take a moment to fill out that survey. We'd really appreciate it, as it helps us improve what we offer the community, and we get to iterate a whole lot. So if you could take the time to do that while you're having some lunch and kind of catching your breath and all that, that would be great, because you'd help us out a lot. So thank you so much. Hello, Ashish.
Hi, Amber. Good afternoon.
Yeah. Are you meaning to share your Slack channel too?
No, no, no.
I didn't know if you were meaning to share that or not. Yeah, it looks like you're sharing okay and all of that. So
Okay, I think.
thank you, Fatima.
Thanks, Amber.
Yeah, thank you. How many slides do you have today, Ashish?
Oh, just 138.
That is awesome.
Yeah. No, actually, I don't know. Like once we start the training, I think one of the first, you asked me a very good question. One of the first thing I was going to say is that I am not in any rush to finish all the slides. I think my plan or idea is to actually get the point across like early in the training session and see if people can grasp the basics more actually. So let's see.
I know people are excited. And I've been letting everybody know that we'll run another training in November. And those people who are on the wait list
Hi, Amber, you around?
it looks like I dropped for a moment. For those who are in the Slack channel and watching on YouTube, did the YouTube video drop? Can somebody let me know?
Seems like YouTube video was working.
Okay, I just want to make sure. Let me ask in the Slack channel. Oh, goodness. Goodness. This is like live demos, you know?
Tell me about it, Amber.
You know, I mean, you know how this feels.
Okay, let's put water behind so that I don't spill it.
Let's see. All right, Ashish, I'm going to make you host just in case I happen to drop again. I'm not sure why that happened, but just in case. You may be host now. Are you? Let me look. Nope, I am. Let me make you host. Let me rechange my name. Well, we'll leave it. I'll make you host in just a minute. Let's see. Let me fix this. And then. All right, you are now the host. So just in case I drop or something, you're good. Looks like the YouTube stream is still good. And at the bottom of the hour, in about 9 minutes, I'll introduce you and you'll be able just to take it away.
Okay.
So. All right, what was I getting ready to do? Ashish, while we're waiting, I was gonna ask, could you share, like in the 8 minutes that we have, can you share the most significant item that would, like, what event was what possible breach or event did Zeek prevent in your history of using Zeek? Did you know, can you talk about a memorable one that just kind of sticks out, some activity that Zeek caught that you were like, wow, but for that, we wouldn't have caught that? Is there any unique stories you can share from how many years of using Zeek now?
Oh, quite a bit actually. So yeah, there are some unique stories. I think most of them ultimately fall down into this idea that, I wrote this heuristic and I didn't think this would catch something else. And that is where you actually get very excited about stuff. Like, for example, just like anomaly, for one time I remember, like the heuristic written was simple, just like, okay, how many, like how much two hosts are talking to each other, and that was based also on connections in the bytes, and turns out that it actually ended up flagging these like top talker, and ultimately ended up becoming a pretty interesting incident. So the like stuff like that. Other times have been like chasing the bad guys and then expanding on the heuristic. That is also very interesting. Long ago, if you can remember, IRC bots used to be the thing. So like what miscreants would do is use BNC and all kinds of stuff. So once you start seeing that action, then the Zeek policies were written to actually start flagging all that. But then the bad guys will just keep evolving and changing things. So like they would use base 64 encoding. So now you actually end up adding base 64 encoding inside your like detection heuristic. Then they would do something else like transmit credentials over DNS text record. And now you actually are like, oh, okay, let me go and add something there. So the more you understand the attack, the more versatile the heuristic gets. But I think my favorite ones are generally when you are writing detection, things should like light up like a Christmas tree, where multiple alerts happen for somebody who is trying to either exploit or already is successful in exploiting and is in misuse phase. So that's generally the crux of like Zeek heuristic ideology, as well as like the fun of writing, as well as using the detection. And I think it's more like when the other people who are in the team are using it as well, where they actually are able to rely on your heuristics and they know, oh, this is worthy of being a text message because it will always catch the right thing. So I think that also becomes a pretty fun part of this entire exercise.
I think the stories are great. Like I hearing
so I remember, like, okay, when talking about the story, so one time I was in supercomputing conference running Zeek at supercomputing. I cannot quite remember. I think it was in Tampa, if I recall right, or maybe plus minus a year. And at that time, there was all this like malware downloads happening. And what bad guys used to do was like they would download binaries and name them like GIF or PNG. So like sitting there, you ended up writing this detection, which was like the incorrect file type, which was a pretty lame detection. Like if it's a binary, but with extensions of PNG or GIF or JPEG, just flag it. And my God, like we were finding like these droppers happening like fall season, like a whole lot of them. And I think ultimately that evolved into Seth writing like file analysis framework where you can actually dig deeper into this and then into all kinds of files coming in. So that was one of the things like beginning of like, oh, here is a good idea. And then how it ultimately shapes up into a pretty strong heuristic. So it starts like pretty like proof of concept, lame idea, like, oh, this is a binary. Let me see if it has extension of JPEG. But then when done right, it ends up becoming like dissecting the file, doing things properly. So like, I think there are eras. Drive-by download was a pretty good era. And that time we ended up with vulnerable versions of Flash in Java. There was an era where SSH credential theft was big. There was a whole lot of heuristics for that. Currently, you know, the fun one is Bitcoin detection. John Civic, I believe, wrote that one, but I'm running that package. So every time Bitcoin hits the news, you see a Bitcoin heuristic fire in a day or so. Like when Bitcoin hit 10,000, there were 3-4 times it alerted and there was Bitcoin miner. Likewise, when Bitcoin went 50,000, then again. So you see all these different patterns. So even if you're not keeping track of news, you just see when the heuristic hits, there has to be something going on with Bitcoin that time. So
that's awesome. Like, you know, you're one of those folks like others in the community that have been using Zeek for so long that, you know, I often joke with people who ask me about your class, and I say that he's probably forgotten more than I will ever learn. And you know, I just think you're one of those personalities and Zeek users. And so when I know you've given your talk about, you know, the top 10 things you wish you'd known when you got started, and in these last few minutes, I'm going to let the channel know we'll be starting in about 2 minutes. But what would you say in all the years you've been using Zeek was the most painful lesson that you learned on the use of Zeek?
Oh, actually, that's such a good question, Amber. The most painful lesson which I learned and I'm still living is being hesitant. Not going in and changing things inside Zeek, actually. Like I remember way back when I was starting to use it, the idea was like, okay, do everything in the site folder where you rediff the variables, you create your own notices, write your policies, but don't go into base and policy directories. I mean, nobody told me. I think that was just my mindset. And I would not make changes there. And it was hard. Like sometimes you have to just go and start changing things internally. So I think that is what was the most painful lesson I learned. Do not hesitate. Zeek is a great capability. And don't restrict yourself following like, oh, here's how Ashish is doing things, or here's how the package is written. Just go, make changes, do things. I mean, of course, with sharp knife comes a warning that don't cut your own neck. But don't hesitate to still do some kinds of dissection. So I believe we are at 12:30. Let's start. I'm not sure if Amber actually is around or again got disconnected, but hello everybody. I am Ashish Sharma. If you are seeing this and looking at my screen, I have a laptop on the side where I actually have the Slack channel open. I will keep an eye on there. And then we have a bunch of people who have kindly agreed to help us answer the question. So I'll keep an eye as well, and I'll keep training. So my idea here is actually not to rush through the slide or like overburden things. I think I have a great art of throwing a lot of information out. But this time I will try to see if I can slow down and make people understand things. So you can download all the exercises from the Zeek training GitHub. Here's the URL. In case if you haven't done it, please do it now. And then we have to go into, and you know, by the way, I realized way too late that this will download everything. Last year's training, Fatima's training, this year's my training. So you get everything for free pretty much. But go into folder ZeekWeek 2021 hands-on scripting. And if you haven't installed Zeek yet, I would assume and think that after Keith and Fatima's class, you should have Zeek running on your system. But if you haven't yet done that, please do a Zeek install, follow this thing. This URL docs.zeek.org, en current install.html. Pick your taste. Is it OS X, Ubuntu FreeBSD, and then do it. I think by the time we will need Zeek, you will already have installed. Like I think I have a few filler slides before that. So let's start. So this is hands-on Zeek scripting. I am Ashish Sharma. I work for Lawrence Berkeley National Lab doing cybersecurity there. A little bit about Berkeley Lab. I think those who have seen my talks before have pretty much seen these slides. So Berkeley Lab, pretty much the idea is science first. And we are right next to UC Berkeley campus up on the hill. And it's a Department of Energy Research Lab, primarily operated by University of California. And there is a rich history of scientific discovery. I mean, the roots of Manhattan Project belong to Berkeley Lab, but there are 14 Nobel Prizes. There is Nobel Prizes in climate change. I think the last one happened last year. And that was the 4th since I got to the lab. And this is the tradition. Whenever there is an announcement, they print a paper copy. I wish I would have images of each one of like the last 3 of them. But we are living in the COVID times, and I'm kind of, I will accept that I'm kind of disappointed that I have to do this remotely this year too. Last year, I was like, okay, we will do it remotely. This year is just unfair to be remote. So apologies in advance. I think I could do a lot better job being in person, live in the room with everybody around where I can actually walk, talk, and help. So bear with me in case if you have questions and stuff. Slack is there, my email will be there, and I will be available. So here are some of the names to the fame, specifically with cybersecurity and networking from Berkeley Lab. You folks have heard of Traceroute, libpcap, TCP-dump. They are all coming from Berkeley Lab. So it's pretty good historical significant place. And then if you haven't read Cuckoo's Egg, I think this is a pretty good read too. And of course, early origins of Zeek, which used to be called Bro, has its root from the lab too. So here is the deal. And this is from the last time if you look at the notes, but here's the deal. Like any programming languages, there are going to be 10 plus ways of doing something in Zeek script. And I may not be teaching you necessarily the right way to do things. Like, you know what, if you do it this way, this is the correct way. I'm teaching you a way to do it. Like, here is how you can do this. Here is how you can do this. And then I'm teaching you like do's and don'ts based on my experience. But the idea here is to convey the overall understanding of like what Zeek scripting is, what its capabilities are, how to think about writing scripts, how to actually think about heuristics. And I'm really hoping that, you know, everybody in this session ends up writing Zeek packages and scripts much better than I ever do. And that way I can actually start utilizing your packages too. That is ultimate goal and win here. So Zeek scripting, I mean, a whole, like pretty much all the slides are actually made out of Zeek manual. So they like, it's pretty much open source. Everything is documented. Everything is out there. The value I add to this material is some of my experiences or some of my lessons learned. So if you actually have to start Zeek scripting, this is a very good resource to go to, docs.zeek.org. So I would definitely encourage people to go here. There is a documentation subgroup too. If you find shortcomings or documents are not of your liking, definitely join the documentation subgroup. That would be a great help too. And then there is another URL I would like to talk about is try.zeek.org. Last year after my training, Justin told me to actually go and upload this training to try.zeek.org. I said, I'll get it done in 2 weeks. It has been a year. But anyways, maybe someday we'll have the training here too. But try.zeek.org is pretty good. And actually most of the material from the training, you should be able to like upload the PCAP or run the code here. But at the same time, you can do it on the command line as well. So I think most of the people are aware. If you are not aware, definitely check out try.zeek.org. It's a great resource again. So, and like here, I think here's one of the things which I did, like, you know, like one of the module, like test scripts, I uploaded the PCAP and ran it here. And this is how it should look like. The output would come here, and this is pretty much what you are going to see on the command prompt too. So try.zeek is pretty good resource. Now in this training, it's pretty similar to, not similar, it's pretty much what I gave last year. And I didn't change a whole lot of things. I will talk some things which have changed or improved or are little different. But my thought last year was like, you know, different people learn things differently. So my idea here is to cover the fundamentals, tools, tricks. I will talk about theories and then exercises and examples. So what I did is I tried to actually draft this training into 3 parallel streams. Like right now, I actually have no idea who my audience is. And any smart speaker or a trainer, actually the baseline is know your audience. So, you know, you are running blind. So what I ended up doing is I broke it into 3 streams. There's this collection of streams which can be used as a reference to understand the concepts. And that's the beginner's level. And then I know that I learn a lot by doing things and fixing bugs. So then like each of the exercises also has find the bugs. So when you are writing it, actually most of the time when you are writing code, you're gonna anyways create your own bugs and you will have to deal with that. But if you are running the code, you can go and run, try find the bugs exercises and then try to fix them. That will get you a pretty good understanding. Then there are tasks and there are these problems which are like at intermediate to advanced level. But if you're comfortable and it's like, oh, Ashish is being boring here, I would encourage go try to do those. And then I was really hoping, and this would have been a magical thing where, you know, there is this continuous development of a new heuristic. So we start from scratch and by end of the session, we have a package. Maybe like someday we'll be able to do it. Last year, not able to do it. I don't have very high hopes this year, but there is one thing and I will keep working on it. So the idea there would be like start at step 1, step 2, step 3, step 4. And by end of the training, I will like, even if you don't follow the package because it's overwhelming, we have scripts, find the bugs, then there are tasks. I will still cover the package at the very end. So the training layout is like the entire training is broken into chapters. And each chapter actually, like I'm covering fundamentals of the scripting, then like we'll get into how events work and what are functions and hooks and stuff. And then we'll talk about the container types which Zeek provides. And they are powerful resources to use in the scripting land. We'll talk about records. We'll talk about logging, notice frameworks. I will actually talk about configuration framework because that's my new favorite framework currently. And we'll talk about input framework. How do you scale? How do you use probabilistic data structures? And then we'll talk clusterization. And if this all we are able to accomplish this, we'll actually even get to chapter 11, which is find the password. So let's see how we do. if you have questions, definitely interrupt or ask me. And or if I am going too fast, not clear, you want more depth, definitely feel free to say, because sometimes when you ask questions, a lot of other people are thinking about the same thing, just that either they are not asking or they are not able to think that this is the question I wanted to ask. So I would encourage doing that too. Like in a room, we would be doing a lot of back and forth interaction. Now, each chapter actually is laid out in this manner. We'll have fundamentals and basics, then we'll have the use cases. And this is where I bring some more add-ons to this session, like what use cases are, why and where you will need it. And then the exercises will have problem statement, like generally, I think I call it question. Then there are like high level solutions. And then there are further questions, which becomes the task. And then there are find the bug problems and extra credits. So if you know scripting, you know a lot, you should definitely, I will say, try extra credits. And that will actually get you at least some exercises, if not, at least some production running code too, or at least basis of new heuristics. So before we start, and I think this is one of the important slides overall, because if we can get this going, then we should have pretty much most of the exercises done very easily. So I would say that, you should create this alias Zeek, which actually is Zeek dash capital C and then E, and then we are going to redefine the filtered trace detection enable as false. And the reason we are going to do this is because a lot of PCAPs we are using in the exercises, the traces actually are filtered. Either they only have control packets, or they only have half a session or something. And this will always, if you don't do this, you will see a warning, which is like this analyzed trace was determined to contain only TCP control packets, which may indicate it is pre-filtered. And by this, so this gets a little annoying. So if you are okay with it, remove this part, otherwise you will see this. And dash C is to actually not look at the checksums. Generally, when you are doing the traces and anonymizing the IP addresses or other information, then the checksum gets broken in the PCAPs too. So create this alias, and let's see, I'm going to do it with everybody else too. Can everybody see the fonts on this properly? Okay, so let's just create an alias. And now we have the alias. And the second thing I want everyone to be able to do is Zeek-H and be able to see if you can run Zeek. So this is the only requirement right now. And if we can do that, I think we'll be fine for most of it. And another thing is, like, each of my scripts actually in the exercises have a corresponding PCAP. And the PCAP has the same name as the script which we'll be running. So, and if the script does not have a trace in the trace directory of the PCAP, that means that script does not need any PCAP. So that's a convention I'm trying to use here. So here is the chapter 1, which is like any programming language. Let's do a hello world. So what we are going to do, do you want the fonts bigger for the slide deck or for the command prompt? Okay, so let's see if I can put the alias here. 1 second. Okay, so here is the alias, and I think okay, so let's go with this font size, and let me know otherwise. Okay, this will be hard actually. I apologize. removing the yellow background would become little tricky. I mean, we can do white background. Okay, so let's try. How is this? Is everybody okay? Okay, here you go. And let's, oh my God, okay, still small. How about now? Okay, I think you will have to get used to this. I don't think I'm going to do a black background with white and white background with black. Apologies. Okay, so let's just go to run this first exercise. So if you go into Zeek, so I take everybody is in this Zeek hands-on scripting folder, and let's just go to 00 directory. And if you run Zeek, okay, hold on. Okay, clear. Let me just give me 1 second. Let me just set things up. Okay, so let's start this Zeek, and then all you do is 00, and you should be able to see Zeek in it with hello world output on there. So is everybody able to do this much? So you get on Zeek 2021 hands-on scripting in the directory 00 exercise hello world, which is the very first directory. If you do a ls-l and then run Zeek with 00 exercise hello world, and you should see this output. So this means that we are able to run Zeek properly. And this is like if you cat the file, you should see is a simple hello world, which is Zeek init, and then Zeek done. So Zeek init says hello world, and Zeek done says Zeek done. I feel good, and actually, honest to God, I feel good right now because like at least we got to this part. So this is definitely useful. Okay, so what this actually does is let's. I can see on the Slack like pretty much most of the people are able to see that. So now what's actually useful here is actually these two events. There is a Zeek init event and there is a Zeek done event. So the Zeek init event happens at the very first thing which happens when you run Zeek. So of course, there's a lot of things happening before where it's loading all the scripts and the packages and the BIFs and all those. But when you're running your script, Zeek init is the first event which will happen. And then Zeek done is the last event which happens with your end of the script. And what uses is Zeek init and Zeek done are in the real world. So, you know, you can actually set up variables, you can set up constants, You can do redefinitions, if any, right? I don't do these as much anymore because you end up using input framework and configuration framework. And talking about that, you can use Zeek init to read tables into input frameworks. You can do Zeek init to read or manipulate values using configuration framework. You can create different log streams. You can define and create like different filters for logging frameworks. We'll go into all those things. And then you can also schedule like timers and events. And Zeek done is generally like summaries. So like you have a scanner going on and you want to get a summary of like finally how many IPs did it connect to, how many bytes, how many ports, how many connections. You can do those kinds of summaries at the end of Zeek done. You can do a lot of cleanups as well, purge the tables, clear values, or if you have to do other things like send notifications stuff. And then you can also use backend stores. If you have backend stores, then you can actually use those to preserve states. For example, like I have used Postgres as a database for backend store, and I have used Zeek then to actually send commit values into the table, which are actually currently in my recording set. So this is Zeek script. Now we are getting to the real stuff. So what is the basic structure of a Zeek script? And in this slide from 21 to 27, we'll be talking about a very high level overview of the script, and then general sense of what script actually looks like, what's the skeleton is, what's the structure are. And then we'll look a little bit more. And this is a little dense section in terms of theory. Why do you want to write a Zeek script is the very first question we should answer. So personally speaking, why do you want to write Zeek script? Because that's the capability I have. There's so much I would like my tool, my intrusion detection system, my network analysis tool, or like as a security engineer, there's so many things. It's like, it's nice to be able to do this. It's nice to be able to do that. And generally what we end up is like, oh, it's nice if this tool has that capability. But what Zeek ends up doing is that, even if it does not, it allows you to do it. And that capability comes with Zeek scripting. And Zeek scripting is just one layer. A layer before that is there are Zeek plugins, there are BIFs you can write, then there are protocol analyzers you can write, and then there is this core Zeek code, which is C++. So you can go all the way from like core Zeek code, which is C++, to BIFs, which is an interface between C++ and the scripting world, protocol analyzers. Then there is, like, I think previous session talked about Robin's spicy too. So all that, but script actually ends up at the very top layer of user interaction with Zeek. So it's a communication medium between Zeek's packet processing engine and people like us. And it also gives us an mechanism to access these different data structures, which the Zeek core is populating. And by that, I mean, let's say you actually have a email SMTP traffic flowing in your network. So Zeek's protocol analyzer is going to parse that as email. It will populate its own structures for that particular email, like, okay, who the message is from, who the message is to, are there CC lists, where is the origin, what's the subject of the message. And if I want to tap into that, I can actually use a Zeek script to be able to tap into that. So between the packets and logging, you can actually access all these data structures using the script. And then it definitely allows you to write new detection heuristics. And then sometimes not only heuristics and detection, like it's not only about like catching things, it's also about creating new resources. So like IPv6 does not do address resolution protocol. What it does is this router advertisements and solicitations. So how do I get the binding between those MAC addresses and IPv6? So you tap into ICMP v6 events, and then you tap into these router advertisement solicitations and get that data. And now you have a new data set or a resource, which actually is the bindings between IPv6 addresses and the MAC addresses. There, you can use script to do directives and policy enforcements. DHS has a policy of no Kaspersky in US government networks. So, you can enforce that. You can write those custom scripts to be able to do that. And then you can also decorate your logs with your custom data set. And like a very simple example is that, if you want, you can put GeoIP information in your logs. So that would be like extending and decorating. Do you want to do it or not is a other conversation which we'll have as we move through the slides. But this is how a very raw bare bones skeleton of Zeek script looks like. So each script actually is part of a module. So generally when you're writing your own code, you actually create like module training, for example. And then what your script can do is it can load different scripts as well. Think of it like C header files or C++ header files too. And then there is this section called export, where you define these different variables and data structures like sets, tables. And if you put them in the export section, then you are able to reference those outside this different module. Otherwise, the declarations generally have the scope in the module only. So these are like exports are for scope manipulation. Scripts have functions. Functions can be just pure functions, which used to be historically called like procedures if they don't return a value. And then there is functions which actually return the value. And Zeek is basically an event-driven engine. So everything is event driven. So you actually have like Zeek init is an event, then there are connection events. So there will be events. Events will call these different functions, and that's how you will start manipulating. But this is a very high overview. So what you do generally is you tap into your desired events, you fetch the data you want from those events, you manipulate that data, or you add on to that data, take an action or write a log. So that is generally how you will go with it. So this is actually, I just kind of populated the previous skeleton. So now you have a module called my module, and then you load and like your other scripts, which are helper scripts or base scripts or scripts coming from other, like if you're using functions and event functions generally from other code. So you can do that. Here is this declaration. So I said global number, my event is an event, my function is a function. And then you will have events called different events or functions. And then there is a hook. So now this is actually a dense and an important slide. If you are not paying attention, please pay attention on this one. So Zeek has three fundamental code path executions. One of them is called events, which is pretty much the basis of everything which Zeek will be working on. So Zeek is an event-driven engine. If something happens, Zeek fires an event for it. So if there is a new connection, like if Zeek sees a SYN in the PCAP, it would actually fire an event called new connection, for example. So events actually get fired in one of the three ways, either from the event engine itself. So after each packet is processed, the event queue gets flushed, and then there are limits to it, like how many events can be flushed, like 5,000, 1,000. So those are like details which Zeek actually has by default, and you really don't have to generally go and change those. So event can be fired by event engine itself. Event can be fired with an event statement. So you can say event, for example, what we did here. So we actually, I don't think I have, did I call event? Yeah. So you can see like in an event, you can actually call another event. So you can do something like that. And then event can also be scheduled in the script, and we will see that as we talk more. So that is the event. Now, functions can be inside an event, they can be inside a hook, or they can be inside another function. And then hooks are also invoked similar to events. But I think generally, like for now, as we move forward, I will go into details. But for now, hooks generally is something you don't really have to write, but you will end up using different hooks most of the time in notice frameworks, where you are going to be using policy hooks to do certain manipulation. So again, now events don't execute immediately. Like, you have an event, boom, it goes on. No, event gets added to an event queue, and when the event queue gets flushed, event will execute in that particular order. But the way things run, it's pretty instantaneous most of the time, unless you are overloading or doing something really wrong. So it's not that, you schedule an event and look, you call an event and turns out like half an hour later it would run. No, it's not like that. Events don't return any value, unlike functions, which may or may not return a value. Hooks may or may not return a value. Generally, hooks return a true or a false. Most of the time, that's how people will check that. But even functions can return more manipulated data if you want, including records and structures. So you can have multiple events inside with the same name. So like, let's say I have an event called my event. So, I can actually say event, my event, and then I have argument address. And then later on in another script, I can say event, my event, have an argument, and then I can do something else there. So you can have multiple instances of the same event handler. But you can only have single body for a function. You can, and I think that was the shortcoming, due to which multiple hook bodies can be defined, and hook actually got that capability. So now in terms of events, like when you have multiple events going, like my event, and then there is another my event, and then another my event, sometimes you want those events to execute in a certain priority, and that can be influenced with this directive called ampersand priority. So if you say my event 1, my event 2, my event 3, then when they run, they would run with a priority. Functions have nothing like that, but hooks definitely have the functionality of like priority, which can influence like the order in which hooks will be executed. So if you look at this slide, generally like a hook is a hybrid between an event and a function, and that's how I generally end up seeing it. As we look more into the code, you will get more familiar with it. But if you get confused, I would encourage to come back to this slide and then look here. But even then, more than this, go to the Zeek documentation and read about events, functions, and hooks, and it will be a lot more clear. One thing definitely with hook, which has bitten me quite a few times, which is like there is a difference between a break and a return in the hook. So when you put a break in the hook, then the execution immediately ends. So like even if you have multiple instances of the hook, like hook, my hook in another script, hook, my hook in the third script, if there's a break, the rest of the hooks will not get called. But if you say return, then only that part of the code, like the part under the return, will not get called, but the execution will go into the second my hook and the third my hook. So you cannot return values from the event, and function can or cannot return, may or may not return value. So this is a dense slide, and I will accept it, but it will help you further down, and I will walk through these details as we move. So here is a little snippet of like how does the event work. So like you declare event as like my event, and there are 2 arguments to it. And then in event new connection, you can actually call your event, and then you can pass the argument. Or you can do is you can schedule an event. So you can say schedule 5 seconds and then say my event. So 5 seconds is when after which this will fire. And sometimes you need to schedule events. Like if you want to do something periodically, let's say every 30 minutes you want to send out a report, you can schedule 30 minutes, my event, and then say report. So something on those lines. Then hooks actually, so here is an example, like you have hook, my hook, with a priority 10, then you have a my hook, no priorities, and then there is a my hook with priority -5. So this priority is defined order of execution. But the deal is, I think what you need to pay more attention is the difference between return and break. So, this hook gets called priority number 10 hook handler, and then with no priority, which is the default priority. So it will come here, there is a break. So this will call this, but this is a much lower priority of -5. So what will happen is that, this is the first hook, this is going to the breakout, and this will never happen because you have a break here. Had you put a return under print, S equals to by will have never been assigned, but rest of the hooks would continue if there were no break here. And functions, actually, most of the time you are going to use functions as like function foo, and you are going to put whatever arguments you want. Functions do have a functionality of actually calling with one single argument, and then you can default other arguments. I have not used this ever before, actually, so I cannot say more about like where this might be useful versus not. Maybe like base scripts have used this more often, but I generally end up using functions with the parameters instead of relying on the defaults. So this is actually just a high level overview of script. And so how do you look at the Zeek script? Oh, can I break down what an event is doing? So, okay, so what an event generally does is that, you know, and I'll talk about this little later as well. Let's say you have a TCP connection. How does the TCP connection work? There is a SYN, SYNAC, and ACK, and then there is this communication going on back and forth. So if like Zeek core engine is going to fire an event when it sees a new connection, then it actually sees a handshake, which is SYNAC, and then it sees a ACK. So it will fire different events at different states of TCP transition of that connection. And those events actually will have the values populated in the connection record, what it has seen so far. For example, when it only sees a SYN packet, it will actually say, I saw a SYN, and it fires an event. And that event, you can actually look at it. So let's pick a simple example of scan detection, which is just SYN flood. So you only will see SYN, 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 SYN. And you can say, oh, I only saw SYN. So you tap into that event, you count how many SYNs you saw, and based on a threshold, you can fire another event or a notice saying that, you know, 25 SYN only are seen here. So again, not to confuse people, but a Zeek core event engine parses protocols, populates different records and data structures, and then gives you these events, which you can tap into, and then you can call functions or hooks or other events to actually start manipulating data or generating alerts. I hope it answers, otherwise it will clarify a little bit more. So what your script does is that it represents either heuristics or helper functions. Then one or more scripts make a package. And then these packages become detection platform. And I would highly encourage, when you're writing Zeek scripts, write them as a package. It simplifies life significantly, especially when your package also has the testing and everything inbuilt there. Then you make changes, you don't have to worry about breaking other things. So, and then one or more package makes your detection platform. So you can go to packages.zeek.org, you can download all or some of them, and then you can like, I have heuristics for this, I have heuristics for this, I have written heuristics for these. So the script is actually by default, Zeek loads the script using local.zeek, which is actually in your share Zeek site folder. So all your default scripts are loaded from local.zeek. So if you go and look into this directory, you should see what all has been loaded, and you can actually like comment it out. And if you have your custom scripts, then you can actually set up site policy path and site policy scripts in zeekcontrol.config. And we will go through it. If not, remind me and I will show you how you do this. But you can definitely say, so let's say you have custom scripts and they are in like home, Ashish, Zeek, my Zeek scripts. So they are in this directory. So what you can do is you can say site policy path is home, Ashish, my Zeek scripts. And there you can do another Ashish's scripts.zeek, and then you can load all the different scripts there. So you generally have to use a at load to be able to load a particular heuristic or a script or a package. So, all the scripts are generally, so base has scripts. If you look there, you'll see a whole lot of scripts. These are like fundamental scripts, which are the closest, which talks with the Zeek event engine. Then there are policies, and then there are sites. Generally, it's recommended that you put your stuff inside, or even if it's outside the site directory, then you can set it up with your policy paths. And then, so this is generally it. So here, actually, I think what you can do, so this is an old Google search. I think we should do is version 4.11. But if you just do a simple Google search of Zeek scripting, you will actually find docs.zeek.org, and then it says writing scripts. I will again encourage you to go look at this thing. So don't worry about this. The latest search still says the latest versions information here. So this is just a high level overview of script, but now let's actually get into a little more hands-on stuff. So I'm gonna like, what do the scripts do? Like scripts actually do either create new heuristics, manipulation of data, tapping into the existing events, tapping into the data structures, using them, formatting. But for everything, what you really need is this data types, different data types. So if you're coming from programming background, let's say, for example, C. Now C has different data types. There is a character, there is a long, there is an int, there is an unsigned int, so on and so forth. So what Zeek does is that consider it like any programming languages, but with a specialized data types. And those include, because Zeek is a network driven engine, it actually gives you this functionality of having very specific data types. For example, IP address is a data type address. There's a data type called port. There is a data type called subnet. So we'll go through the basic data types. We'll go through obvious like use cases, and then we'll talk about like how you define what are the scopes of local and global variables. And then we'll start the exercises and hands-on stuff. So, and if you think that, you know, this is getting like, you know, all this stuff already, this is boring, this is not for you anymore. So I would say just go to 002 exercise here, and you can start. 01 exercise. So you can start going here and then go to scripts, and you should be able to see all these different things. So you can start running this code or try to find the bug. But for everybody else, I'm going to just go through these. These are very fundamental things, and I think a good understanding would help here as well. And I don't see any questions so far. So, which basically means I can move slightly faster. So here are the basic data types which Zeek has. There is a Boolean, then there is a numeric type like count, int, and double. There is a time-based type, which is time and interval, which are pretty useful. So when you're scheduling things, you don't have to say like 5 minutes. You can create a variable called next run and of the type time, and then you can actually say 5 hours and then things like that. There's strings. Pattern is a good data type to explore. It's a regular expression matching. It's a very powerful one to use. Of course, then I was talking about like there are network types like port, address, subnets. Then there are these containers, and we will go through all 4 of them. And these are really useful ones to have. So in this entire training, if you are tired and you're like, okay, this is how far I want to learn, you should definitely learn until table, sets, and vectors. So, and then there are these executable types, like you have functions and hooks, then you have files, and then opaque. So we'll get to opaque when we get to those points. And then there are certain places you can actually even use a data type called any, but I think that gets into very big subtleties of writing scripts. So for now, I don't want to confuse myself going here, but as time comes, we'll talk about it. So here is this thing, like the way you will declare is like you have like the port type is like SSH port, and you can say 22 TCP. So later on you can just use is destination port equals to SSH port, and then you can go. But you know, sometimes 22 TCP is not enough. You need 44 TCP, you need 22 TCP, and so on and so forth. So for that, you can actually in fact create a set of port. And this is a container type. So now you actually have a set of ports, and here's the set of all these ports which are interesting to watch for. So same way, there is a subnet type. So you can say, you know, my VPN subnet is this, or if you have multiple, you can create a set of subnets and now you can keep appending to it. Pattern matching is extremely powerful. Primarily, you can use that in like more deep protocol analysis, for example, emails or HTTP or other protocols. Yes, yes. So if you want, you can go into like 0-1 exercise and try to debug. Definitely, if you think that you know this stuff, definitely go and try that out. So then there is this address type called like address. So, you know, you can say authentication IP, which is an address 1234, and time. So when was the last reply from this IP? You can create a time thing. And you know, what was the duration of that connection? So that can become an interval. So like last seen minus first seen, and that gives you interval. So these are like fundamentally network centric data types. So and these are, you will keep using them often and often. That's why I like you to actually pay a little more attention to these things. So now what you can do is you can also redefine these types. So let's say by default, you're using certain Zeek provided data structures, and now which is already populated and you need something more. So what you do is you use this directive called redef, and that allows you to redefine with this thing. So you can say redefine watch destination port, and then you can add a new port. So what I generally end up doing is that I write these scripts, and then if I have to add certain very specific customizations to my own site, I actually have a different file called site.zeek. I call it lbl.zeek actually. And then what I will do is I will redefine and then add values. So this is a great feature to have, but please do remember there is a plus equals to. So if you make one mistake here and instead of plus equals to, you have an equal to, all the previous declarations will get overwritten just by this, and it will get reassigned to 22 TCP. So if you want to append, make sure that there's a plus equals to. Needless to say, a minus equals to works as well. So, and same goes for like pattern, where you can redefine and then you can keep adding to it. So, but redefines have one shortcoming, and that shortcoming is that you need to restart Zeek for these to be effective. And as Zeek, like you don't like to like I don't like to restart it if it's running fine. So what ended up happening is that the Zeek team created something called a configuration framework. So where instead of declaring it as like a global or local, you declare a variable as an option, and then in your script, and then you say that, you know, look at this file and read everything from the file. So next time, if you need to add something or remove, you go and add to the file or remove from the file, and it will automatically get populated to this particular variable. So configuration framework is right now one of my favorite frameworks actually, because of this specific functionality. I can declare all the things I want to watch for, and then I can just go and add and remove in the files. So this happens real time. It is cluster friendly. So if you change something, the changes get propagated everywhere, and it gets you a pretty good functionality. So now you have all these variables. So now variables actually, like you have these data types which become variables. So you have a data type called my address is of type address. Now you have data my subnet of type subnet. So, but how do you declare them? So recall, like back we talked about local and global. So you can actually declare these different data as local if you just want its persistence and usage locally in your particular code segment. So that code segment can be an event, it can be a function, it can be a hook. So if you don't need anywhere outside, you can just say local and it's fine. So the scope of this A string is local to my event only. But now there are times when you actually need the scope to be more than local. So what you can do there is you can define it as global. So like I created a module called training, and then I have a global called test. So that I can actually use in my event, and then I have a function, and then I have another function. So I can use test everywhere there. But let's say if you have a module 2, then the scope of global will disappear. So the scope of global variable in a module is a module centric. So you only have it in a particular module. So if you want a variable to actually go beyond your module into another modules, you have to export it out. So now when you export it, then this becomes like global test, and then you have a string, and then event. And then in module test, you actually just say, this global was declared in training, and I can run tests. So it would still be able to run it. So this actually is a pretty interesting scope concepts. It's pretty much like C++ too. Like, locals are only scoped in between the parentheses, and then you actually change different scopes based on namespaces and different ways. So consider module as a namespace actually, if you are thinking from that part. So now here is a quiz time, and actually I don't even expect a lot of people to know this, but here are the things. This gets me a good insight. When I was writing this slide last year, I thought of putting this in here. So like you can declare a variable called a port, and a port is actually is 22 UDP less than 22 TCP, and this is the power of Zeek. So it allows you to be able to do things like this. So you can actually say a port, and then you can say, is it equal, is it greater than, is it less than? But how do you define equals to, greater than, and less than? So if you look here slightly in the lecture notes, you can see that when you're comparing order across transport level protocol, unknown protocol is actually less than a TCP, which is less than a UDP, which is less than ICMP. So for example, 65535 TCP is actually smaller than 0 UDP. So here, if you run this, you will know that, the TCP is small less than UDP. So this condition is true. So the A port will hold the value of 22 UDP. But you can also say that this particular port protocol is unknown. So I can see traffic on 22, but it's of kind unknown. Same way, you have the IP addresses. So you can compare IP addresses. Zeek actually goes a little more smart too. So, oh, by the way, I forgot, like I wrote this in written, not to forget. But when you're doing a port level comparison, make sure that you lock between the boundaries, because you say something like, if port is less than 4000 UDP, ignore. That will ignore all the ports from 0 to 65535 for TCP as well. So you should always lock between the boundaries. Like, if port is less than 0, greater than 0, or greater than equal to 0 UDP, and less than equal to 65535 UDP. So that way, you know that you're only manipulating between UDP ports. So, but here is another one. This is a local. Where is this? Like, okay, you say A equals to google.com. Now, what will happen is that Zeek is smart. It will resolve google.com, get the IP addresses. And if there are 3 IP addresses, A will become a set of address. So Zeek does some smart things like that already. And then you have a set of port, interval of -1, and so on and so forth. So like we are almost an hour into it. I would say I will call first break for, like, let's say 10 minutes. Is everybody okay with the 10-minute break? At the same time, let's start looking at the exercises in the basic types. So I would definitely like a feedback right now. Like, I'm pretty much alone in the room here. So like, are we okay? Are people getting what I'm talking about? Are things easily understandable? Sure, let me know. And if there are questions so far. And while we are at the break, I will do the exercises, but still, I mean, it's pretty much the standard thing. So, so we are already in the exercise here. So there's traces and scripts. So if you go to scripts, you should see all the exercises. So I will say first run yes, Joel. Actually, there is a lot of info to take, and I think I do realize that I throw a lot of information out on people. Hopefully, at least if you don't get the subtleties, you get the high-level ideas about it. And so far, the idea has been that a Zeek script has this structure, which actually is a module. Then you have variables, which can be scoped as global or local. And if you want the scope to be much larger, then you actually export a global variable outside. Then you have events, and we will get into events. You will love that section definitely, where you can tap into the events, and then there are functions, there are hooks. Don't worry about hooks right now. I think everybody is pretty clear about functions, what they do. But in terms of events, consider them as something which is Zeek provided for now. So as of port information, so like because port is a data type, address is a data type, subnet is a data type, you can actually do operations like is a port. So let's say my SSH port. So SSH port equals to 22 TCP. So you can later on say, is SSH, like is destination port for this connection equals to SSH port. You can also say less than, greater than, and so on and so forth. But what's confusing here might be that there are different protocols. So like is 22 TCP less than 22 UDP? Now that gets tricky, because the way original authors wrote Zeek, they said unknown is less than TCP, which is less than UDP, which is less than ICMP. So 65535 TCP would be still considered less than 0 UDP. So, so this concept is generally useful only in one place, where you are like, what, I want to ignore all the ports below 1024 UDP, but that will end up you ignoring all the ports which are in TCP as well. So generally, when you're doing port level comparisons, either do specifics or tie them between the boundaries. Can you explain what colon does? Okay, so let's. Oh, I see where you are. Yes. So primarily, what you are doing is you are declaring the data type. So let's say via.o. I say my port, no, my, local port, and then I call it what data type it is, and then I can say 22 TCP. So this actually gets a variable, declare what particular type this particular variable is. So similarly, if you have a local P, which is of type pattern, and then you can say something like that. So, so yeah, I would encourage everybody to go look at this, these exercises, run them, and like break, as I said, is 10 minutes. So I'm gonna let people like at least relax, if nothing, for next few more minutes. If there are other questions, or if like I haven't clarified these ones, just let me know. So the slides actually are on the GitHub training repo. So if you like, if you look at the folder below, oh, okay, I don't have it on this one, but documents. Actually, how about I show it here? So if you go to GitHub Zeek training, hands-on scripting, you should see the entire slide deck here. Oh yeah, thanks a lot, Fatima. So. And thanks a lot, Anthony, as well. I know you have been fielding questions too. So. Okay, so I'm going to start talking again. So let's go through some exercises. Hopefully people have gone through it. If there are any questions, definitely let us know on the Slack channel too. But so the first one is actually valid, invalid. This is actually a solution to this quiz. So everything here actually is the code you can run. So this code you can run pretty much as exercise 00, valid, invalid, and then look into it, think about it, and you will get it. I think Anthony has a another explanation on this channel too. So let me just get to the second one, which is a variable of global scope. So if we do a less dash s on this, so let me walk through this one slightly slowly, and then we'll go very fast on the remaining ones. So this is a module called training. Now we have exported the variables IP, which is of type address. So if you don't declare it as colon address, Zeek actually automatically looks at it, passes, and understands what it is, what kind it might be. Then there is a net. So this is a type subnet, and then there is an answer which I actually qualified as a Boolean and a false. And as I talked in the beginning, like every Zeek script, if you run Zeek init, is the very first event which happens. So what we did is we created a module called training, and then there is another module called training 2. And in Zeek init, I am actually just doing a conditional check that is IP part of this subnet. So here is the IP 1.1.1.1. Is it part of that /24? Answer is, if yes, then answer becomes true. So we initialize answer as a false. If this condition holds, then the answer is true. And I will get into in and all the specifics later on as well. So don't worry about it, but it is little self-explanatory too. If this IP is in this network block or subnet. So now you call module, you declare a module called training 2, in which you call event Zeek done. And then you can say the answer is, and then if you want to look at IP, you cannot just say IP, because IP is not scoped in training 2, it's scoped here, and it is exported as a global. That's the only way you can actually call it in the second module. So this is training IP, training net, and training answer, and you will see the output as expected. So if you do a Zeek, you can say that answer that 111 is in this, is it true? So this is how you scope a particular variable between two modules with global and export. Let's see. So now if you go back to 00 here, I did the same thing, where here I said SSH is a global variable with a scope of export. So it means that other modules can actually reference it as long as it's qualified with this module. But then here are these local variables. So like IPv4, IPv6, these are local variables. So their scope is only in event Zeek in it. So I think if you're coming from slight programming background, this should be self-understanding. So let's look at exercise 2. This is same module training. I have a set of address, which is 1.1.1.1 and .2. And I said, okay, this is redefinable. And when I say redefinable, that means you can increase the set later on. So I actually did a redefine IP. Remember, it's a plus equals to. If you don't do a plus and do equals to, IP will become just 2345. Right now, IP is 1.1.2 and then 2345. So if you run this code, you should see that the IP is in IPR .2, .2345 and .1, and since the set IP was redefined, it can be expanded. So, and then actually let's look at the third one. So this is a conditional check. We have already done things like in this one, again, like I have a set of IP addresses, I have a port which is 22 TCP, I have a set of subnet, and then there is this answer. But what I am doing is I am actually checking if the source port is less than 1024 TCP, and it will say it's in well-known port. But remember, as I said, like what's less than 1024 TCP? 65535 UDP is unknown. Sorry, unknown would be less than 2. So you are kind of like put it between the boundaries, like 0 TCP and 1024 TCP or something like that. And if this 1.1.1 is in the set of IP addresses, then you print this to out. Yes, redef will just append as long as you are doing a plus equals to. If you do a minus equals to, then it will actually remove that value from the set as well. So, but it also depends, like, if you have a string, let's say there is a string called my string, which is redef, and my string has a name Ashish in it. So if you redef my string to Kevin, then it would actually, my string will hold value of Kevin. So it depends on like what particular variable you are redefining. Is it a set, or is it actually like a string type. String will get overwritten, set will get appended if it's a plus equals to. So now let's do a find the bug. Like I think what we can do is let's just do a simple one. And this is one of the classic mistakes I make actually. So Zeek. So I run this and it actually says that line number 7 syntax error or at or near port. So let's look at the find the bug. And I try to give like certain hints that there is a reserved keyword. So line 7. So let's go to line 7. So line 7 is local port equals to 22 TCP. So, but the error says syntax error at or near port. It doesn't say anything more. So what is happening here is that, 22 TCP is of data type reserved word called port. And I am using word port as a variable. And that's why this thing is not happy. So if I say S port and then run it, it will run. So be careful about reserved words too. And this thing happens with me quite a few times where you are like thinking it's like putting English into language and it's like, oh, if port equals to this, let me just declare something called port or declare something called net or subnet. So this gets interesting in that manner. But yeah, I will say do other find the bugs exercises too. And if you see problems, issues, put it on Slack or we can talk about these later. But these should be fun. They are simpler. And the one which I have marked as hard was hard for me, but later other people have said that this was the easiest one. So let's continue. And let me know if other questions come or you have any, if anybody wants more clarity on certain topics or want me to go deeper into it. So now this is where the real Zeek stuff starts. Like right now, what we have done is A, B, C, D, like alphabets of Zeek, which are like, here are the data types, here are certain things. But now we are going to be tapping into the events. So I'm talking about certain fundamental events. Then also like, how do you go and look for what events you want actually? And then we'll do these exercises. And those who are actually familiar with events as well as all these data types, jump to slide 41, run your exercise. Any questions, feel free to say. Maybe that will help in greater understanding for other people. So here is the deal. And actually, this text here, if you can see this is literally a copy paste from the documentation. So again, I encourage to go read the documentation as well. But here is what Zeek does at the high level, very high level. Zeek reads the bytes on the network interface. So you have a router, it uses span port or it does some tab. It sends these bytes come to your network interface. In a simpler word, you just read the interface and it's good. In a complex word, you use Maricom or other AF packet or something, and then you load balance across different workers. But irrespective, Zeek reads bytes from the network interface. When it sees those bytes, it applies the protocol analyzer. And protocol analyzer is like language of computers. So Zeek tries to understand this language in which computers talk to each other. And they talk in different languages. Like sometimes they talk Telnet, HTTP, FTP. And if you don't agree with the analogy, just you take it in the loose sense. But there are protocol analyzers which understand what bytes are coming from the interfaces. What these analyzers also do is that they organize and structure this entire network stream into right data containers. So for example, like let's say there is HTTP traffic. So it will have a data container called HTTP header. So header has all this different information. So it will actually start populating those different records inside the that particular protocol. Like you have connection, then it would actually find like, is it a SYN, is it a SYNAC, how many bytes are transferred, who is the originator of the connection, response of the connection. If it's an email, where is the mail from, who, subject, so on and so forth. So like these protocol analyzers organize and structures this information, and then they fire these built-in functions which become events. And these are the events which allow us access to the data. So for example, new connection is an event, connection established an event, and we tap into these events to manipulate the data or use those data to make these heuristics and decision. And based on those, we actually are like, oh yeah, here is an anomaly, or here is the ground truth. So most of the ground truth end up becoming the log. So these events fire, and then they ultimately populate the entire record, which goes into log. So when you see a connection.log, that's actually that entire session is like one row is actually one single connection. And then all this thing is going on, and this is where you actually say that, generate me a notice. So this is how Zeek works at a very high level. From packet to notice, notice does either notification or does an action. Otherwise, you see a log. So here, like, let's go with connection record, and like you will end up using these many times. So like if you see, you can go to the like your Zeek install, and then there is the directory called share Zeek base bef, and then there is plugins. So these plugins actually, this is where is like at the very basic of the basis of the core of the scripting land is the interfaces between the Zeek core engine and the scripting land, and everything we build is on top of this. So when you like in this specific example, I actually just grabbed on string or keyword called event in TCP events, and then I just commented out the comments. So now here are these different types of events which TCP analyzer gives you. Like there are new connection contents, connection attempt, connection established, partial connection, partial close, finished, half finished, rejected, reset, pending. So there are all these different, and each one of these actually fire at a different stage of the TCP connection happening. Now, this is like sometimes it's a hit and trial, sometimes reading documentation, sometimes your understanding of where you want to tap into it, you have to tap into that specific connection. So for example, like if you're doing a like a fully established connection, like you want to know if the connection was completely established, like I sent a SYN ACK, and then there was an ACK, and now this entire TCP connection got established. In that case, you will tap into the event called connection established. And one of the things you can get out of that is actually what service is running, and you only know that this is a service running once a full established connection is happening. So you can look at that. Like if you want to see the like at the very end of the connection, then you can actually go into connection state remove. So that's when like Zeek removes or flushes the entire connection state. Now, all events are not equal. Like, when you see events like TCP packet, TCP option, TCP contents, like these are tempting. These are like, oh, wow, I can get to that level of granularity and details. But, like think about it. This event fires for every packet. I do not know of a single person who actually has made a useful heuristic tapping into the TCP packet. So, the useful heuristics are actually slightly above in connection level abstract rather than at the packet level abstract. So, but yeah, this is how you will look into the events. So here are certain tips. Ideally look into the BIF files, go to documentation, look there. Or let's say you are looking at DNS protocol and you want to see what all events are available for me in DNS. So you can actually go into directory called base protocols DNS and do the same exercise, grab on string event and then in the main.zeek, and like you will see all these events. And these are the events which DNS analyzer provides you. Now you can actually ideally simply you can tap into it. So look at, let's say DNS A reply. So now it actually gives you parameters of C as in connection. Here C as in connection, then there is a message which is the DNS message, which is then there is an answer type, and then what is the address. Oh, okay, so here an address. So like here are the parameters, but DNS protocol analyzer has populated all this for you. So let's say you are writing a heuristic which says I want to get alerted for any domain lookup which is undernet.org. So you tap into DNS request, like if you are actually wanting to just see the first request happening, or you can tap into DNS reply, and then you can say is query equals to undernet.org, and there you go. But that is a string comparison, query equals to undernet.org. If you're doing irc.undernet.org, you probably want to use type pattern where it's like query in undernet.org in query, and then you actually do a pattern matching too. But I digress. What we are trying to see here is how to look at the events. So like what events are there and what you can do. So now let's say we are going to, in this specific exercise, peek inside connection event. So like based on different strategies, stages of TCP protocol, TCP reassembler inside Zeek fires these different events. So there is the SYN packet, connection attempt. Connection attempt is literally like I'm trying to attempt a connection to a port which is not listening. There is the SYN. There is no response coming back. So Zeek is going to fire connection attempt. But Zeek will also fire the connection attempt if, like I say, SYN, it's a connection attempt. The remote machine replies back with SYNAC. So then there is like connection first act. So this event will fire, then this event will fire. And then when we are closing the connection, let's say I send a reset, and then it's a half close, then the other party sends a reset back, and it's like, okay, we are actually completely closed. So based on different stages of the TCPs, we will see. So, you know, as I repeat, like I'm repeating this, but connections, like you need to tap into the events which gets you specific visibility. For example, connection established is a fully established connection and lets you create the list of, like, this is just the use case. Connection attempt is for scan detections generally. State remove is like when Zeek is done with the entire connection and it actually either has a half open connection expire or timeout in its state, like it's in memory, or if it's actually something which is completely a fully established connection which has gracefully ended, irrespective, it will fire this event called connection state remove. And I do have links to all this. So if you go to this will get you the documentation. So you need to find the right events to tap into. And I do not expect people to understand what I have said here, but let's go to the exercise 2. And now I will walk through it and maybe people will get a better idea of it. So let's go to exercise 2, which is exercise exploring events. So now you should see is there is a directory called traces, then there is find the bug, there is cautions, and then there is script. So let's look at the caution. So these cautions are for people who already know what events are and are very comfortable with tapping on the events. So like, you know, and these cautions are built upon the first set of exercises. So like, you know, when you look here, there is this 01, which is connection record preview, excuse me. 02 is an event, which is for connection state remove. So, and then the cautions actually are built upon all these exercises right here. So let's not go on the questions first. Let's look at the exercise. So let's go to scripts. So we are going to run the first one. So let's just run this code. Zeek -r traces 01, and then, and don't worry, let me clear this. Let me run this again. So this is what we run: Zeek-r, then go to folder traces, load the file. We need to read the file. And again, the file pcap is exactly the same name as the script we will be running. So if you do this, this is going to get you a peek inside the connection event. And here is a good peek. So what happens is, this junk, this garbage, this jumble of text on the screen is what Zeek stores inside the connection record. So, but like for when you do it every day or often, you will see, like, your eyes will be trained. So like here is this connection ID that is like a data structure inside a connection record, which is the connection identifier, and that has the origin host, origin port, response port. Then there is like for orig, which is the origination IP, which actually has sends in like what is the size, state, number of packets, bytes, and on. Like don't look at layer 2 address because this is generally the address of the router or the tap or the packet broker. So ignore this part, but here is all the info. Then there is relevant info for response. Then there is info for start time, what is the duration of the connection, what are the services, and then there is all these different protocols which haven't yet attached to this particular connection. So they are all uninitialized. But if you look at this, it actually says SSH, like response is 22 TCP. So why is SSH uninitialized? We will talk about that too. So let's go slightly even slower. So let's cat on this file and look at this. So what I did is I actually tabbed into this event called new connection. And how did I know about this event? I actually grabbed on the TCP BEF and I said, okay, give me all the TCP connections. And I see that there is this event new connection. So, and what I did is simple things. Like I said, empty line, and then print me the connection record. So you see this variable like argument here, C is of type connection. So what we did is we pretty much dumped the entire C. And this is just like an event Zeek done. I actually made a help tutorial. But let's just do this again for 1 second because I think it will be useful. So I run this. Here's a dump of this connection, right? This is same thing as here. And apologies, this is too big of a font. But you see, like when you do a con.log, cat on con.log, you see this thing. Like here is this connection start time. Here is the unique identifier. Here is source IP, source port, destination IP, destination port. And then there is all this stuff. But look at this duration. It's a 4-second connection. There is 3000 bytes going, 3600, and then there is SF. The reason we don't see that all in here, like see the bytes are 0, num packets are 0, is because we tabbed into a connection event called new connection. So if you cat on this second script, which is (02), okay, we need to do 02. So now we are tapping on connection state remove event. So this happens, this event will only happen when the entire connection state is completed, the connection has a full graceful termination or timers expire for TCP, UDP, ICMP, and then it will go. So generally the log happens at connection state remove situation or event, sorry. So if we run this, I'm afraid I'll just reduce the size a little bit of the font. Okay. But never mind, I'll scroll. So now you see this is much richer connection record. It has same stuff like what it saw, but it all like we did see like the start time, but now it also has populated duration, it has populated service, which is SSH, which Zeek actually used the dynamic protocol detection to figure out. Like it doesn't use port numbers to identify services in 99.999% cases. And then it also has the history. This itself is like a long 45-minute talk at least. Then what is the connection unique identifier? But then it goes into like SSH protocol. So it will populate the SSH protocol right here and right here. So like this bucket actually is this is all SSH. So it has everything which is part of the SSH log now. So the point I am trying to raise here is that even in TCP analyzer, different stages of tapping into different events can result you in different data. So you need to understand where you are tapping into. And I will give you hints of which are like user-friendly beginner events. So you can always tap into new connection if the use case is scan detection or something like you really need to know. I want to know the very moment this IP tries to connect to me. But otherwise, tap into connection state remove. You will have everything pretty much ready for you. So here, whatever this entire dump of text you see is also con.log and ssh.log. So what happens is, in this case, you have two options as a security engineer. Either you tail on con.log and then do a pattern matching, and tail on ssh.log and do a pattern matching, or you just write a script which is simple, tap into event connection state remove, and then you can actually say, you know what, my address, and then this thing, bad address, and then it can be a set of like bad addresses, and then you can match, like, you know, if this address is like if source is in bad address, generate a notice. If destination is in bad ports or watch ports, generate a notice, and so on and so forth. So this exercise lets you get a little idea, like, so we are walking backwards. So we are walking back from the log into memory, and memory to be able to tap into these different data structures, specifically in this case, connection record coming up. So literally you say C. Now let me just manipulate this a little. So, you know, if I do this, oh. So what I did is, what I did here is that, you know, instead of the entire data structure of connection record, I said, just give me connection ID. And the way I can do reference this is using a dollar reserved symbol. And we'll talk about it in records. I'm jumping the gun. But what this allows me to do is literally, instead of dumping the entire record, it only just gives me the connection identifier, which is this 4 tuple. Are people with me? Any questions so far? Are you able to run 1, 2, 3? Okay, so let's look at 3. So what this does is that, you know, when you run this, now we are tapping into all the 3 different events. There's event new connection, which, as I told, the very first instance the connection is initiated. When I'm reserving myself into TCP domain to become less confusing, you can do something same in UDP or ICMP too. So in ICMP, you use like ICMP request and reply. In UDP, you do something similar as well. So UDP request, UDP reply. So in this case, there is a new connection of type. So argument is C. And here, what we are literally doing is we are going to just say, give me the bytes for orig, which is the origination of the connection, and the response. And then so the idea here is to look at all the 3 different stages of the connection in TCP state machine and see what you see and what you don't see. So let's say Zeek-R traces 0. And then we do a 0, 3. So what this does is that, you know, here, so in new connection event, orig has size 0, packets is size 0, everything is 0, because this is brand new connection. Like this is at the moment I saw initial SYN. Now in connection established, I can see that, you know, state is at 4, but number of packets is 1, number of bytes is 64. And flow label is this, but still the data is not moving. Like this is still SYN, SYNAC, ACK. There is no data in this SSH connection. But when we do a connection state remove, I can actually tap into connection finished as well. But maybe that's an exercise for greater audience to do. But at the very end, you can see that the, you know, the bytes are this, number of packet, the size, yeah, the data size is, the connection size is this, the number of bytes for IP protocol is this. IP, so this includes the IP header and for orig, and then this includes the IP header for the response to, and then here are the number of packets and so on and so forth. So this literally what we did is the idea here was we are only tapping in one specific thing, which is the bytes. but the idea is to look at different connections, and then we see how the bytes get added or enhanced as the flow of the connection happens. And this is what you need to understand as well as use when you are doing writing heuristics. And this is simply a connection record. You can try to do this in HTTP analyzer, DNS analyzer, SSH analyzer. So if you go into like base protocols and then look at this, you will see all the events for different analyzers out there. And then you want to do something with email, you actually tap into the events which are for email. So let me see what else we can do. Oh, so let's look at access inside a connection record. So here is the way you do access. So like, you can dump the connection pretty much like this. But now if you have to use the connection record is made up of a lot of different data structures inside it as well. So like, here is the to access con, you can say $con. If you want to see, remember I showed you the ID $ID, which actually has origin host and response host. So like that's the way you can actually tap into origin, response, destination port, service, and whatever is the connection state. Now, you may not understand this when I'm talking about it. By end of the entire exercise, we may. But if nothing, at face value, go with this idea that if you want to find the origination IP, this is the way to access the origin IP. If you want to find the response IP, this is the way to find the response IP. What event to tap into? You can tap into this event if you want the entire state of the connection. You can tap into new connection depending on, so you choose your type of event and then you can actually pick how you can access the different records. So if you just dump C, it will dump the entire text for you, but this will make it a little more pleasant. So like if let's try this Zeek. So here, so like this is the connection ID, so like, sorry, con info. So con info actually gets you the timestamp and this, and then here's the connection ID. But when I am actually saying, here is the origin IP attempted a SSH session to destination on port 22, that actually comes from here. If origin local nets here, so that info comes from origin, what is the service, what is the response, what is the destination port. So the origin attempted a SSH connection or to response on port 22, and here this is how we actually ended up picking. So if nothing, if you don't understand how connection record is designed, how things are, here is the going by the face value. But at the same time, okay, let me do this on this. So if everybody can see, this is like going into the source code. So you can see like I went into, I don't like this part about Zoom. So we went into, this directory called base protocols con main.z. And this is where the connection record is actually truly defined. So you can see like the timestamp, unique identifier, ID, which is of type connection ID. Then there is a protocol, which is of type transportation protocol, which is actually TCP, UDP, or ICMP, or unknown service, which gets populated. And you see all this stuff here. So just decorations. But here is the response byte. So this is where this entire connection record is actually defined. But this is the source code. What I actually showed you is how to access it in memory, or here is the log. So this is where you ultimately see it in the log. So now we actually see it in 3 stages. You have the packet, then you have the Zeek manipulating it, firing those events, you fetch into the event, and then you dump those information out, and then you take actions on it. So my action is this thing here. So in this one, I say here is a new connection. I say this is a new connection. Here is a connection established. And then I am actually just counting these variables. So connection state remove, and then so on and so forth. And then if you run this, so here is this new connection. Here is the connection UID. This is the connection identifier. But you can see that there is one new connection, one connection established, one connection state removed. And there was no connection attempt because there was not like this was a full connection. There was a SF, there was this entire handshake going on. But yeah, if you can like look at this manual here and see things to try and investigate. So you can try to look at connection attempt versus connection established and so on and so forth. So those are exercise 7 for you. But let me just walk through that one too. So here, this one actually is a richer one because what I am doing is I am creating this event called my event, and it has arguments of IP, which is of type address, and port, which is P, which is of type port. And then I have a function which actually looks at the port and then returns a string. So I say that in my function, if port, we pass argument of port, if it's 22, return SSH, otherwise return unknown. And then in my event, I actually say what is the service name, and then I call my function. So the my event actually says the IP address and the port, and then my function returns SSH, which is the service name, and then it says a connection was made to this, and then we put a service name here. And we do this in connection established event. This is Zeek provided. So this event is Zeek provided. Other events are defined by me. So what I do is I say if this IP is equals to this, then fire my event. And the way I will fire my event is say event, what is the module? So this gets an idea of namespace in which this event is, and then I say response host and response port. So this event, actually these arguments, both of them, what happens is Zeek sees the packet, it goes through the TCP reassembler. When it sees a full connection established, it fires this event. When this event is fired, it actually goes, meets this condition. If that is true, it fires my event. And my event actually has parameters of response address, destination address, and destination port. So that goes here, becomes the IP and the port. And then it calls this function called my function, which provides me the service name. So the output would be a connection was made from this to this on this service. I hope that is clear. So walking through that code, here is this thing. So this allows you to get you a little idea about how to write an event, how to write a function, how to call an event in Zeek provided event, and how to check on things. So it gets you a little more insight. So now there is scheduling of event. For time, I'm going to just leave it as is right now, but I will talk about this one. So what we actually want to do is we want to run this exercise called DNS here. We want to create this thing. So look at the dns.zeek file, and then we want to examine a DNS record if the destination IP is part of this particular subnet. And the idea is that we want to find PTR query, pointer query. And like we see lot of pointer queries. Are they all good? Are they, some are good? Are they bad? Is there a way? So if this is a heuristic we want to do, look at the PTR queries and then see they are good or bad. So how do we do it? So what we do is we tap into DNS events, and DNS actually has an event called log DNS. And all I am doing is I am dumping the DNS record here. So remember for new connection, we did a new connection and C was the connection record, and we just dumped the record. So if you do this Zeek-R, okay, so I need to do is a C. So this is where the checksumming, I think I haven't put the alias, that's why. So if you do this, here is the dump of the DNS record. So this is part of the connection record, but this is same thing as what you see here, DNS log. So, and then here's the solution. So the question I had was, print and examine DNS record if the destination IP is part of this subnet. So if you go and look at 11 DNS solution, what you see is that, I defined local nets as this thing. Again, I redefined it and put a plus equals to. If you don't do it, it actually forgets all the previous values. I tap into log DNS. I said request IP is from record. Here is the connection identifier. Remember $ID, origh. And then I said, if this IP is part of local address, which is actually here, then print the record. So in this case, because our exercise is to find all the pointer query, and if they are good, the first stage to do is to find the right event to tap into, and then look at what that event actually gets us in the data. And that event gets us this information. It gets us timestamp, connection identifier, it gets us the query, and then it gets us query type, which is a pointer query. Then it actually gets us all the different flags of the query. So are people with me so far? Any questions? Is it overwhelming already? And I think what we should do is like take another 10-minute break. If people want to run the exercises, understand, ask question, or any other concerns. And if folks think that the break is not a good idea, we can continue. Walk-in, I'll blame it on Keith and Fatima. They stole the morning time slot. So while we are at break, let me just keep talking. Yeah, this is break. I'm not going to go to like chapter 3 or this. I'm just going to probably just recite what we have done so far, which is we try to see how Zeek scripts are written, and then what is the structure of the Zeek scripts, what are different data types you can look at. And primarily, we actually are right now only manipulating these data types, which are of type address, type port, type subnet. And then the way Zeek works is, again, there is bytes going on the wire. Zeek uses the network card, reads those bytes, runs a protocol analyzer. The protocol analyzer fires these built-in functions, which are events. And those events actually you tap into, look at the arguments which event supplies to you, and then you use those data values of those arguments for your manipulation or usage. And that's what we have done so far. We did this exercise with specifically with the connection record. You can do that with mail record, HTTP, DNS, any other such things. Are folks able to do exercises like are people finding exercises like useful, or are there any problems? Has somebody done find the bugs or the extra credit stuff? I'm glad to hear, Joel, that you are actually doing find the bugs as well. I think I have generally learned by that, and most of the time it's just that I am actually creating the bugs for myself. So, and yes, I'm glad actually the exercises are useful. I think the way these exercises are designed is I try to keep them incremental, step by step. At the same time, like if you can get very familiar with these exercises, this is what you'll end up most of the time repeating when you're writing new scripts, new heuristics. Uh, Ultimately, it's like, you're going to be doing set memberships, you're doing if conditions, you're checking things. So, and most of these are incremental. So if you see that, what's how to do one specific thing, maybe just run a diff and you should be able to see that too. So we'll wait for another 3 minutes. Actually, the fun part is this is like I'm reading a comment called like lots of information, but the deal is we haven't got to a lot of information part yet actually. But at least I think the good part here is even if people are able to, yes, Kevin, this is exactly why I wanted to do a live one. Like that way I can see people's reaction, talk to them, and pace accordingly too. So like you folks' comments are really helpful here. You have no idea how much I appreciate them currently. I'm alone in the room otherwise. So, but yes, like don't leave the exercises after the training. I would encourage just try them, and you will really be able to write pretty good heuristics by the time you are done with like chapter 4 or 5. So, okay. But trust me, I'm distilling a lot of information from the manual. At least this should get you pointers, like there are sets, tables. Then when you are looking at the manual, you will get a little more idea about like what these mean. And like Zeek documentation is so detailed and so specific actually that you will see a lot of exceptions. Like when you're doing programming, I am reading your comments. So when you're doing programming, I mean, sometimes it's the exceptions which bite you, not the rules. And the Zeek documentation actually has a lot of exceptions highlighted very properly. So I truly appreciate that part. So, okay, so let's go to chapter 3. This is container, which is sets and tables. And if you haven't really understand the events to tap into, don't worry about it, that part, but definitely worry about understanding the sets and tables, because this is your containers. This is where you will actually store information. And then this is what you will use to actually generate further heuristics. So I'm talking in next 7 slides, and I will try to pace it up in maybe 15 minutes or so about sets and tables. And then what are their subtleties, or like what is the richness of them. And then I'll talk about expire function. Don't worry too much about expire function if you don't get that one. Again, same thing, exercises 0 to 07 are for you to get familiar with sets and tables. But if you are bored and you are looking at doing something, go for slide 50. So let's just go into these things. So Zeek has this concept of container types. So there is set, there is tables, there are vectors, and then there are records. So these are container types because these data structures actually contain a lot more values or data into it. So here is some examples of sets and tables. We may briefly touch into vector. I think Anthony is the vector expert from what I know. But anyways, I digress. So sets and tables. So like you can use sets and tables as a representation of networks. So, like local nets, that can be a set or a table. Never drop nets. So we drop a lot of remote IP addresses at the lab. So you are like, no, do not drop these addresses. What are live networks? What are dark nets, scan nets? So like, for example, you can actually even create, so like your networking group might actually have these subnets. So like building 11 has these subnets, building 12 has these subnets, building 13 has these subnets. So what I can do is I can actually say building 11 is a set of subnets, and then I can put these subnets here. Building 12 has a set of subnets, and you can put subnets here. But when the list grows significantly big, like you have 90 buildings, you cannot just keep track of all these variables. So what you do is you can create a table of set of subnets. So now you can actually say, and then call table lab or organization or something like, I would call it a lab. Lab is a table of buildings which are set of subnets. And now you actually have like encapsulated your entire network into Zeek language. So you can like say, this is my VPN, this is my employee net, this is visitors net. So you can actually do all that. And then there are like, you can create other stuff too, like whitelist. So ignore this source port, block these ports. Here are the institutional services. So here is a table of institutional name servers or table of mail servers. Here are the watch lists. So you can actually like come up with these English words or concepts, and then you can translate that into Zeek. So this is where the sets and tables are good use for. So sets is again connection of unique elements. You can have a set of addresses, ports, strings. Think of a data type Zeek has, and you can have a set of all that. But the deal with set is that it's an unordered data type. So what that means is that you can keep adding values to the set. But what you end up doing is you do a membership testing of the set rather than you rely on the order. Like you say that, I'm going to add here, if you can see, follow my mouse pointer. Okay. So here is this thing that I have a set, which is a set of addresses, and I have addresses of 1, 2, 3, 4, 5. So this is an unordered set. So a set will have all of them, but you may not get that in the same order. So this is the only thing which you need to worry about sets, so that it doesn't preserve the order. So if you run a set 5 times, this particular script, and this is a screenshot from try.zeek.org. So every time the order is going to be different. So if you want order, then you go and you use vectors, which actually are favorite for Anthony. So, but they preserve the order, they preserve the things. But what set allows you is do a membership test. So you can say, if I address in a set, if address not in a set, if 22 TCPs in allowed services or not in allowed services. So you can actually pay attention to these two things as well. So it's collection of unique elements. So if in a set you want to add another IP 1.1.1.1 again, it's not gonna change anything because it's already there. So how do you add something to a set? You say add, and then you can put the name of the set and what you want to add. So in this case, add host and IP. You want to delete something, you say delete on what's the name of the set and what value you want to delete. But Zeek being Zeek, coming from highly academic and research background, it has all these things taken care of. So you can actually do a set intersection, which means that is this value common between two sets? So, like is allowed services, and then do an intersection with block services. And then you see, oh, there is something there. Oh, there is a problem or conflict. You can do a set of union, like do not allow and watch carefully. And then you can actually do a union of both these sets. And you can also do a differences too. So, and this was when I was creating the slide. Again, this is a whole talk. So last year, I was in fun mood at that time. So the question was like, what happens if we delete a value which is not present in the set? So that's not how black holes are made. When you delete a value, it just like if it doesn't exist, nothing happens. So you should like, and one reason I ended up adding this part was that you remember, experiment with this thing, add a value, remove a value, try stuff. So now a table actually is this container type which you will use most. This is what I have used a lot more. And the way you define table is like in this example, I'm using peers. So you say this table is of global scope for that particular module. If you want it to be accessed across other modules, you actually export this table, put it in like export, like here, like this way. And now it actually becomes accessible to other modules too. But here is the table of index address of doing counts. So what this does is that, you know, how many times this specific IP address has connected to my network. So you say 1.1.1 count is 1, .2 count is 5, .3 count is 10. So this is like a literally a index with values, like a Python dictionary of certain kind too. But what Zeek enriches here is that, you know, you can actually create something like create expire. So, you know, a value gets added to a table and then this timer will start to. So the value will expire after 1 hour. So you don't have to worry about like housekeeping that, oh my God, I ended up adding like 10 million entries to the table and how do I remove them? So it turns out that Zeek just keeps going up and up. So you can do manipulation and control. So you can say, you know, expire after 1 hour. So, and then you can also say that when you expire it, I want Zeek to run something. So it runs an expire function. So what you can do is say that, you know, when this value expires, I want to generate a notice, I want to log it, and so on and so forth. So how does the expire function work? It's called right before the element expires in the container. And then function's first argument is same type. So the first argument of the expire function is actually this thing. And the second argument of expire function is address. I will show you later on. An expire function returns an interval. So, you know, you can also do something like, if this IP is in bad IP addresses, expire function kicks in and then you return 1 hour. So the value never expires and then is extended by an hour. If this IP is not in bad addresses, you return 0 seconds. And as soon as the expire function returns a 0 second, the value will expire from the table. So yes, this is heavy, very heavy duty information. This gets pretty dense as well, but this is one of the data structures. Once you are very familiar, you are going to use quite a bit. So a table is of type. So you can have a type of address. You can have a type of address, string, count, think of something else, port. And then you can also have a like a table address of set addresses, set count, set port, set string, and so on. Table you can have an expire function. You can choose not to have an expire function. Good idea to have one. So, but now what's beauty of the Zeek is that, you know, it also allows you certain more things than just create expire. It allows you to do a read expire. So what read expire means is that create expire is literally like the value gets created in the container and then you start running down the timer. Read expire is like every time the value gets read, the timer renews again. So let's say a remote IP comes in, that touches you again, and the values gets read in the table. Like if destination in table, then the value got read, the timer resets back to the 1 hour, and then so as long as the things are active, you don't have to expire. It will auto refresh itself. Then there is a write expire. The last time it's been written, and by written I mean we mean is this value. So like whatever the count has been changed. So if the count has not been changed, then the write expire will trigger. And then there is this on change. So if the value is changed, then you can actually tie this up. So this these are the functionalities which a table will have. So, and then there is this backend broker, but I will not go into that for now. So here is certain more information. So let's say like I created a table called table distinct peers. So like distinct peer is like how many unique remote addresses a given local address has talked to? Yes, good question, Kevin. Let me answer that on this slide itself. So in distinct pair, you can say how many remote addresses this local address has talked to. If you flip it the other way, it can be how many local addresses a remote address has talked to. And as soon as you flip the question the other way, this becomes a scan. Like how many local addresses a remote address has talked to. And if that number is 200, man, why does a remote address needs to talk to 200 of my machines? So that thing you can store here. And then you can say expire. So why would you expire it? So let's say 1.1.1.1 actually came, it talked with 200 of your IP addresses, and you actually have the value in table. Now 1.1.1 actually just moved past your network. It was scanning entire internet. And now it's not good. It's not coming back for 5 days. Do you care about keeping that information in the table anymore? No, you don't. So that's when you will actually do. So instead of this, maybe you want to keep it for 24 hours. You want to keep it for 72 hours. Like how long you want to watch for something. And then you say, okay, expire it. So that way the value gets expired. So like, let's say Zeek runs for 6 months. You don't end up with tables with 1 million entries. So the expire is generally useful for doing housekeepings, or expire is generally useful for generating notices. So let's go to exercise 3, which is sets and tables. Look at this and run at least 0 by yourself. See if you have any questions. And then like for people who are more familiar with it, they can always go and actually do questions like how many unique IPs and ports do you see in the trace, and then all this addition and functions. So look at this exercise, and then what I will do is for next 5-7 minutes, I will walk through a few of them. Okay, so now this gets to a place where people are like, you know what, I know scripting, and you wasted my time. So here is the things you can do. Or if you already feel familiar, like if I think I'm doing a great job and everybody now knows how to do scripting, here are the things you can actually start doing too. Like some questions for you, like for each remote IP, how many unique ports do you see? So like, you know, in security terms, these are the questions. This is how we think. For each remote IP, how many unique destinations do you see? How many unique ports on each destination do you see? So like when you say these stuff in English, then you can translate that into Zeek script, and then you can actually have a meaningful heuristic. So, and then there are extra credits like calculate the bytes, and then how many bytes actually each of the sources did, and so on and so forth. And then there are these extra credits, which are like use average bytes and then find the anomalous event. Like, you know, all the hosts are talking at like 5,000 bytes. Why does this have 2 gigabytes? So something on those. So these are the questions, but let's just go through the exercises. So the first one is valid, invalid. And stop me if like I'm distracting people from doing the exercise. I can sit for like good few minutes, or if you want to walk me through it, just stop me if you think this is distracting. So this one is actually a valid, invalid thing. So what we did is, remember like when I was talking here in the slide deck, that what can you do with the sets? And sets have like addition, deletion, intersection, union, differences. This is what we are doing. So now we created this set called a new, and then we put all the addresses 1, 2, 3, 4. And then we created a new set called B, and then there is a set called C new. So if you run this, it actually will give you self-explanatory output like A new is not equal to B new. And then if you are doing union, so the union is actually done with, and what is generally used as an OR operator in other languages, a pipe. Intersection is done with ampersand, so you can actually see what the intersection is. The difference is done with minus. And then remember long ago in the quiz, I said local A is of type this thing. So what Zeek does is it actually resolves google.com. A becomes a set of addresses, and then you can say A is, and then it will actually give you that info. So if we run this thing, so this will allow you actually insights into Zeek. And now you see all this hex here. So these are actually the separators which Zeek actually just dumps out on the screen. So you have to traverse through the set to actually run it cleanly. But you can see union of set is like all the IP addresses are here. Intersection will only have this one. A becomes a set of addresses. So when you resolve www.google.com, this resolves to IPv4 and IPv6 address here, and so on and so forth. So, and then like you can see, so this exercise will actually allow you a little more code and mental walkthrough of like understanding how sets are actually manipulated. So now same thing is here, like what is the basic addition of the set? So now this one is useful. I think you will like this one. So I created a module called training. Now I have a global services and remote host, but see, they are not exported. So they are only, their scope is only this module, but all the events and functions in the module. So like services is the set of port and remote host is a set of address. So now we are tapping into new connection event, and we are saying, okay, here is the connection unique originator. So we say connection ID, this is the origin host, and this is the service, which is the response port. So we extract that out as a local. Again, local means the scope of origin is only in event new connection here. That's it. So now you see if services not in service, then not in services. So what we have defined is services is a set of port. So if services not in services, we add services. And the way we do it is we say service, which comes here. So add in the set of services, this service, and add origin in the set of remote host. And when you do, you actually now at Zeek done, we are literally printing the things out. So for is the only good use of for. Oh, we are in the subdirectory 03. So the only good use of for is actually printing output for your consumption. Try not, whenever you feel like you're using for in your scripts, try not to do it. There are other better ways to do it. But what this will give you is like all the services which are actually in service, same thing, all the IPs which are in remote, and so on and so forth. So, and then you can also do one more thing. You can actually find the cardinality of a set, which is like the number of elements in the set, by actually putting it between two pipes. So like when you say, what is the cardinality of services? So this actually, this and this should get you how many elements are in the service, how many are in the remote host. So, and this is here. So here is all the IP addresses. Here is all the counts. So the total, like there were 3 services seen and 56 remote IPs seen. And if you go up, scroll up, it actually dumps all the unique services. Oh, this is because I have not done -c. See, my alias is not there. So now it's not going to give you a checksum. But here are the unique services seen. So these were the destination services. Here are the unique IP addresses. Again, here, look at this. Here is the thing. So all the unique services seen are actually here destination. So when you look at the con.log, you can see all the destination services. Here are all the unique IPs. See, this IP is seen twice. No, thrice actually right now in 3 rows. But in the set, when you're counting, it will not be 3. So if you do a, like I know there are 8 cat con.log. Let's remove the header and then do. So there are 64 rows in the con log, but there are total 56 unique IP addresses and 3 unique services. So that's how you actually translate the logistic into from English to. So these are basic set additions. This is more cleaner version. So I'm not going to go through these 2, 3, but let's go through the exercise of tables with basic usage. So here is the table. Like again, what I did remember last time we had services as a set of port and remote host as a set of addresses. So now what we did is we set services as a table of ports of count. So this way, for every unique port, we will have the count. So this gets us like, okay, in the previous output, what we saw was port 22 was there, but we don't know how many port 22s were there. We know that for .12 address was there, but how many times was it there? So, when you do that, this is the way the table actually lets you correlate a lot more information. And then same exercise, if you see this, I am extracting the original IP, response IP, and services, doing a membership check. If service is in the services table, if not, then the way I initialize is I say services and that specific service. So in this case, let's say port 22 TCP. So that becomes response port is 22 TCP, which comes here. Is 22 TCP in services? No, it goes into services 22 TCP and initializes that to 0. It also already I am defaulting it to 0 here too. And then what I am doing is I am incrementing the count by 1. And same thing I am doing here, like is remote IP, let's say 1.1.1.1 is in remote host. No, so remote host 1.1.1 initialize to 0, increment the count. So if we run this thing, yeah, so let's run this Zeek-R. So now it actually says unique services seen were 3, unique remote IPs were seen 56. And remember, we did that with the set as well. But now we can actually say that 23 TCP was seen 30 times, 22 was seen 30 times, 445 was seen 4 times, and this IP addresses was seen 4 times. So that the way you can actually do much more granular picking of the data, as well as converting this data into more condensed form. And this is all here. This is all here. So let's verify if Zeek is not surprising us. So if we do this, oh, here are the 4 connections. So you can do literally this same thing. Like you can write a bash script, do this, awk -f/t print $3 here. So this thing now is that script. But what this script allows you is a lot more capability after this. So I hope the idea gets passed. But now if you look at this tables, distinct peer services count, so this will also give almost like 3, 4, and 5 are built on one another. So like 4 is a slightly better version of 3, 5 is slightly better version of 4. So I would leave it to folks to, I know you will not like it, but I will leave it to you folks to actually look at that and try it out. Let me go through the expire function demo. So in the expire function, the deal is like, when you say 10 hours, we are not going to wait for 10 hours, right? But what you end up doing is that you also have to do something like when we are running the code manually, you want the Zeek. So Zeek terminates as soon as it's done processing the PCAP. If you want Zeek to hold after processing the PCAP, you end up redefining this variable exit only after terminate to true. So, but in this case, I don't know why I have 10 hours. Oh, maybe because the PCAP runs 10 hours. So yeah, that brings me to another concept. Let me verify. Sorry. Okay, so I wanted to learn this before I do this. Okay, so let's walk backwards. So I ran the code, checksum. I'm just disabling the checksum because this was like anonymized and whatnot. But here's the thing. I read the PCAP, I run this thing. So the process is not frozen. Like when you run this, it's not frozen. It's because readif exit only after terminate is true. So you have to control C out of it. So this is self-explanatory now. But here is this thing, unique services are seen on this trace is 18, remote IP is 1. But here is a summary which is coming from that this IP connected to these hosts, and here is all the list of the hosts. So let's look at the code. So in this code, what we have done is exactly same thing. Here is services, which is a table, but now this is of type address and port of count. Remember previously we had services of type port, but now you can expand the table further to say it's of type address and port, and then of type, like it's going to do a count. And then distinct pair is of type address of set addresses. So you know you can go pretty advanced very quickly here. So now you have multiple indexes in the table, as well as you have a more complex container type. But what I have done is I said create expire 10 hours. So which means that after 10 hours, expire the index and the value. And here is the expire function. And like previous exercise I showed you, this is how you populate the table. But what we are more interested is the expire function. So what expire function does here is that it uses the argument, which is literally the table declaration. So recall, distinct pairs is a table of index address of set addresses, and then the index is of type address. So we do this. The expire function will always return a value of interval, something which is time. So once the entries expire, this function gets called, and then it starts printing the values. So it comes here, it looks at this thing, and then it does pretty much all the dumping. And then when you return 0 seconds is when the value actually is purged from this table here. Now, here is one question. We ran the code, but it's written 10 hours. So how did the time, like we did not wait 10 hours. How did it run and it complete? What happened? So do I have CF? Oh, I don't have it. So, but if you look at conn log, these timestamps are actually what moves the Zeek timer inside the Zeek forward. So Zeek actually has the concept of network time and current time. Current time is the system time, but network time is the time of the PCAP, like the packet in the PCAP, which it is processing. And that is what moves forward. So this time is what actually results in moving forward. I unfortunately don't have CF. I can install it right now. Maybe I should just do it. So this is the website of the network research group, like folks of the names like Van, all those, when they were active at the lab, they were actually running this. Actually, where is the here? So there is a tool called CF, which I have used often. And what this does is it actually converts the Unix time into human time. So I apologize for this delay, CDCF. Okay, so now if we see, you can see like on September 30th, midnight, 31 minutes past midnight, the first connection was seen, but the connection keeps going on till 8 hours, 52 minutes. So this is how the timer inside the Zeek works. So when you are seeing this thing, this is not the real clock time, but this is the time of the packets. That was the point I was trying to make here, and an insight I wanted to give. But like, you know, you can actually, so this is the expired demo, and here is all the, like, you know, if you want to identify services per host, these are the things. So now let's go back to the slide deck. Any questions so far? Yes, the PCAP spanned for 10-hour period. So like this was a really slow scanner, which was like connecting once every hour, half an hour, and like 56th connection happened 10 hours later. But that's what you will see. So, okay, so here, let's go back to the build of the heuristic, and like remember what we did in the back. In the first part was like we just dumped the DNS records. Now in this exercise, what you do is that you will limit the DNS record to only query type pointers. And then if query type is uninitialized, ignore them. Otherwise, access the whatever is the R code name, otherwise put it as ignore. So what the goal in this one was print query name and R code name, and print the count, the number of queries for a request IP. So this is what we are doing with the DNS record. So if you look here, so if you look, let's just go with walk through the solution. So remember, we initially said, okay, local nets, redefine local nets as this, and then in event log DNS, all we did was print %s record, and it actually printed the record. In this form, we have gone a step ahead. We said, you know, here's a local request IP of type address, check threshold is of type Boolean, and then we said record identity connection identifier origin. So whatever is the original origination of the connection becomes the request IP. If the request IP is not in local nets, we don't care. Otherwise, look at the type. So we said if the query type is pointer, not pointer actually, then actually, I apologize. If query type name is not set, and the way you say not set is actually put a question mark before referencing that particular type, or if it's not pointer, return. And I will explain you why we prefer return before actually doing the real action. So you say, okay, so by this part of the code, all you get is actually pointer queries. So the goal one was print the request IP, what is the query, what's the query name, and what's the response code. And the goal two was if request IP is not there, how many times we saw the request IP. So if we run this, and this is, I know this is beyond most of the people currently, but just play along with me on this one. But here's the thing. So what we ended up doing was we only filtered all the queries coming from this IP address. Here is the query. They are of type pointer, and there was only one query. So if we cat DNS log, here is this query. It's going to a server which is in our local net name server, and it's a pointer query. So that's all we filtered. So the question was, in DNS log, can we just narrow our queries to of type pointer? So this exercise 10. This exercise 10 DNS solution, all it allows us to do is ignore everything which is not of type pointer, and then actually populate the data structures and move forward. The point I'm trying to make here is, again, same thing. Tables and sets are a useful piece of container types. What they allow you is to store multiple values and combinations of it. You can have a table of type address of table with index address of set addresses or ports, and then you can do addition, subtractions, and all kinds of activities there. So are you folks with me so far? And actually, you know what, this was all the dense stuff I was talking about. How is everybody doing? Are you with me? Any questions? Okay, so let's go to, how about take a 5-minute break? How about that? Okay, if you folks want like me to cover more of the tables and sets, I can do that too. I can move to a next. Yes, definitely need practice, and you know who to bug. You can always reach out to me. So, but let's take like a break till 3:06 at least. Like let's have some breathing room. Maybe 3:07. Actually, it depends. The memory impact is a function of how much you're storing in the record. If you say that you are storing every remote IP address in your table, and let's say you have a very busy link, then you might have 1,000,000 elements in the table within like first half an hour or an hour. So, but with an expire, it's still better than having 1,000,000 elements every hour for next 20 days. So you have to figure out a balance. Like I think like with scan detection, which I'm quoting too much because it's a pretty simple thing and it's always in my head. I expire inactivity after 24 hours. So if there is a really low and slow scanner, which does one connection every 24 hours, I will still get it. But if it does one connection every 36 hours, I don't care anymore. But I don't want to keep values in the table for 36 hours for something inactive. So expiration, don't think of it as a memory impact, but think of it as a memory management technique, which tables and sets give you, because you can bloat tables and sets very quickly in a lot of places. So let's say, for example, you get a blacklist. Now the blacklist is 1,000,000 elements. So you only are interested in looking at blacklist if those IPs have ever connected to you. So that's where you can use the tables and the expiration. Hi, David. Yeah, thanks for comment. So yeah, but I would still encourage, like, go to these exercises, look at the code. Let's look at one random code. Let's just look at 07 tables chatty pair. So what this does is that, you know, I have a table called talkers, which is a table of address and address. And talkers is like, you know, now I want to watch how many times these two IP addresses, source and destination, talk to each other. And this can become a pretty interesting thing. Like, you know, if you're watching two IP addresses consistently talking to each other for, let's say, 15 days, I mean, what's going on? Generally, you know, things will pop up is like NTP servers, DNS stuff, like a service. But there are other times where you are like, no, this host consistently talks with this host. Let's look at that. So you can create something like table address of how many times. And then you say, you know, if I create it, I expire 1 hour, 24 hours, depending. And you just populate, you tap into new connection, you populate the talkers with origin response and just keep the counter up. And when it expires, that time you can say that, this host has talked to this host for these many times. So let's run this code. Maybe gets you a better idea. So here, this host has talked with this host 2,560 times in that duration. But, because I'm doing a table expiration, you will see that there are certain places where you will see a repeat value of like this host has done this host and this thing. So let's say if I change the expiration to no. Oh, 1 day was way too high. Yeah, so as soon as I do this, those numbers 2,500 has changed to 3,096. Okay. My kids are home finally. So anyways, so this is how you actually like translate English into the code too. Like, but this way you can actually run this code in your network and you now start knowing who are the chatty pairs who like to talk to each other a lot. And then you can start filtering them down. You can create a test, like a set of like, oh, chatty friends, and then you can put them and like you can say if source isn't chatty, source and destination chatty friends, ignore otherwise. And that way you will always have the new list of IP addresses which are talking to each other a lot. So this is how you would convert like security into code. Let's move forward. Again, this is a heavy one too, but this will make a lot more sense now. So there is this container code type called records. How many of us here actually are familiar with C data, like C structures or C++ classes? So, or like back in the day, I mean, there used to be other things where you can create a record. Record has a lot of different data types is part of record. So there is this, like what Zeek allows you is to create this complex combination of, I don't know how to disable it. So complex combination of different data types together to make a record. So like next few slides, there are 4 of them only, is actually, it will introduce the concept of the record and like how they can be used. Yes, structures. So structs, just like you have structs in C, just consider records as same in Zeek. And then folks who want to do something, go and to find the bugs at 56 and 57. Or 57 is our DNS. But let's move forward with this thing. Actually, here. Yes. So you can create your own custom data types, which actually are of type record. So let's say I created this data type called connection info, and connection info is a record of which actually I want to measure, like keep track of the start time of a connection, end time of a connection, and how many hosts did that remote IP connected to, and how many total connections did it make. So you'll end up with like, and as I said, like here is the table, like what we say is a connection. It's a table with index address of type connection info. Remember in past we have done table address of set host, and here is the set host. But now we want to know what is the start time, what is we want to know what is the end time, we want to know the connection count. So what we do is we tie all that up together as a record, and then we actually, so now how do you access record? And previously you have seen that is using a dollar operator. Remember, C dollar ID gets you the connection identifier. C dollar ID or dollar origin H gives you the origin IP. So here is how you access the record. So C is actually a record which has a data type called ID, which is a record which has origin H in there. So this is how you would say. And the way you actually check if the there is a uninitialized member or empty member is using question mark dollar. So let's say if the start time is not set, then you can actually say if start time is not set is by using question mark dollar. Actually, no, if this is true, then the value is set. If not, then the value is not set. Sorry, I'm just distracted a little bit. So this is how you actually access the record. So let's go to the next one. So here are the field operators. A dollar will actually let you access the field value. And if the value is existing or not is a question mark dollar. So let's say in email, I want to know if is the mail from set, then it's C is the connection record. Remember very early I talked about the connection record with SSH protocol. In this case, the connection record has SMTP protocol, which actually has a subsection of mail from. So if mail from is not set or set, I can actually check its existence using question mark and dollar. I'm trying to explain this in a simpler manner. Maybe it's confusing, but remember two things. If you want to access elements of a record, use dollar. If you want to see if it is set or unset, use question mark and dollar. So this is generally how you would. But now how do you use records? You create your own data types, right? So in this case, I have a connection stats, which actually is a type of set addresses. And then start time, end time, what is the host, and how many connection count. And you can actually all of a sudden have a log like this, that here is the timestamp, here is the remote IP addresses, it's part of the blacklist. How many days was it seen? It was seen 1 day, 3 day, 1 day, 2 days. When was it first seen? When was it last seen? When was it last active? Like how many hours or days ago was it last active? No, how long was it active for, which is a subtraction of these two. When was it last active? Like it hasn't been seen for 3 hours, 5 hours, 6 days, 14 minutes. How many total hosts did they connect to? How many total connections did they connect to? And what is the source of the blacklist? It's Tor. So, you can do all that log as if you actually just start tracking things like this in the record. And this actually allows you to bundle things together. So hope this actually is little abstract in some ways, but if you understand structs in C and C, like classes in C++, this is a natural progression. If you don't, I would say that this is how it is. So let's go to the exercises. Let's look at the exercises. So in these exercises, what we are going to do is we are going to the very first one tells you how to track start time, end time, how many local hosts were contacted, and how many total connections were there. And here is the hints too. If you choose to write your own code, just look at this hints. You need to create a connection record. You need to create a table with index. You need to tap into new connection event. If you want to have complete information, tap into connection state remove event. If let's say we are counting bytes and you're counting the connection states and everything, how many of these connections are open, bad, so on and so forth, and inactivity timer and all. So let's just go through this exercise. So for people who want to run with the code on their own, here is what you can do. And here's the extra credit. So this is the challenge part too. Can you do it at a scale, like 10 million IP addresses? So, and that's where the expiration timers and stuff comes in, because the problem is as soon as you get into a little large scale network monitoring, we need to think about scales. So let's go to scripts directory. So here we have the module. I am exporting this new data type called connection info. We talked about this already. Host is a set of addresses, rest is there. And then like to hold this record, we have a container type called stats, which is a type of table, which is called stats with index of address, and address is the remote address of type connection info. And like this is all Zeek init will give you some info. We are tapping into new connection event, right? Same thing again, like I'm repeating same thing again and again, which is like in connection record C, there is a connection identifier, and you actually get the origin IP, you get the response IP. Do a membership test. If origin stats, origin is not in the stats, then you actually now have to initialize stats origin. So first you actually initialize with the connection, like you instantiate the connection info record, and then you create a edge called set of addresses. You add record host as a set of addresses, and then you are here states is the table. So table address of connection info. So this is how you get it. And see, rack is a con info, right? So rack is con info. You have a table stats of connection info, and then you can actually store start time from the argument here. And then, so this is only one time. This code fires initially when we have to initialize stats with origin IP. Once you have that, all you need to do is keep updating start time to end time. And start time is like, you know, you have multiple connections. You have connection 1, 2, 3, 4, 5th. So the start time of the 5th time is the end time, which is like the last connection we have seen. And then this is the set addition. So remember, host is a set of addresses, which is part of the record with index, which is a part of the table stats with index of origin. So you add the response IP to the host, and then you increment the connection count by this. And every member of the record is actually accessed with $operator. So the connection count is actually here. This is part of the record. End time is part of the record. So this is how you will end up populating it. May not follow it right now. Look at the code again. Maybe it's easier to understand that time when I am not talking more. So traces 01. If you run this, it actually runs and it gets you all this information, which actually is like, here is the IP address, here's the start time, here is the end time. There are total 31 connections, and here is we dump the entire set of addresses in here. So, but the reason we dump like this is because we just printed, and Z has this serializer, which actually like takes any data type, and when we are doing a print, it will just serialize the data type and print it. That's why you see all these extra characters. But you can always like use a for loop, and then you can actually traverse through all the hosts in here. So what you can actually end up doing. So like what we are doing is this thing for I in stats. So stats is the table. So it goes through every index value of the stats. Likewise, you can do is for H in host stats I $host, and that would actually give you individual hosts. So this is pretty much the record. Like, and you know, if you look at con log, this is what you see. Here is this IP address, and here is all the IP addresses which actually are talking. So, but I think this is pretty much the heavy stuff we are talking about in terms of developing the new heuristic. What we did was, now we need to create a record to keep the counts of all kinds of pointer query types. So like, you know, pointer query is actually no error, annex domain, refused, serve fail, and unknown. So this is where you will end up creating a record. So far, remember in our DNS heuristic, what we needed to do was examine the DNS record. Like I have shown with the exercises, examining the connection record. But if you tap into the DNS protocol, you will examine the DNS record. Then we said we only want to limit the query name to pointer. And then we want to actually print all the query name and the types and everything. But now, if we want to see what is the breakdown of the pointer queries, we can actually create a record and then which can keep count of it. So let me just walk through this code if that is helpful. So what we did here is that we called it pointer stats. It's a record which has count how many times no error is seen, how many times NX domain is seen, how many times refused is seen, how many times server fail is seen, how many times unknown is seen. And then we created this table index address, which is going to be the remote address of pointer stats. Remember, like in our previous exercise, we had a table stats, which is a table of address of con info. So this is what you do. So like most of this may look complex. So don't worry about those parts, because ultimately you will be doing a lot of things similar to each other. We were doing that in the connection record. Now we are doing similar in the DNS record. But what that would lead you is to translate different security into code. Like in connection info, what we wanted was, give me all the local addresses and the counts of local addresses and the ports on which a remote IP has connected to. In this case, we are like, give me all the pointer breakdown of the pointer queries. The breakdown is in like no error, NH domain, refuse, serve fail, and so on and so forth. So this is how you actually end up doing. And then if the case is this, this is the table, this is the index, and this is the value we are actually manipulating. So if you are coming from C background, this is like no brainer. If you are coming from non-programming background, don't be mad at me right now. So, but I think if you can feel comfortable at this part, I think you are going to be pretty good with the Zeek programming. I can give you in guarantees. So, but get familiar with this as much as you can. So now let's get to like operational Zeek usage. So this is where so far we had been talking about like developing heuristic part, but a lot of people may not want to develop heuristic, but they want to manipulate Zeek. And by that, I mean, I am running Zeek, everything is good. I am happy with the heuristic which Anthony or Fatima wrote. What I want to do is that I want to improve that heuristic a little bit or customize it to my level. And most favorite of that is logging. That, what, you are generating this log. Excuse me. You are generating this log. Can I do log filtering? I just want a subset of the log. I don't want all of this log. And at the same time, I got more ambitious actually, which was like, can you create a new log file? So this is again 4 slides. Hopefully not too much burden. A heavy burden is already gone past us. Now this is more understanding from a higher level too. So what logging framework is actually, I would say this is literally copy paste from this URL. So if you go to this documentation page, I can guarantee you what I will explain in next 4 slides is nothing compared to what's written here, and much more clarity. But what logging framework is allows you like a good control on how the logs get written by Zeek. So like, the abstraction in the logging framework is that there are multiple streams. So like when you see con.log, that's one stream, dns.log is one stream, notice.log is one stream, and so on and so forth. And for each stream, you actually have a set of filters. So you can actually do all kinds of filters, and filtering will allow you to actually manipulate what gets written out, what gets appended, what gets changed before you create the log. Say, for example, you want to write the name of the building in which that particular subnet is in the connection log. And this is a very lame example. You can actually, or actually in the notice log. So what you can do is that you can actually use a filter, create this set, a table of buildings with subnets, which actually I talked very early in when we were talking about sets. And then you can actually take each log line, see if it's in the table, and print the building name along with it. And then there are writers of the logs. So you have the stream, which is multiple log types. Then there are filters, which allow you the manipulation on the logs. And then the writer is actually what writes on the disk. So you, by default, like it's ASCII, but you can have JSON writer, you can have binary writer. I think people have used log writer to write on Kafka, and then you can write directly to Splunk. And I have not done any of that, but there are different writers you can actually experiment with. Now, why do you need custom log files for any new heuristic analyzer? Oh, you are like, you know what? I wrote a new heuristic. I want my own log file. And it's nice to have your own log file, isn't it? So, and then if you are doing log separation and filtering, what I personally feel is that, Zeek doesn't tell you what's good, what's bad. Zeek tells you what happened on the network. So when I am doing filtering, what I do is I actually create a separate log file and filter there, so that I have the ground truth of what Zeek has seen in con.log. And then I have another filter, which can be called like reduce con log or watchdog or blacklist.log or so on and so forth. And then sometimes there is policy compliance too. For example, you are only allowed to log local IPs and limited fields, and you cannot log remote IPs, or you cannot log certain fields. For example, names of people in emails or whatever else you may have. So in that policy compliance, and policies can be obnoxious to like fantastically specific. So there you might need log filtering. So here is one simple example of extending, and this is again from Zeek documentation. I actually had my own, but I thought this was much more simpler. So let's say you want to increase the connection log. And you say that if a IP address is RFC 1918 or not. So you can create a new field. Remember, plus equals to. If you don't do that, the entire connection info record will actually just have one column. So you do plus equals to, you say is private, put a Boolean type, which is true or false. So if the IP address is from RFC 1918, this variable will get set to true, otherwise gets set to false. And this is how you end up in connection state remove. That, here is the IP address. Is it in private address space? And if one has to guess, they can easily guess that the private address space is either is most likely a set of subnets. That's where you can do 192.168.00.24, 172.16/16, 10.00/8, and other, if any. Otherwise, it can, like, if you are doing it really lame, you will actually have it as a set of hosts, which I advise against. But if this condition is true, then in the connection record, because we have already extended private, you can just say 2. So when you do a tail on con.log, you will have a column at the very end, and it's called private. What are do's and don'ts of extending logging? I would not say don't. I would say I would discourage to extend connection log. Connection log is a fundamental to your Zeek deployment. If you extend connection log, you will, if not now, in future, have problems with filtering. For example, let's say you say, I want to send my logs to Humio or Splunk, and somebody else has written the ingestion thing. Now your extra fields are going to confuse their ingestion, and now you have to manipulate that. So try to enrich your logs with more data, but don't create a subset of another log. Like, you can create a subset of connection logs and then enrich that. we have seen this problem because like lab has connection logs going back many years. So when I'm writing these scripts which are like crunching those data, all of a sudden a new field completely is like, okay, so now I have to remember that from March 3rd 2011 to January 17 2015 I have to like look at these columns and then I have to look at those columns. It's a mess. Don't do this. I made this mistake before. I would like you not to make this mistake. What you do is you create a filter and then create a subset of these logs. So how do you do that part? You create, so here is this thing, like, you know, I created a new log type. So I can create a log summary is my new log type. And remember con info, that was the record we previously declared in the record section. So now I say is that the columns of this log type connection summary are con info. And then there is this filter. And I actually just set that filter as default. And when I say the filter's path is con summary, that would actually create a file called con_summary.log. And I add this filter. So this is pretty much the way, I mean, I can explain more, but if you go by the face value, this is pretty much the way you create a log stream, you manipulate a filter, and then you add the filter back to the log stream. But here is how you populate it. So when I'm populating in some function, I actually create this local variable called info of type con info, which is a record we talked before. And then we actually say add the start time, end time, populate everything. And the way you write a log is actually say log write, what is the stream and what is the data. So this is like how you would do it. So I'm thinking, should I talk about this or not actually? Okay, so let's not talk about configuration framework currently. And let me go through the configuration framework after this exercise. Then we will come back to this one. Because what configuration framework does is that it actually reads a file on the disk and automatically populates the data structure here. So let's say you have a file with a list of ports. So the way you tie this together with config files, this file will actually go and populate the entire filtered port. So right now you actually have port 22 TCP, 53 TCP, 53 TCP. And later on you go, you VI this file, you add 6667 TCP. That will automatically get populated here. So, but then, you know, the way you filter everything in the log is this very simple example. So you literally, like, remember we were tapping into event new connection, event connection state remove. You tap into something called hook, connection log policy, copy this thing entirely as is. These are the parameters. This is the record of type connection info. This is the identifier of the logging stream and whatever is the filter. So it all gets passed here. You check if the destination port is in the filter port, no, break, which means that your log file will only have lines which are not in the filtered ports. But let me not go through this. Let's go through the logging exercise. You will like running this and understanding it more. Let's just do this thing. If any questions, please bug me. If not, I still hear you. So where are we at? We are in the 05 exercise log files. So for people who think they actually can work with logging framework and are familiar with things, what I would like to do is in the policies directory, there is a file called logging stream.zeek. You should include in timestamp and source address. For everybody else, let's just go here. So, okay, so the first one is actually, you know, connection log. Let's filter on the port. So here is the thing. I have a file on my physical disk, which actually is called filtered ports.file. It has the list of ports. So when I am actually running the PCAP against this particular script, what it's going to do is it will read the PCAP, it will look at all the connections, it will look at the destination port. If it's part of the filtered port, it will actually either log it or refrain it. Let's see what it actually ends up doing. So here, all we do is actually this thing. So you tap into this hook called conlog. This is built in for you. It's ready-made and available for you. So all you do is that you check if the pull the destination port from the record, check if the destination port is not in filtered port. If it's not, then break, and break will result in not logging that particular information. Let me run the code. Easier sometimes to run the code and then show. Oh, okay. We don't even need to do that. So Zeek 01. Oh, okay. So the way we want to do that was we want to run Zeek on our interface. So this is the first time I forgot about this. So clear. So this is the first time we are actually going to run Zeek not on PCAP, but on your network interface. So like what you do is Zeek-I. In my case, I do AN2. And if I do this now, Zeek is actually running on live traffic. Oh. So now it's running on the live traffic, and it will only print me values if I have connections going on the filtered ports. So let's look at the con. There's nothing because I don't have a traffic. But what you see is that, you know, I was trying to filter on this. But let's do exercise 2 much easier. So exercise 2 is, remember this connection record? We talked about this in the record section. This is a connection info record, which actually has start time, end time. Then there is a host. And then what I did is I said a host count and connection count. Because host is a set of address and you don't know how many hosts will be there. We don't want it to be logged. So we don't have an %log in front of it, but everything else we want to log. So we have a directive called %log. And this is how you actually can manipulate a record to say what can be logged, what you don't want to log. So, but what we did is we actually created this new log called consummary.log, and we already know about this thing. We already know about this table, which is a summary indexed on address of call info. Remember, we talked about all this stuff. So what's new here is this. And this is literally like if you're creating 10 log streams, this is literally how it will be. You create a log stream, give it a name, and then the column will be a record. So in our case, this specific case, it's a record of connection information. You look at the filter, and we are just doing a default filter, and the path is consummary, and the path basically is the name of the file. And then we are saying, okay, the name of this particular filter is this. You know, you can actually do it much easier too. You can when you're creating the stream, you can actually set up the path up here. But I always found this much more clearer that, you know, I am pulling the filter, setting the path, adding it to the filter. And what we are doing is that in new connection event, I pull origin IP, response IP. Remember last hour and a half, this is all I have talked about. You pull the value, you check the memberships in the tables, you create an instance of the connection record, you set the host, create a set for the host, you instantiate, you say, okay, in the summary table for the originated IP, this is my record. You put the times, you end time, you start doing the count. So this is all I am doing in the new connection event. But what we are doing is that in the expiration table expiration function, I am actually creating the info record again, and then I'm resetting that with all the values of the table, and then I'm doing a log write here. So let me run this thing and we walk through the code again. Zeek-C-R 02. So we go through this. Okay. Oh, okay. RM. Remember, I was running, trying to tap on the interface. So all the con logs were created with permissions of root. So it couldn't create the new con log. But here we're running it. Since we are running the expire function to write the log file, let's wait 5 seconds. I think this is more than 5 seconds. So if we kill this, now, if you look at con summary.log, here is our connection summary. Here is the start time, here is the end time, here is the host count, and here is the connection count. In the, like back an hour ago, our exercise was more function of, we were printing this on the screen, but now we are writing this in the log. So it is incremental. I can completely understand and relate that I'm going fast right now, or maybe not clear. And this is where I have to be physically in the room someday. But what you can see is that, you know, there is a con.log, which is the log of all the connections. This is exactly same connections with all the port 22 scan, but con summary will give you all the summarized information. So let's look at this back again. What I did is I created a new, like I redefined the NM type, basically the log streams. I created a new log stream called connection summary. I told connection summary to use connection info record as actually the columns. And then I actually was writing in the function connection expire function. This is all I am doing. So like looking at the background, the new stuff added is actually creating a new log stream and then how to write to the log stream a record which we already created. How about 5-minute break or 10-minute break maybe? I hope everybody did not leave me alone.
I don't think people left you alone.
Okay, so let's take a break till 3:50 actually. And
You've got about 45 more minutes to your session.
That's fine, Amber. I think we are okay. So let's run the other parts of the code. So in this one, what I'm doing is I'm just adding a source IP to the log. So if you look at con summary, I added the source IP to the log. Because, you know, it doesn't make sense. Like you have 20 entries. You cannot uniquely identify. So Walk-in, thanks for all the comments and the feedback here. I would love that everybody in the training fill up the review and feedback too. That will definitely help with formulating the training for the next time or for the next person. And yeah, feel free to reach out to me anytime. So, like in 03, what we ended up doing is we actually just added the IP address to the log format. How did we end up doing it? We created a new field in the connection info record and we called it IP. Any questions? Oh, busy exercising. I hope it's a physical exercising, just get up and move a little bit more too. But if you are definitely doing like Zeek exercises, nobody would be happier than I am right now. So. Karsten, any problems with exercises so far? So like, like there are different kinds of people. Like some people want to run the code first and then try to understand it based on output. Other folks look at and read the code first and then try to expect like, oh, this is what the output would be. So I think right now what I have designed is either way, you should be able to do this. Okay, people, let's run through this one. This is what I did is I picked and choose. So I'm going to go through the notice framework. I think it is important, but after notice framework, I'm going to go more with like do's and don'ts of the scripts rather than getting into clusterization and input framework. But if you have been like trying to follow the training so far, rest of the chapters are pretty much in the same fashion. There is traces, there is cautions, there is code in the scripts directory. So let's look at the notice framework. Notice framework is an integral part of Zeek's ecosystem, scripting system actually, because what good is a heuristic if you do not know that it triggered? So you're not going to go and look at the log file all day and try to see, oh, this is bad, this is good. I mean, people do that, but we still want to notice. So the idea in the next few slides is to see if we can get you to create a notice. So, the way you create notice is that there is a enum. I have not even got into the enum data type, but if you copy this struct, this is pretty much how you redefine this enum of notice type, and then you add whatever you want as your new notice type. So this can be, new attack. So this new attack will become now a new notice type actually. And the way you generate notice is calling a semantic like this. So this is how you will actually generate a notice. So you say the note is my new attack. And then there is what particular connection was interesting. So you actually say here is the C connection. And then notice actually has these built-in mechanisms too, where you can actually suppress a particular notice from generating for a duration. So you can say, you know what, suppress this for 1 hour, and the unique identifier key is the origin IP address. So like every time if this origin IP generates the notice attack, then you suppress it for 1 hour. So this is how you populate and invoke a notice. And then the third thing you have to do with a notice is manipulation. You control the notice. Like, this notice is generated. Now the notice generally ends up going into a file called notice.log. But if you want to actually say, no, I want email on this notice, you actually tap into hook. notice policy. And remember, very early we talked about events and functions, and I said, let's not talk about hook right now. This is the place to talk about hook. Most likely, the only hook you are going to be tapping into or the hook which you are going to be tapping most into is this hook notice policy, which has a parameter of notice record going in. So this hook, I think the second hook is for log manipulation, but this is the notice policy hook. So what this does is that there is this notice record, and notice record has these different elements in the record. Remember, we talked about connection info record. This is a notice record. So connection info record had start time, end time, host counts, port counts, so on. So the notice record actually has the note, which is of the notice type, what kind of connection it is, what are identifiers. There is other more things in the notice record. But you say if the note is training attack, then add the action of an email. And if you do this in your script, anytime this notice gets generated, you will have an email coming up. So what are notice actions? There are notice actions of logs, alarm, email, and page. And to get like email, you have to set this particular variable, notice mail desk equals to ashish@lbl.gov or plus equals to Ashish and then security and whatnot. And similarly, if you want to do a page, you actually have to set this variable up. So these are built-in variables which Zeek has. As you can see, this screenshot is from the manual. If you go and look at the manual, you'll see this column, this table, but you'll see a lot more information around it as well. But yeah, what by default you get is these different notice types, and these variables, if set, will take action on it. Long ago, we actually did a dump of connection record. Now this is a dump of notice record. So this is what notice record has. So here, when I was actually showing you, I only showed you a few of those elements of the record. Here's this entire dump. So the timestamp, what is the unique identifier? Here's the connection. I notice ID, which is part of the connection ID, pretty much this thing. Then there is a connection record, which actually is the full connection record. Then there is all these different things like file. If notice actually relates to file analysis framework, then you can have a file identifier, file MIME types, whatever is the protocol, whatever is the note, message, then you actually have what is the destination ports, peer name, all these different things. So then, but what I mostly care about in this entire record is the note, what type it is. So is it like notice attack, notice, whatever, I can't think of any other, like watched URI, HTTP sensitive. What is the kind of notice which you have, which is this thing. When you create a new notice type, that is what this is. Note is what type it is. Then there is a source. What IP caused this notice? Is it a local IP, remote IP? Sometimes local IP is good to see, sometimes remote. What port? Sometimes ports are relevant too. And then accompanying message for the notice. If you have a connection record, it's great. Sometimes you don't. So I remember, like, I was connected at the very end of Keith's and Fatima's talk, and I think somebody asked this question that, like, you know, I don't see a connection ID in the scan notices. So the reason is because, you know, scan actually is not for one specific connection. It's a aggregation of many connections. So putting a connection ID is only going to confuse. So that's why you don't see. Other places you might not see con record is con record is like wherever you tap in for. But yeah, these are the ones which I care about. And how do you use notice? So it depends on, like, at Berkeley Lab, we have automated actions as well. So we actually would use notices to go and drop a remote IP on the border. Other times you do a notice escalation to page and email for eyeballs, or you can do aggregation notices too. But here is how you would end up using notices in the script. So like here is how we have defined, like, populated the notice record. But you know, you can enrich a notice record as well. You can actually go and you can say email body sections, and then you can actually create a function called format message, and then you can add a lot of things. One of the examples is this. So I actually have a notice, which is an ICMP scanner. So originally the notice was just that this IP has ICMP echo scanned 512 hosts, but I don't know which 512 hosts got scanned. So what I did is that I actually went and said in the email body sections, give me all the subnets in /4, how many IPs were in each of those subnets. So like 112.0 had 256 IPs, 1330 had 253, and remaining 3 were here. And why do you see like more than 512? Because by the time notice generated, it actually added up a few more IP addresses in the other subnets. But yeah, so you can enrich notice with body sections as well. Sometimes it's useful because the person who is generating the notice is not the person who is processing the notice, and the other people will. So this is where you can go and like brag about Zeek as well. It's like your on-call people are like, oh, it would be nice to have this thing in the notice. It's like, sure, you got it. Or it would be nice to actually supplement this information with that information. So it's like, sure, you got it, and you can enrich all that with this way. So, but notices, the problem with notices is there is way too many. And that's where the real intrusion detection challenge is, specifically in anomaly detection. So there are these built-in structures available. Like, you can do notice ignore tag. So like as soon as you add to this set a particular notice type, for example, my module : attack, that would get ignored. So like, let's say you are really annoyed by certain alerts, which a package which Ashish wrote, and you are finding it completely uninteresting. You can actually do is redef notice : ignore types plus equals to Ashish : alert. And that will actually pretty much start ignoring it. So ignore means it won't even log into the notice.log. So it goes away. So like if you think Ashish wrote a heuristic, which is very useful, and I want an email on every time that happens, do the same thing here, and so on and so forth. So then there are other manipulation techniques for notice. For example, like in notice, just remember this hook. This is all you care for. And 99% of the time, what you care for is not what it is, what type of notice it is, and then supplemental condition. So in this case, if the protocol detector says server found, I care about all the server founds if it's SSH and the destination ports are 443, 7070, or 8080. So if it's a non-standard SSH on any of these ports, I want to see an email. And this is what this particular notice is going to do. Now this gets pretty interesting too. I think I actually took this from one of the packages which community published. This was a Windows package, I believe, if I remember right, CV 2020. I don't remember which one was that. But the deal was, if it's detected with high confidence, I want to generate an email, but I also want to generate an email on a mailing list which is of higher priority. So the way you can do that, so this email may go to your regular mailing list, which is like Zeek alerts at yoursite.com, and then this is like important alerts. So you can actually in fact do this too, where you can say email a notice to this thing, and this is a potential candidate. So in this case, I just want it to go to reports. So the idea is like, if I look at alerts, that is a high priority urgent mailing list, versus reports is like, I'll check later after my talk. So you can do certain manipulations like this. Other manipulations in notices can be, what is the notice type? See, it's always going to be hook notice. This is always going to be the case. And all you do is you just tap into it. So here is the notice type. And then I say, if the source is not in scan host and it's not in the local host, drop this. If it is a Havage scanner and not in my scanner host and local host, drop. But because it's a Havage, I want an email as well. So drop an email for internal IPs and drop only for external IPs. So, if it's a sensitive user agent and external IP, drop in. Oh no, here what I'm saying is it's in local nets. So if it's in the local nets, it's not part of the scan host. And remember, these are scan host is a set of addresses which actually is populated by list of scanners we run at the lab. So those are like all the scan machines we have. So there can be 5 machines, 50 machines, but you create a set of scan hosts and then you populate it, and later on you can use this everywhere else as well. So, and this is local nets. So you can do all kinds of things, like if watch user agent, it's not in the local nets, just drop them. So here is just a little idea about like all kinds of notices generate. Like you don't want to email or page on knock scan or a landmine, because this is like 114,000 notices generated day. But these both actually are notice drop. So if a remote IP triggers this notice, the action here, so literally this can become like a knock scan, and action is drop. So there's, but here is like, this can get you a little idea about like what notices can do what kind of things and how you manipulate them. I don't want any of like which are in thousands, but sometimes you really want to watch something which is like 1, 2s or 3s. Other places, a lot of notices doesn't mean it's bad. It's just that these parts are automated. These parts are like, this is a noisy detection. I need to make it big. At the same time, this might be a pretty accurate detection, just that the volume is too high. So you have to look at your data to understand these things. So here are these notice exercises. I'm not going to go through one because this is literally same as the very first exercise, like in exercise 2, which is just dumping the notice record. I'm going to do the exercise 2, which is actually creating a new notice. So let's just do that. And then I'll make this talk much easier. So this is what actually creates a new notice. So what I do is I redefine this enum, which is a built-in notice type. It's predefined inside Zeek. And what I am doing is I'm just adding a new type to it. And I say port scene. This is what you select. You can say port scene, Ashish scene, IP scene, whatever you want to write. This is your notice type. So you do that. I'm redefining local nets as this subnet /24. And in connection established, what I'm doing is I'm picking up again origin, response, and service. If the origin is in local nets, I'm generating this notice of port scene for this connection, and then I'm suppressing it for 1 hour. So let's run this thing. So if I do this, oh, okay. See, I told everybody that I don't want to run 0-1, but I actually ran 0-1-2. So let's just talk about 0-1 for a moment. This literally dumped the entire notice record. So it has the connection identifier here. This is the unique connection. So basically what you see here is what are the unique things you can actually use from the notice records. You can use the response edge. You can use UID. You can use email destination, email body. So these are the fields in the notice records which you can either use or manipulate. But we wanted to run the second one. So the second one, which I showed you, is created a new notice, which is called port scene. So here is this notice for training. It's port scene. So you can have your own notice. You can say my module, and you can say my new notice, and a connection on port 22 was seen. So here is the con record. You had a connection on port 22, and here is this thing. But now there are 2 connections. Why does it show only 1? Because remember, I said suppress for 1 hour, and oh, why did it go 2? Oh, maybe, but yeah, it's suppressing for 1 hour right now. So let's go back to, and I'll explain this more so that here is this new notice. If the origin IP is in local nets, which is 192.168, generate a notice, call this notice port scene. Identifier is the original IP. and suppress. So let's do this. Okay, I'm not sure this, like when you're doing live demo, but yeah, this is how you create a notice, to be honest. And let me just see one more thing. Oh, so this one, let me walk through this. I want to do this one. Let's do this one. So this is a false positive suppression. So if your notices are just too many, so in this script, what we have done is that we have defined local nets as there. You create two new notice types, which are remote and local. And then you use config framework and you say, you know what, here's my false positive file. So every time you add an IP to this file, it automatically gets propagated to this set of addresses. And here, all I am doing is that if the source is not in false positive set, if not, then there is an action email, otherwise there is an action log. And what I am doing in the code is pretty much same things. Like if it's a local IP, then I create a notice called local. If it's not a local IP, I create a notice called remote. But if it's a false positive, I actually generate an email, otherwise I call a log. So this is just an illustrating example of how you will create a notice, how you would use config framework to actually populate. So when you run this script in your live data, like in your Zeek instance, every time you put a IP address in this file, it will automatically get propagated here and it will suppress the emails for that action. So in this case, like cat false. Yeah, so in this case, I have these two IP addresses. So if you run this, you will see it. So now that I have like 20 minutes, let me just do a big jump and if you want to look at the scaling, look at Broom-Filter and opaque of cardinality. Otherwise, you know, I'll break this training into two parts and then we'll do it again. But what we should do is actually think. If you know how to think properly, you will know how to write properly. So what are the do's and don'ts of writing Zeek scripts? So here is a Zeek script which we have written. What we have, oh, why do we have that typo? Okay, so here is the thing. I created this module called HTTP 404. The idea here is that I want to track all the 404, like HTTP not found, for a remote IP address and see if that crosses a threshold. If it does cross a threshold, I want to generate a notice. You know why? Because a lot of people run this web spiders like a bug suit or like a web scanning tool, and it tries to connect to a lot of different URLs which don't exist. And then that's the way, you know, like in HTTP is a self-aware protocol because it's link based. You're clicking on different links. And there is always a referer and there is always a link. Like somebody getting to a web server knows where they are going. If they don't know and they just don't know thousands of times, that means it's an automated tool. So what you do is you look at, so that is the security mindset. What you look at is like 404 not found. Why is this remote IP address requesting a URL which does not exist on the web server? So I tap into HTTP reply event, which is provided by Zeek. Remember, we had new connection established, DNS request. Now we tapped into HTTP reply. Where do you find the HTTP reply? You go into share Zeek base protocols HTTP grep on event, and then see, you will see all the list of HTTP events. HTTP reply is a good one to look into because that's where you will see 404 not found. So I collect origin IP, response IP. If the code, and it actually gives us the code which is of type count, and this code is actually populated by the HTTP analyzer based on looking at the HTTP stream inside your network bytes. So what HTTP event does is that it populates these variables, which now we are going to manipulate on our purposes. So we know the code. So if the code is equals to 405, then you look into the table. Is orange part of the table? No, you set this up and then you do the count and you look at how many times it is. If it touches 100, you generate a notice. pretty simple script. But what this does is that it gets you a very good heuristic to catch web spiders, like somebody who is trying to like reach out to your web server. But there's a lot of things wrong in this script. And this is what I wanted to convey, that, this part is wrong. Like I declared response.h, but this variable is not used in my entire code. So because this variable is not used, why am I declaring it? And this becomes interesting because HTTP reply might run 1,000,000 times a day. So there is 1,000,000 times a variable gets created and destroyed inside Zeek without being used. So don't create something which you don't need to use. Then this is also wrong, because I'm saying is, if the code is 404, do this thing. So like, how many of the HTTP requests replies may have code 404? I would ideally like to think a very simple minority compared to, I would like to think everything is 200 okay, right? So what is happening is that even for 200 okay, we are running this part of the code. So this is unnecessary code which doesn't need to run anymore. So the way you think of it is that, if the code is not 404, return. This is what I care. Like, I only care about this specific type. Otherwise, I don't care about running the following code execution. And then this one is off by one error, because remember, like we already set 1. This has to be 0. If it's not 0, then you are already off by one error here. So this is the right script. You create this thing. You say, here is my origin IP. If the origin is in local nets, we don't care about our IP addresses doing a spider outside our network. But what we care about is remote. So if origin is local, we return. So now we have only distilled all the HTTP replies to remote addresses, like remote IPs who are connecting to us. To do. If code is not 404, return. So every code which is 200, 500, 401, they return back. Then you check here for the membership on the table, you initialize it, you increase it, and you write it. So if you can add a notice to this specific bunch of code, you have a new detection which will detect all the spiders, like somebody who is actually trying to like crawl through your web server requesting URLs which don't exist. But I think I'm going to leave this exercise for people to generate a notice. And I think if you go and look at the code, you might actually see that already. So yeah, if you look at the Zeek scripting from a very high level, think about eliminating all the uninteresting connections first of all. And you know how I learned this? Looking at like very original early code written by Vern and Robin, like they would always do, if not this, return, not this, return. I'm like, why are they doing it? And turns out, like, if you do it million of times, you only care about things which are interesting. Everything uninteresting, return, go out of the code. And it was counterintuitive early, but it makes total sense once you start thinking of it. If the origin IP is in local nets, return, that almost eliminates half of your connections. So assuming that, you have even both ways. Another way to think of this is actually how to write detection. So, a best detection is when your detection lights up like a Christmas tree, where for a given attack, you have multiple notices. So think of the attack as a state machine. So, what attacker does is they scan the system, they find a vulnerable system, they execute an exploit, they download a malware, they misuse it. This is pretty much how most of the attacks happen. They find the system, they exploit it, they download their tools, and so you may actually detect at attack, like you may detect at the scan stage, you may not detect at the exploit stage, you may detect at the download stage, you may detect at the misuse stage. Long ago, back in 2010, I did a work and I crunched a lot of incidents, and vast majority, like 67% of the incidents were caught actually at the misuse stage. And I think 90% of the incidents are prevented at the scan state. If the bad guys cannot find vulnerable systems, they cannot exploit it. It's very hard to detect at the exploit state because we don't know what the exploitation might be. But there's always known things, like attackers are either using curl to download something, or wget, or there's a URL. So, but yeah, here is how things are. So I wrote this heuristic back in 2014, and I love this one, because what happened is I was able to write it at multiple stages of the detection. And this is what you should aim for. Like, where is the attempt happening? Once the attempt is happening, what bad guys were doing were, they were using a user agent string, and they were actually putting bash commands in the user agent, including there was a curl. So as soon as this curl was happening, you would see a domain name lookup. So this domain name lookup would happen. Zeek would see DNS queries and request and reply. So I was able to extract this curl out of the attempt. Then I added it to the DNS analyzer. And then I actually generated this notice that this was in the request and this was in the reply header. And then if there was a curl happening, it would go into the HTTP analyzer. So I can actually tap into the HTTP analyzer, and I see that there was a wget or a curl request happening. And if there was a compromise, then whatever host actually did this request will actually, you can see a URL coming from that host. So here, like a.b will do a DNS lookup, then a.b is going to do a URI lookup, and that's how I will call it. So I wrote it in 2014. This thing, the shell shock thing, worked perfectly well for Apache Struts, because you know what, both were web server related exploits. And in Struts too, all I needed to do was change this part. So once I changed this, I did not even have to change this one, because the bad guys were doing wget on this one, curl on this one, and then here's wget. So they were doing 3 different exploit download. And once I have that, I was able to actually find the URL, pretty much the same heuristics. Then, like in this case, you don't see a DNS lookup. So bad guys were pretty smart to not put a domain, but we would still see a HTTP GET request. So that's what we said, that, a hostile URL seen in a recon attempt, and here is the URL, and generate an action. So think of, when you're writing detections, think of writing detections in this way. So now, like I don't know if I should go into packages or other things, but what I can actually show everybody is actually this one. I think let's walk through this for 5 minutes, and then I will give everyone a breathing room. So this was an exercise which was like, find the password. So let's just show this one. So this exercise, is actually, oh, this is just extension, never mind. So what this exercise does is that, in email, if somebody is sending clear text passwords in email, then generate me a notice saying that there is a password in email. So I just created this module called OUO. There is this message body, which is my new notice type. It's called message body. And then I said, here is the keyword blurb, which is of type pattern. Remember the original data types, there is a pattern. And then I actually put a regular expressions in here, which says that match any character of length 0 up to 90, and then match string password, and then match any character after that. So this is the pattern which I actually created for blurb. And then I also created keyword, which is the password, just the case insensitive password. So what this ends up doing is that, in event mymall data, now this event actually is provided in the mailing list. And you can see this. So you go through the keywords, you actually match the regular expression, you generate an alert. So you match the keyword in the data. So all Zeek does is that Zeek actually uses this pattern, which is the keyword, and it would actually look into the data. It would try to match the regular expressions. If there is a match, I use a function called find all. It's a built-in function inside Zeek. It looks at the data, looks at this, and then gives you the match. If there is a match, it actually like we just figure out like who got that email, and you go through that. So let me run this code. So I sent myself an email. So I sent myself an email. So Ashish Sharma at lbl.gov sent an email to ash at lbl.gov, and this was this email. But in this email, I actually sent this text, which was, here is the secret password, thanks. So Ashish was thanking Ashish, but this was the email. So, you know, this kind of heuristic will actually tell you, and the email went using a mail agent MUT, and it actually came from this IP address. So like all this stuff is told by the SMTP record, but what this additionally does is that it creates a notice which says that Ashish Sharma sent an email to ash at lbl.gov, and the subject of the email was secret information, and it had a password, and the match string was, here is the secret password. So again, what you need to do is think of things in English and then start manipulating and using it. So this is one of those heuristic which doesn't use table, which doesn't use sets. What it uses is the pattern matching. So it primarily uses this thing. So even though I took long time, what I told you is actually just scratching the surface of Zeek. So let's go. We have a few more minutes. So here is the philosophy. Don't ask what Zeek can do for you. Like, you know, what do you want to do, and see if the Zeek is a good tool for it. Most often it is. If it is not, don't waste your time using Zeek. I am telling you that. But I have stuck with it because more often than not, it's a good tool. It's a scalable tool. It lets you write scripts. It lets you manipulate data. It lets you get into pretty core of the protocols. And I would like to thank these people. Like every one of them has been very, very immensely helpful in developing this. I am just the face of actually giving this presentation, but there's a lot of work all of them have done to actually make it happen. I am available anytime. This is my email address. Actually, let me put another one. This one is an easier one because I don't get spammed on this as much as I get here. But yeah, I mean, definitely feel free to ask questions, write code. Even if like 5 people from this training create their own package, I call it successful. So, and I think I would like to say that, you know, I mean, we have used Zeek. You all should do it. It's a fundamental cornerstone of Berkeley Lab security, and it's a good tool actually. And scripting will make it much more powerful for you. Thank you. Any questions, any thoughts, anything? And if not, please at least fill the survey. Critic is good. Be harsh, that's fine. I can take it. But I think what that will help Amber is to actually find somebody else to give this training next year who can actually do a better job or make it much more lucid. But thanks a lot for bearing with me so far.
Ashish, thank you so much for your time. And I don't know that anybody could do it better than you do. People lean in to hear you talk about your experiences and what you've learned. So thank you so much for sharing that with the community once again this year. We do have to update one thing on the survey. So if you can't do it today, I'll send it out again tomorrow. Make sure you join the ZeekWeek 21 Slack channel in the Zeek Slack, because even if you didn't register for day 2 and 3 and you find out that you can make it, the live stream link will be posted in that channel tomorrow. So we look forward to seeing you. Hope you'll join us. And Ashish, I can't say thank you enough to you, to Fatima, to Keith. Also, I'll be notifying 2 people from today's talk who are the recipients of $100 Amazon gift cards. So 2 people from today's session will be notified. And with that, I'll say have a good evening, and I hope that we'll see you all tomorrow.
Thank you. Thank you very much. Thanks, Fatima, Anthony, Christian as well. Thanks, Amber. Bye.